अब होगी। अब हम लोग स्मूथनेस पे ध्यान ठीक है। अब हम लोग लगाते हैं
ना सेंसिटिव है पब्लिक
इसको वाला 5 मिनट में होगा भी, अभी भी नहीं हुआ। हो गया सब मैंने यहाँ भी लगा कुछ चल रहा
हमने भी हट जाते हैं
जरूरी है उनकी बढ़ाइए बाकी सब हो
नहीं वो नहीं चलेगा सीधा लिंक पीडीएफ पे खुला होगा
उससे ना चलेगा। यू आर करेंटली ज्वाइनिंग में
इसका नहीं खोल रहा है वो कर सीधा इस पे जाए ना काम करते हैं कट वाला बैक अकाउंट
ठीक है
सर डिले लिख रहा है अभी
वो होता है वो होगा पटना में हम लोग का टेक्नोलॉजी फास्ट में सिमुलेटर नहीं चलता रहेगा, कसं वेरिफाय करणार अपलोड कर गया सर अभी भी बोलो चला
All the students and participants are requested to take their seats. Bliss was it in that dawn to be alive, but to be young was very heaven. Right are the words of William Wordsworth, though in concern of French Revolution, he meant that being alive at the time of French Revolution was bliss. But it was divine to be young and to take part in that. Same thing is applicable over here, as we are organizing an international conference here at our institute. So with us, we have our dignitaries. On the behalf of the organizing committee, it gives me immense pleasure to welcome you all to the first International Conference on Advanced Trends in Engineering and Emerging Technologies. It is in hybrid mode. Some guests have joined online too, so I welcome them too. This prestigious conference is jointly associated with IIT Patna, NGP 13, Patna 13 and NIT Raipur, bringing together academicians, researchers, industry experts and students to deliberate on cutting-edge advancements, shaping the future of engineering and technology. Now let me have honor to introduce the dignitaries sitting on the dais. We have with us Professor S.K. Verma sir, VC, BEU Patna. Please welcome him with a big round of applause. Now we have with us Professor T.N. Singh sir, Director, IIT Patna. It's a matter of great honor and personal pride for me, sir, to introduce you and invite you here, as for me it is very meaningful that we both share the same alma mater, that is Banaras Hindu University. Welcome you, sir. We have with us Dr. Anand Singh. Sir has not arrived yet, but he will also join us. We have with us Professor Manvendra Pathak, sir, IIT Patna. Please give him a big round of applause. And our patron, principal and secretary of SBTE, Dr. Chandrasekhar Singh sir is here with us. Please welcome him too. And other guests who have joined us, Professor Karali Patra from IIT Patna, Professor Parimal Acharji, Dean, NIT Durgapur, Professor Bhupendra Singh Bhullar sir, BBSB Engineering College, Punjab, Dr. R.K. Sahu sir, NIT Durgapur, Professor Pavan Kumar sir from IIT Dhanbad, Dr. Murshid Imam from IIT Patna, and we have our sponsors also here. Muhammad Sayyid Asadur Rahman he is MD of Margarita Tech. So I request you all to please give them a big round of applause and welcome them. Now, as this is the tradition that before beginning a program, any formal program, we start with lamp lighting. So as a mark of auspicious beginning, we now proceed with the lighting of the ceremonial lamp. Yes, Anand sir is here with us. Sir, please join us here on the dais. Sir, please. Please welcome sir with big round of applause. Yes, now we will proceed for lighting the lamp. I request all the dignitaries for lamp lighting, as this lamp lights, it will definitely bring here in this hall knowledge, wisdom and enlightenment. It will take us from darkness to light. Thank you, sir. Please take your seats. Now, as we are proceeding further in this program, that is international conference, now we'll start with felicitation of the dignitaries. I would like to express our respect and gratitude to the distinguished guests sitting here on the dais with a small token of love. Ma'am and her team members to kindly help. First of all, I will request Roma ma'am to help sir and invite Dr. Shambhu Kumar to present bouquet to Professor S.K. Verma sir, VC BEU Patna. Now I invite Dr. Ashutosh Kumar to present bouquet to Professor T.M. Singh sir, Director IIT Patna. Bouquet, memento and shawl, please. Now I invite Mr. Rohit Kumar to present bouquet, memento and shawl to Dr. Anand Singh sir. Rohit sir to Dr. Anand Singh sir. Now invite Dr. Anushka Pradhan ma'am to present bouquet to Professor Manvendra Pathak sir, IIT Patna. Anushka ma'am remain here to present bouquet to Dr. Chandrasekhar Singh sir, our principal, patron and one of the organizer of this international conference. Bouquet, memento and shawl.
स्पीच के लिए नहीं बुलाना है.
Now invite Mr. Pratyay Amrit sir to present memento and shawl to Professor Parimal Acharji sir. Sir, please welcome you. वहीं पे बोलो, वहीं पे सर नीचे खड़े हैं. I invite Dr. R.N. Singh sir to present bouquet to Professor Bhupendra Singh Bullar sir. Sir, please welcome. Now invite Mr. Daya Shankar sir to present bouquet to R.K. Sahu sir. Mrs. Romarani ma'am, you are invited to present bouquet to Professor Pavan Kumar sir from IIT Dhanbad. Dr. Pooja Kumari ma'am, you are invited to present bouquet to Dr. Murshid Imam sir from IIT Patna. Thank you very much, ma'am. Now we can start the program with this small gesture of showing our gratitude towards the esteemed guest. So the now program begins with program briefing. I would invite Dr. R.K. Sahu sir to kindly come on the dais and give a short introduction about this program, the design, that how this program will take place. Sir, please.
Good morning, all of you. Respected dignitaries on the dais, esteemed guests, fellow academicians, industry colleagues, dear researchers, and enthusiastic students. At the very outset, I would like to express my sincere gratitude to Dr. Ranjita Tiwari, ma'am, NGP Patna, who addressed us and set the tone for this conference. I thank her for her leadership, vision, and continuous support in making this event possible. It is indeed a privilege and honor for me to welcome you all at the International Conference on Advanced Trend in Engineering and Emerging Technologies, ICATEET-2026, jointly organized by IIT Patna, NIT Raipur, and NGP Patna, being held here at NGP Patna on 17th and 18th January. This conference itself is a testimony to what institutional collaboration can achieve. The joint effort of IIT Patna, NIT Raipur, and NGP Patna demonstrate how academic ecosystem can come together for a common goal. I would like to place on record my sincere appreciation for the director, the leadership of the host, as well as supporting institution, the organizing and technical committees, and all keynote speakers, invited experts, and session chairs, and last but not least, participants whose names are detailed in the conference schedule. Your presence adds immense academic values for this particular conference. Friends, we are living in a transformation era. An era where engineering is no longer confined to laboratories and technology is no longer isolated from society. The theme of this conference reflects exactly that transformation. The focus area of this particular conference is AI, artificial intelligence and machine learning, advanced materials, robotics and mechatronics, green energy, digital construction and smart cities, additive manufacturing, and cybersecurity are not independent silos. They are deeply interconnected, shaping how we design, manufacture, protect, and sustain our future. This conference is therefore not just an academic event, it is a convergence platform where ideas meet implementation and research meets industry. One of the key objectives of this conference is to strengthen research industry collaboration. In today's rapidly evolving innovation ecosystem, the success of research can no longer be measured only by the number of publications or citations. True impact is reflected through patents, functional prototypes, startups, technology transfers, and ultimately societal benefits. I strongly believe that laboratory research must travel beyond journals and enter the marketplace. Educators and researchers, our responsibility does not end with generating knowledge. It extends to translating that knowledge into usable, affordable, and scalable technologies that address real-world problems. In this context, collaboration becomes not just desirable but essential. India has exceptional talent spread across IITs, NITs, state universities, and emerging institutions. However, much of our research still happens in isolated pockets. When researchers working within India collaborate across institutions, disciplines, and religions, we can significantly reduce duplication of effort, accelerate innovations, and enhance global competitiveness. Collaboration within India allows us to pool complementary expertise and infrastructure, align research with national priorities, create technologies situated to Indian operating conditions, and present unified, stronger proposal for sponsored and translational research. Platforms like this conference are therefore extremely important. They create opportunities for researchers to connect, correlate, and co-innovate, leading to joint projects, shared facilities, industry engagement, and startups ecosystem rooted in Indian needs. If India is to move from being a consumer of technology to a creator of technology, then collaboration among researchers working within the country, hand in hand with industry, will be the driving force. Allow me to briefly share my personal perspective. In my own research journey, I have fortunate to work in several sponsored projects like DST, ARDB, DRDO, so many agencies. An ongoing project on development of self-healing materials for sensing applications, which falls under the advanced material domain. Experience from these foreign visits, what I learned from these sponsored research projects is something very simple, yet extremely powerful. A good idea, no matter how noble or elegant, creates real impact only when it is engineered for reliability, scalability, and real-world constraints. In the laboratory, we often work under controlled conditions with ideal materials, perfect environments, and unlimited flexibility, but the moment an idea moves outside the lab, it must survive variations, uncertainties, cost pressures, safety requirements, and user expectations. During my work on this particular sensors and more recently on self-healing materials for sensing application, I realized that innovation does not fail because the science is weak. It often fails because the engineering translation is incomplete. What question comes in my mind? Will the material perform consistently over time? Can it be manufactured repeatedly with the same quality? Can it survive real operation condition? Can an industry partner adopt it without redesigning with entire ecosystem? These are the questions that determine whether research remains a publication or become a product. This is why I strongly encourage young researchers, especially UG, PG, and PhD scholars, to start thinking early about application relevance, manufacturability, and industry adoption while designing the experiments. Even at the concept stage, ask yourself, who will use this? Where will be used? What problem does it solve better than existing solution, and what would prevent an industry from adopting it? When research is designed with these questions in mind, the translation from lab to prototype and from prototype to technology and the technology to society becomes much easier or smoother. In today's ecosystem, excellence lies not just in discovering something new, but in making that discovery usable, scalable, and meaningful. That in my view, is the true responsibility of modern engineering research. To the students and young researchers present here around bright minds gathered under one roof, I want to share a thought inspired by Swami Vivekananda. Arise, awake, and stop, not till the goal is reached. But in today's context, I would add, arise with skill, awake with ethics, and move forward with innovation. Do not limit yourself to routine problems. Ask bold questions. Work at the interface of disciplines. Use AI not for automation, but for intelligent decision making. Use material science not just for strength, but for functionality and sustainability. India today is moving decisively towards Atmanirbhar Bharat Industry 4.0 and Sustainable Development Goals conference like this conference plays a crucial role in aligning academic research with national priorities. In conclusion, I am confident that the next 2 days will witness stimulating discussion, meaningful networking, and new collaboration that extend well beyond this conference. I urge all participants to engage actively in technical sessions, interact across disciplines, and explore opportunities for joint research, fundings, and technology development. With these words, I once again welcome you all to this conference and wish the conference every success. Thank you, and I wish you a productive and inspiring conference ahead. Thank you so much.
Thank you, sir. Thank you very much. The way you revised the saying of Swami Vivekananda was very impressive. Thank you. Skill is very important, and this conference is definitely work as a platform for the upcoming researchers. One of our students who passed out diploma from here is also presenting here in this conference. So this is very heartening to see that. And we are doing this for the first time, and definitely it will continue. So thank you very much, sir. Now I would invite ma'am from Dainik Jagran, News 18, sorry. So ma'am will take bite of our principal, sir, a small news bite from principal, sir. Sir, please here. They have to go. They have very short time. That is why they are doing it here. Though it is not.
आज विज्ञान एवं प्रौद्योगिकी विभाग बिहार सरकार के नवीन राष्ट्रीय पॉलिटेक्निक पटना टीम में हमारे मेंटर संस्थान IIT पटना के सहयोग से हम लोग इंटरनेशनल कॉन्फ्रेंस ऑन एडवांस इंजीनियरिंग एंड इमर्जिंग टेक्नोलॉजी, जिसमें हमारे माननीय निदेशक IIT पटना सर डॉक्टर सिंह साहब, हमारे सर डॉक्टर कुमार पटना पाठक साहब, डॉक्टर साहब एवं अन्य जो हमारे सहयोगी जिस इंटरनेशनल कॉन्फ्रेंस में इंस्टीट्यूशन है IIT गुवाहाटी से भी लोग सम्मिलित हुए हैं। तमाम NIT पटना, NIT रायपुर, इंजीनियरिंग कॉलेज पंजाब से भी सब लोग जुड़े हैं। इंटरनेशनल कॉन्फ्रेंस में जो हमारे तमाम बाहर के विदेशों के जो विशेषज्ञ शामिल हुए हैं ऑनलाइन, और इसमें हम लोग इमर्जिंग टेक्नोलॉजी के जितने हमारे विभाग IoT, रोबोटिक्स, जो कि पॉलिटेक्निक के सभी संस्थानों में अभी तक चल रहे थे, IIT पटना के सहयोग से IIT पटना और स्किल डेवलपमेंट में हम लोग कोर्स और इंजीनियरिंग कॉलेज में भी इमर्जिंग टेक्नोलॉजी। तो ये आवश्यक था कि बिहार के विकास में जो पूरा इंफ्रास्ट्रक्चर का विकास हो रहा है, जो हमारे इंजीनियरिंग कॉलेज पॉलिटेक्निक हमारे व्याख्याता उसकी सभी छात्र अवस्था से पाठन का काम करते हैं। तो एक आवश्यक है कि हम अपने सभी विशेषज्ञों को सभी व्याख्याताओं के बीच समागम हो और अंतर्राष्ट्रीय स्तर पर जो इमर्जिंग टेक्नोलॉजी उसमें बिहार आगे बढ़े और IoT, रोबोटिक्स, AI आदि के विषय में विशेषज्ञता हासिल करके, जैसे बिहार के हमारे नौजवान छात्र पूर्व में इतिहासों में भी जब है नालंदा यूनिवर्सिटी था उस समय हम लोग का यहाँ पे बिहार के लोग सबसे ज्ञानी थे। आज हम लोग चाह रहे हैं कि अब उनको इमर्जिंग टेक्नोलॉजी में सबसे ज़्यादा ज्ञान बनाए और 20 वर्ष तक ये वो नए उत्पाद पैदा करें। और जैसा विकसित भारत के लिए डीप लर्निंग की व्यवस्था है, वो डीप लर्निंग में हम लोग नए ट्रेंड में सेमीकंडक्टर में हो, अन्य सब IoT में हो, सारी हम निपुणता हासिल करें, इसलिए अंतर्राष्ट्रीय स्तर पर कॉन्फ्रेंस कर हम लोग अपने स्तर को बढ़ाते हैं और ये शोकेसिंग कर रहे हैं। बिहार में जो हमारे टीचर्स आए हैं, IIT पटना है, बिहार इंजीनियरिंग यूनिवर्सिटी में, वो एक विश्व स्तरीय प्लेटफॉर्म पर कंप्लीट करते हैं और इसमें आप लोग
Thank you, ma'am, and thank you everyone for having patience. So now we proceed further in this program. I would invite our principal, Dr. Chandrasekhar Singh sir, to present welcome note. Sir, please.
Good morning, everybody. Respected Dr. T.N. Singh sir, Director IIT Patna. Respected our VC sir, Dr. S.K. Burma, Bihar Engineering University. Dr. Pathak, HOD, Patna. Dr. Anant Kumar, Joint Director, Science, cum Project Director, Taramandal, and others dignitary from all the across India and abroad who joined this international conference online and offline. I welcome you all with the core of my heart to the institution, to the new government Polytechnic Patna 13 campus for coming in international conference on advanced trends in engineering and emerging technologies. As we know, since the 2047, the target for the Viksit Bharat, we have designed this deep learning, and that deep learning too in emerging technology. So it is the requirement for today to go inside the deep learning of emerging technology, do the research at par with the international standard. And that's why the conference has been organized with the help of IIT Patna. I am very grateful to our director sir, Dr. T.N. Singh sir. हमें याद है वो दिन जब 7 निश्चय 2 में हमारे अपेक्स बडी ने बिहार सरकार में ये निर्णय लिया था कि IIT पटना अब बिहार में आ गया है, तो इसके सहयोग से पॉलिटेक्निक शिक्षा में और तकनीकी शिक्षा में बहुआयामी समागम होना चाहिए, जिससे उनके एक्सपर्टाइज को हेल्प ले। और आज वो दिन है जो IIT पटना के सौजन्य से, उनके सहयोग से ये इंटरनेशनल कॉन्फ्रेंस पहली बार बिहार में पॉलिटेक्निक में संभव हो सका है। सर, मेरा बहुत बहुत धन्यवाद, कोटिशः धन्यवाद। पॉलिटेक्निक एजुकेशन में अक्सर लोग जो स्किल डेवलपमेंट में जो थ्योरी पार्ट को छोड़ते, इमर्जिंग टेक्नोलॉजी को छोड़ते थे, उसको हम लोगों ने सर आपके सहयोग से आगे बढ़ाया है। और पिछले 5 वर्षों से हमारा जो सेंटर ऑफ एक्सेलेंस चल रहा है, जो इमर्जिंग टेक्नोलॉजी में, वो 3D प्रिंटिंग में हो, रोबोटिक्स में हो, मशीन लर्निंग में हो, AI में, IoT में, वो सर IIT पटना के सहयोग से चल रहा है। हमारे पॉलिटेक्निक के स्टूडेंट्स ट्रेंड हो रहे हैं और हमारे व्याख्यातागण प्रशिक्षित हो रहे हैं, और यही वो कारण है कि इमर्जिंग टेक्नोलॉजी में अपने आप को वो सक्षम किए हैं इंटरनेशनल कॉन्फ्रेंस करने के लिए। मैं उन सब तमाम विशेषज्ञों को, अपने व्याख्याता को, एक्सपर्ट को धन्यवाद देना चाहता हूँ। ये पॉलिटेक्निक के परिसर में आपने इंटरनेशनल कॉन्फ्रेंस की जो सुविधाएं हैं उसको थोड़ा असहज महसूस करते होंगे, थोड़ा कम महसूस करते हो, उसके लिए हमें माफ़ी। लेकिन हम संकल्पित है कि हम बिहार को इतना आगे ले जाएंगे कि उस इंटरनेशनल स्टैंडर्ड पे भी आ सकते हैं, उस इंफ्रास्ट्रक्चर में आ सकते हैं। जब अगला इंटरनेशनल कॉन्फ्रेंस हम लोग करें तो बड़े शानदार तरीका से करे और उसमें पूरे कॉर्पोरेट व्यवस्था हो। आज ये आयोजन हम लोग किसी होटल में भी अच्छी जगह कर सकते थे, लेकिन हमने पॉलिटेक्निक का नींव इसलिए डाला कि हमारे स्टूडेंट्स के जेएन में आए कि हमारे इंस्टीट्यूशंस में भी इंटरनेशनल कॉन्फ्रेंस होते हैं। हमारे यहाँ भी विश्व के ख्याति प्राप्त जो विशेषज्ञ हैं वो भी हमारे संस्थान से जुड़े हैं, ताकि उनका हौसला अफजाई हो और वही एक दिन विश्व स्तर पर हमारे इंडिया का, हमारे भारत का नाम रोशन कर सके। हमें उम्मीद है कि इन 2 दिवस में जितने भी टेक्निकल सेशन होंगे उन सभी सेशन में जो विशेषज्ञ हैं, जो चेयरपर्सन है, जो एक्सपर्टाइज है, जिनके पेपर पब्लिकेशंस होने हैं, प्रेजेंट होने हैं, उन्हें कोई असुविधा नहीं होगी। और अगर कोई असुविधा होती है तो वो दे कैन डायरेक्टली कनेक्ट विद द ऑर्गेनाइजेशन टीम, और मैं भी 24/7 उनके लिए अवेलेबल हो। दे कैन contact me directly. Thank you.
Thank you very much, sir. Your vision and your dedication towards this technical education is really exemplary. It is your dedication that it has brought the prestigious NBA for us. Our 3 programs, civil engineering, electronics engineering, and mechanical engineering, these programs have been accredited by this apex body, NBA. So thank you very much, sir. Now in this series, I would invite Muhammad Sayyid Asadur Rahman, MD, Margarita Tech. Sir will deliver here something. Sir, please come here.
Good morning, all of you. Good morning, sir. Respected Director IIT Patna, Director NIT Raipur, and all the dignitaries, our VC sir, and all the dignitaries present over here. And I also thank you, all of you, like the participants who are participating the conference over here. We Margarita Tech, actually we are like the sponsor over here, and what we do is basically we train peoples on the emerging technologies. So first of all, we want to show a small gratitude from our side to the respected guests over here. So please allow me the time. So please. So small gift from our side. Thank you. Okay, we will meet again. So right now, I won't take much time. We will meet again.
Thank you very much, sir, for this beautiful gesture. Now in the series, I would invite Dr. Anand Singh, sir, to say a few words on this effort of ours. Sir, please.
A very good morning. आज इस इमर्जिंग टेक्नोलॉजी इंटरनेशनल कॉन्फ्रेंस के अवसर पर उपस्थित हमारे वाइस चांसलर डॉक्टर एस.के. वर्मा साहब, हमारे आईआईटी के डायरेक्टर प्रोफेसर टी.एन. सिंह साहब, एनआईटी आईआईटी से आए हुए एक्सपर्ट्स, हमारे विद्वत शिक्षकगण, हमारे स्टूडेंट, डियर स्टूडेंट्स, हमारे जो बहुआयामी और बहु प्रतिभा के धनी डॉक्टर चंद्रशेखर सिंह जी, जो प्रिंसिपल हैं पॉलिटेक्निक पटना 13 के, तो सबसे पहले मैं उन्हें धन्यवाद और आभार व्यक्त करता हूं कि पॉलिटेक्निक संस्थान से उन्होंने एक जो प्रयास शुरू किया है, जो एक नेतृत्व प्रदान करने का, कि पॉलिटेक्निक संस्थान के पास ये दृष्टिकोण हो सकता है कि हम अंतर्राष्ट्रीय स्तर का सेमिनार संगोष्ठी आयोजित कर सकें। इसके लिए सर आपको बहुत बहुत धन्यवाद, और आपने मुझे यहाँ पर बोलने का कुछ अवसर दिया, इसके लिए बहुत बहुत आभार।
आज इस कार्यक्रम को और एक जो सीखने वाली बात इनसे है, जो मैं बराबर सीखा करता हूं, कि कैसे किसी इंसिडेंट को अपॉर्चुनिटी में बदल लिया जाए। मूलतः आज मेरा प्रोग्राम था ये कि मैंने उनसे पूछा था कि आईआईटी डायरेक्टर साहब का प्रोग्राम आज मुझे पता चला पटना आने का था, तो मैंने इनसे कहा कि एक मुझे बोर्ड ऑफ गवर्नर जो साइंस सिटी है उसका उस पर वो मेंबर हैं, उनसे मुझे हस्ताक्षर लेने हैं। इन्होंने कहा ये हस्ताक्षर करा देते हैं, लेकिन सर मुझे तुरंत मंच पर बैठा करके यहाँ बोलने के लिए आमंत्रित कर। तो सर ये सब स्किल जो है, लाइफ स्किल सर आपसे सीखने लायक। तो चलिए, खैर ये जो प्रोग्राम है, मैं राज्य सरकार की ओर मैं आपका ध्यान आकृष्ट करता हूँ कि राज्य सरकार की क्या अपेक्षाएं हैं। तो राज्य सरकार की अपेक्षाएं हैं कि जैसा कि राज्य सरकार ने 7 निश्चय 1 कार्यक्रम के अंतर्गत सभी जिला में इंजीनियरिंग कॉलेज और पॉलिटेक्निक संस्थान की स्थापना की गई। 7 निश्चय 2 के अंतर्गत सेंटर ऑफ एक्सेलेंस हर एक पॉलिटेक्निक में इमर्जिंग टेक्नोलॉजी और जो रेलिवेंट इंडस्ट्री के लिए हो उसके लिए सेंटर ऑफ एक्सेलेंस की स्थापना की जाए। उसी क्रम में इंजीनियरिंग एजुकेशन को एक्सेलेंस लाने के लिए अलग से यूनिवर्सिटी की स्थापना की जाए। तो 7 निश्चय 2 हो चुका, 7 निश्चय 1 हो चुका, सारे इंजीनियरिंग कॉलेज खुल गए, पॉलिटेक्निक खुल गए, यूनिवर्सिटी खुल गए। और एक और मैं धन्यवाद दे दूं चंद्रशेखर जी को कि पॉलिटेक्निक पहला संस्थान है जिसने न केवल अपना एक्रेडिटेशन संस्थान का कराया, बल्कि सारे पॉलिटेक्निक और इंजीनियरिंग में ये अपना नेतृत्व प्रदान कर रहे हैं कि सारे कॉलेज का एक्रेडिटेशन भी हो जाए। सर इसके लिए भी आपको बहुत बहुत धन्यवाद। अब आप सबको बता दें, आप पढ़े भी होंगे, 7 निश्चय 3 अब आ गया है। नई सरकार आई है तो 7 निश्चय 3 आ गया है। 7 निश्चय 3 का मैंडेट अब ये आ गया। देखिए राज्य सरकार की पहल जो कितनी सिस्टमेटिक ढंग से और चरणबद्ध तरीके से हुई है। पहला कार्यक्रम था जिसमें आधारभूत संरचना का विकास किया जाना था। दूसरा कार्यक्रम हुआ मतलब क्वांटिटेटिव एक्सपेंशन की बात थी। दूसरा जो 7 निश्चय 2 आया उसमें क्वालिटेटिव एक्सपेंशन की बात हुई, जिसमें ये आपका यूनिवर्सिटी सेंटर ऑफ एक्सेलेंस खुला। अब सबको पता है कि किसी भी राज्य के विकास में इंडस्ट्रीज या कुछ भी आप सोचें, तो जब तक हमारे पास हाईली स्किल्ड ट्रेंड मैन पावर नहीं होंगे, जो एग्जाम्पल है कर्नाटका बेंगलोर, सारी इंडस्ट्री बेंगलोर में इसलिए शिफ्ट की कि वहां पर हर स्किल्ड मैन पावर इजिली अवेलेबल थी। तो आज राज्य सरकार ने इसकी व्यवस्था कर दी कि हम टेक्निकल मैन पावर अब मेरे राज्य में अवेलेबल है, और यह राज्य पहला राज्य होगा जहां पर गवर्नमेंट इंजीनियरिंग कॉलेजेस में जितने इमर्जिंग टेक्नोलॉजी जो इंडस्ट्री 4 की बात आप करते हैं, चाहे वो आर्टिफिशियल इंटेलिजेंस की बात करें, मशीन लर्निंग की बात करें, साइबर सिक्योरिटी की बात करें, डेटा साइंस की बात करें, क्लाउड कंप्यूटिंग की बात करें, इन सारे कोर्सेज में आज बीटेक की पढ़ाई हमारे इंजीनियरिंग कॉलेजेस में हो रही है। और उससे रिलेटेड सेंटर ऑफ एक्सेलेंस हमारे सारे पॉलिटेक्निक में आईआईटी के सहयोग से स्थापित किया जा चुका है। तो हम ना केवल डिग्री लेवल की बात कर रहे हैं, बल्कि डिप्लोमा लेवल को भी हम लोगों ने वेल इक्विप किया है, और वेल इक्विप किया है उसको अग्रगामी सोच को रखते हुए कि आने वाली जो टेक्नोलॉजी है ये पूरी दुनिया को बदलने वाली है, और सारी टेक्नोलॉजी हमारी एआई पर आधारित है। और जब इतना राज्य सरकार विकसित कर गया तो 7 निश्चय 3 में अब कार्यक्रम आ गया है कि अब इस राज्य को एआई हब बनाना है, आर्टिफिशियल इंटेलिजेंस हब बनाना है, और पूरे ईस्टर्न जोन का, इंडिया का पूरे ईस्टर्न जोन का सेमीकंडक्टर मैन्युफैक्चरिंग हब भी बनाना है। तो आखिर 7 निश्चय 3 का ये कार्य जो अभी आया है 7 निश्चय 3, आखिर वो किसके भरोसे आया है? वो इसी के भरोसे आया है कि राज्य सरकार ने आज सारे जिला में इंजीनियरिंग कॉलेज खोल करके इन सारे टेक्नोलॉजी में बीटेक एमटेक की पढ़ाई शुरू करके डिप्लोमा में सेंटर ऑफ एक्सेलेंस की स्थापना करके अब राज्य सरकार आश्वस्त है कि हम आर्टिफिशियल इंटेलिजेंस जो हब बनाएंगे उसके लिए हमको कहीं बाहर से स्किल्ड मैन पावर की जरूरत नहीं पड़ेगी। हमारे पॉलिटेक्निक से इंजीनियरिंग कॉलेजेस में इतने दक्ष शिक्षक आ गए हैं जो आईआईटी एनआईटी से पीएचडी करके आ गए हैं। राज्य सरकार को पता है कि कितने हाईली क्वालिफाइड ये टीचर्स को, फैकल्टीज को हमने यहाँ पर अपॉइंट किया हुआ है, और निश्चित रूप से जब हमारे फैकल्टी इतने हाईली क्वालिफाइड हैं तो निश्चित रूप से हमारे छात्र भी उस तरह से स्किल्ड होंगे। और इसी भरोसे पर राज्य सरकार के द्वारा ये निर्णय लिया गया है। और आज जो एक कार्यक्रम मैंने देखा, मुझे नहीं पता था कि विषय क्या है, मैं तो अभी आकर के मैंने पढ़ा कि आखिर ये किस विषय पर है, तो मुझे बहुत अच्छा लगा कि राज्य सरकार के 7 निश्चय 3 के सपने को जो अगर साकार करना है तो शुरुआत जो चंद्रशेखर जी ने पॉलिटेक्निक जैसे संस्थान से की है, ये बहुत बड़ी बात है। ये अपनी सोच, विजन एंड थॉट, इसी को कहते हैं। मैं बताना चाहता हूं कि एक छोटी सी छोटी नदी भी अगर होती है तो उसके पास अपना एक विजन होता है कि मुझे एक महासागर महासमंदर में जाके मिलना है। वो ये नहीं देखता है कि मेरा अस्तित्व तो छोटा है, उसका विजन है कि मैं जाऊं समुद्र में ही जाकर मुझे मिलना है, जहां पर और जा करके वो मिलना इसलिए है कि जब तक नदियां नहीं मिलेंगी तब तक जो महासागर और सागर के जो गुण हैं वो उनमें नहीं आ पाएगा। जो लहरें उठती हैं, जो भी उसके गुण हैं, वो इसलिए आती हैं कि सारी नदियां, छोटी छोटी नदियों का कंट्रीब्यूशन उसमें होता है, तब जाकर सागर और महासागर अपना जो अलग गुण है वो उत्पन्न हो पाता है। तो और इसीलिए कहा जाता है कि नदियां जब उस बड़े विजन को लेकर के चलती हैं तो कहा जाता है कि वो मशविरा नहीं करती हैं समुद्र में जाने के रास्ता के लिए, किसी से पूछती नहीं है कि मैं किस रास्ते जाऊं। वो अपना रास्ता खुद बनाते हुए जाकर के जो अपना विजन है, जो अपना लक्ष्य है, वहां जाकर के मिल जाती हैं। तो मैं पॉलिटेक्निक के लिए मैं यही कहता हूं कि इनका जो विजन है कि ठीक है मैं पॉलिटेक्निक हूं लेकिन मेरा विजन बड़ा है, मुझे जाकर के सागर और महासागर में मिलना है। इसलिए चंद्रशेखर जी अपना रास्ता खुद बनाते हैं, अपना विजन खुद तय करते हैं। और मुझे उम्मीद है कि अगर इस तरह के हमारे प्राचार्य अगर और हो जाएं तो हम जो 2047 में एक विकसित भारत देखने का लक्ष्य जो देख रहे हैं, हमें याद है कि बिहार की इतनी पोटेंशियल है कि जब 7 निश्चय 1 में लक्ष्य रखा गया था कि 2023 तक सारे डिस्ट्रिक्ट में इंजीनियरिंग कॉलेज खोलेंगे, 2023 तक का लक्ष्य रखा गया था, लेकिन हम लोगों ने उसको मिशन मोड में लिया और 2021 तक आते आते सारे डिस्ट्रिक्ट में इंजीनियरिंग कॉलेज खोल दिया गया। और ये हमेशा कहा जाता है कि जो हम विजन, शायद ही कभी ऐसा प्रोजेक्ट होता हो कि जो प्रोजेक्ट का टाइम पीरियड हो उसको आगे नहीं बढ़ाया जाता। लेकिन जब सारे इंजीनियरिंग कॉलेज खोलने थे 2 साल पहले, राज्य सरकार ने वो 2 साल पहले ही अपना टारगेट पूरा कर लिया। मुझे उम्मीद है कि इस तरह के कार्यक्रम से जो आपने एक रास्ता दिखाया है, निश्चित रूप से जो भारत को विकसित करने का 2047 तक है, अगर ऐसे संस्थान बिहार में 5-10 हो जाएं तो 47 नहीं हो करके वो 37 हो सकता है। मुझे पूरा विश्वास है। जिस तरह से चल रहे हैं, मैं ज़्यादा समय नहीं लूँगा, बहुत सारे एक्सपर्ट्स आए हैं। मुझे उम्मीद है कि इस कार्यक्रम का एक दूरगामी असर पड़ेगा, खासकर 7 निश्चय 3 कार्यक्रम का जो राज्य सरकार का है उसके क्रियान्वयन में। मैं IIT डायरेक्टर के पटना साहब को चलते चलते मैं थोड़ा समय ले लूँ कि अगर कुछ भी हम करने चलते हैं, हमसे रोज पूछता है कि कैसे होगा, तो हम लोग यही कहते हैं अरे IIT पटना है ना, कर लेंगे। जैसे मैं एक छोटा उदाहरण, मैं ही कल AICTE से मैंने एक एप्लीकेशन दे रखा है, इस बार बीटेक इन मैथमेटिक्स एंड कंप्यूटर ब्रांच हम खोलने जा रहे हैं वैशाली इंजीनियरिंग कॉलेज में, क्योंकि मैं वहाँ का भी प्रिंसिपल हूँ। तो AICTE वाले ने पूछा कि आप कैसे इस सब्जेक्ट आपने कैसे चुना। हमने कहा हमारे बिहार में IIT पटना में मैथमेटिक्स एंड कंप्यूटिंग की पढ़ाई हो रही है और वहाँ के डायरेक्टर साहब से मेरी बात हो गई है कि जैसे ही ये खुलेगा आपसे MOU कर करके और जो भी टीचिंग से लेकर के जो आपको असिस्टेंस होगा तो आप जैसे ही अप्रूवल देंगे वी शैल हैव एन MOU विथ IIT। सर मैंने आपके भरोसे पर मैंने बिना पूछे हुए कह दिया, तो मुझे विश्वास है कि मुझे अप्रूवल मिलेगा तो आप निश्चित रूप से मेरे साथ MOU कर लेंगे। मैंने ICT को बता दिया है सर। उसी तरह हमें एमटेक तारामंडल में खोलना था, लोग कहा कि तारामंडल एमटेक तारामंडल में कैसे खुलेगा, तो मैंने कहा मेरे पास मोस्ट डायनामिक वाइस चांसलर बिहारी यूनिवर्सिटी है ना, खुल जाएगा मेरा। और वहाँ भी मैंने खोल लिया बिहारी यूनिवर्सिटी के सहयोग से। तारामंडल पटना में एमटेक इंडिया का पहला तारामंडल होगा जहाँ पर एमटेक की पढ़ाई चल रही है। तो ऐसे ऐसे लोग हमारे साथ हैं। तो भी और चंद्रशेखर जी जैसे नेतृत्व करने वाले प्रिंसिपल हैं, तो निश्चित रूप से हम सारे लक्ष्य को समय से बहुत पहले 10 साल पहले पूरा कर लेंगे। अंत में इस कार्यक्रम की सफलता के लिए इस कार्यक्रम के दूरगामी परिणाम होंगे। निश्चित रूप से बिहार के 7 निश्चय 3 में आप सबका सहयोग प्राप्त होगा। धन्यवाद। थैंक यू वेरी मच।
Thank you, sir. Your words always inspires us. You always come here in all our celebration. You are here with us. And thank you for making us aware of the policies of the government and mapping our facilities with them. Now we proceed further and I invite Professor T.N. Singh, Sir, Director, IIT Patna, here to say a few words. Sir, please, you are welcome.
Good morning to all of you. Namaskar. Respected Honorable Vice Chancellor of Bihar Engineering University, Professor S.K. Verma ji. Very respected Joint Director Dr. Anant Kumar ji, very vibrant, dynamic director, public principal of this institute, Dr. Chandrasekhar Singh ji, my colleague, Professor M. Pathak, very respected faculty member from various IIT, NITs, technical institutions, friends, and my dear students. Indeed, it is a great pleasure to participate in such a excellent seminar organized by mainly NGP Patna 13 under the dynamic leadership of its principal, Dr. Chandrasekhar Singh ji. He is not known to me only because he is a principal of this place, but this place is very historical because IIT Patna originates from this place. So they have given the place, hosted us for a few years to germinate and grow, and then we have our own campus, IIT Patna. So our umbilical cords are connected with this institution and it will be remain there. There is no doubt about it. This International Conference on Advanced Trends, Engineering and Emerging Technology is very timely, very appropriate in terms that you have seen that yesterday we have celebrated 10 years of innovation and incubation. It is not 10 years. Why 10 years? Because innovation is inculcated in everybody's minds. Curiosity is always at the earliest stage. But why this 10 year is so important? Because it has accelerated the thinking process. It has accelerated the acceptability, and it has smoothened the path of roughness to engage an individual or as well as a group to come out with that. So it makes us impossible to possible, and that is the reason why Honorable Prime Minister has yesterday addressed the nation from Bharat Mandapam about the innovation 10th year and the continuity. As Dr. Anandji has explained that 7 Nischay of Bihar Sarkar, the first one is same as the government of India has done, that first create the path to connect the people in a better manner, better fashion, with aid of tools and technology available with us. Now anybody can commute from any place without much hurdles in a state of Bihar, like other states also. So connectivity is not at all a problem. Water is not at all a problem. Electricity is not at all a problem. So these are the basic ingredients to think about anything new. And it is a common human being, whether you are a scientist or you are simply you are making a house, you think about all these three. So in the first 7 Nischay, they have created all these things before time, and thanks to the officers and administrator of Bihar government who has done very remarkable work. Now, second phase, the greatest strength in the world is the knowledge. You want to rule the world, it is all based on the knowledge, and knowledge is nothing but transfer into the technology. And technology required different kinds of the tools and technique, different kind of material to survive. That is very, very important. So, basic thing is human resource. The human resource has been created by creating a standard polytechnic system in all, having the modern lab like EV, AI, IoT, 3D, robotics, transformer, manufacturing and repairing. No polytechnic can say they are not connected it out of this 5-6 domain, either as a spokes or hub. And thanks to Dr. Chandrasekharji, Anandji and the Department of Science and Technology and Climate Change Government of Bihar, who has trusted IIT Patna to facilitate and help to create this. Now the quality of lab is on the not debate on this Bihar state, but it is debated at the level of central government also, that how such kind of labs has been created within a shorter time. Why not other states should replicate it? And constantly I am getting letter from government of Madhya Pradesh, government of Chhattisgarh, government of Jharkhand, that can IIT Patna spare the same zeal and spirit to transform this kind of this lab in our polytechnic. So this is we talk about the quality. Never compromise with the quality. So we have made this possible with the help of all principal, all employee. We have we have the refresher courses to make them update with the help of our faculty colleagues sitting here, this side. They are the part of this training of this in their respective domain. Now third one, what he says that we have to go for. Now all gradients are ready. So try to encash it in terms of making this AI hub, cheap manufacturing, semiconductor, and many other emerging areas. Now we have the skill, and this skill has been proven by our student. We have invited 10 to 15 companies in a day, and you can imagine more than 600 to 700 students have got job in job fair. And these companies are from the other places, and they told their skill and understanding about the problem of these students are remarkable. Maybe they are not able to very fluent English, but they conceive the idea, they explain in their own language, and we are very much impressed, and students are getting. Today, if you have seen in the morning newspaper, 150 students have again selected in one company. So we are not only trying to hold handing with this only to providing and helping to establish the lab, but also we are trying to see that our skilled student should get exposure in the national and international company. Now how to make these two dreams as explained by Dr. Anandji about the AI hub and semiconductor. It's very, very crucial, because once you are talking about this final product, we forgot to think about the background knowledge, background process. If you want to semiconductor, you need a certain material which has been used on that one. One is this raw material, another is the human material. Human material we can create, and they will create the material for the future. So I think we will not work in isolation, we can work in association. And then we can resolve the problem of society. Because people say if you want to go far, then go together. But if you want to go fast, you can go alone. So we have to work together for the development of this state as a whole and country at this global level. So engineering is the backbone of all kind of innovation. We have to inbuild and inculcate a very critical thinking among the students, pose serious questions in the class as well as at any evaluation level. Because from my understanding, giving answer is easier than preparing a hard question. It required a lot of thinking. So give this project which has a longer impact in terms of the innovation. It can go to this level of scaling. Then only you can. Now, Anandji has forgot to tell another thing. This Science and Technology Department has also identified 4 spokes with the help of Hub of IC, Incubation Center of IIT Patna. 4 engineering colleges we are going to take up and create a similar kind of atmosphere where students can come, express their idea, discuss their idea, deliberate that idea, and then decide whether they can go for the product development or not. This path is very clear or not, understanding is very clear or not. So this is another value addition in terms of getting this kind of the dream. He talked about this mission and vision. Very early people have said if you have a clear vision, then success will be 25% possible. If you have clear mission and vision, then possibility of success is 50%. But if you have a very clear in your mind about action, with the vision and action, then nobody can stop. Now, the third Nishchay has given us all these 3. Now, we can convert these percentage into the reality and make a Bihar a proud state, not in terms of remembering only history, but talking in the present scenario that it was great, now it is great. So that kind of feeling each and every individual who has associated with that will be always there. Whatever Anandji said about this AICT people has asked me. I have not discussed it with Dr. Ramlu, who is doing the accreditation and giving the permission. He asked me, and he is known to me from last 20 years as a scientist of the Nagpur mining unit. Now he is looking at ICT. He asked, is it possible? I think everything is possible, whatever he has said. If he has said, and he has believed faith on IIT Patna, we will fulfill all promise into the action. I am very happy that Tara Mandal, where people have the different perspective about the thinking about the Tara Mandal. But I think it is not surprising to this other people who are not known about this, that MTech Geoinformatics. Is it correct? MTech Geoinformatics has been started in Taramandal. You can see the forward thinking of the state and those who are in the helm of affairs. Geoinformatics, I don't think in Bihar, any university, any colleges have this kind of this work. Nearby a state, only the Central University Ranchi having this course only. How it is important and why they have kept everything? Because people wants live demonstration, live location, where geoinformatics in all kind of traffic management, accident management, crowd management, everywhere geoinformatics play a very, very crucial role. And if our students, they get trained in master degree in this particular subject, I think many other university will start opening, then there is no dearth of human power. At least you have the technical people are available who can take away much forward these things. Research is a continuous process, and I like the example of river you have given. So every scientist should learn from the river, whatever the adverse condition, it continue to flow either slow rate or high rate with the high tides or low tides, having the disturbed wave or undisturbed wave, but the very basic nature is continuity. So research is not by passion. You should have a commitment with that. And once you have commitment and devotion, then nobody can stop you with the breakthrough. There are many outstanding problems in the society which needs some kind of scientific solution. Once we call scientific solution, it should be technologically proven, economically viable, and long sustainability. That kind of solution is still awaited in many areas. Look at this one of the problem other than the AI and the semiconductor. If somebody can take a mission that how plastic can be used for other purposes, because this is the one thing which is bothering across this India, that in every mohalla, every day, 1,000 at least pocket of plastic. Because even the 100 people are purchasing from one fellow vegetable, average 2 to 3 polythene packets they are carrying and bringing out the home. So thousands and thousands in the 100 will. And what we are doing it, how to reduce it. So certain things we can learn from our ancestors also. That is the reason I told, do not forget about the past glory, but don't try to sparking based on the only past glory. Learning is very, very important. So how a certain change in the habit can reduce it. So just learn from the habit created by Sudha Murthy ji, that reuse, recycle will be important. But refuse is also one of the things. Rejection is also one of the things which can minimize the burden on the climate and the society as a whole. We should not use anything excessive. Even in water, it is very precious. If you remember when Atal Bihari Vajpayee ji, when she took first time as a Prime Minister of India for a very, very short duration, his first speech was, that time, then the Third World War will be going for liquid and water. And many people surprised what he is speaking, and somebody say, ye kabhi hai, kuch aisa man mein aaya hoga. But now you see the reality. The water is so much important. Can we try to reduce it? And somebody can work on this. that we can put some sensor and then they can devise a tool by which we need that how much water required during a demand of water, because every time we have the habit in India, we are offering water excessive. And people are taking only 10 ml, 20 ml and then 70 ml is wasted away because. So these kind of things also one can work to how to reduce these natural resources. For the sustainability, for the viability and for the protection of a global earth as a system. Because climate change is very, very important. So any research, if you take up, try to think that how it is environmentally sustainable, conducive to the environment, not much contributing destruction in the environment, because carbon is increasing and the carbon is increasing in atmosphere, and we can see that slowly shifting. Whenever we have the extreme cold, extreme hot, extreme rain, localized rain, Patna heavy raining, Beta having the sunshine. So these kind of things are happening because of this. Many of the cities are not receiving a good rain because they become the hot spot due to the excessive emission of the carbon because of various activity. I cannot blame any industry or any various activity. So around the city, maybe you have the good rain, but within the city, no rain. So these are the things where our youngsters would work. Of course, the AI is a very powerful tool. But my only request to all of you, AI is not solution of everything. AI is a good servant, but not a very bad master. Don't fully depend upon this AI without putting your mind. Because today we see applications are coming on ChatGPT. Students lost the creativity of writing the application. The older people here and some of us in the front row, they know. We have been taught to write how to application for the leave. But now students are writing without understanding what they are writing. And ChatGPT is straightway given to the faculty member or the concerned head of department without going through it. And sometimes it comes the thanks for using ChatGPT is coming on the first line. So use this AI, but very carefully, very sensitively. As I told you, a good servant, obedient servant. Where you want to do and use this AI for the advancement of your research, authentication of data, reproducibility of data is okay. But everywhere it will not applied and not required. Because it is a helping tool and used like that. But let us see that creativity among the students and learner should not be controlled by ChatGPT. Research paper can be created with ChatGPT. But when we can allow a student to learn to how to write this research paper, methodology, learning will coming from the practicing, and practice makes the perfect man. So I remember this quote of Ratan Tata ji. He told, nobody can destroy iron except the rust. So ChatGPT should be used very cautiously, otherwise it will become a rust to destroy the iron mind of a innovator. So these are the things, and I'm sure I have seen the list of very learned speakers as well as the faculty members. They have the different topics about the material development, the industry to level T4 to T5 to City 6 All kind of things will be going to be discussed. And I request and urge the students that participate in more number to see the work done by the researchers across NIT, IIT, different engineering colleges with their hard work, their experience, and maybe out of that something click on your mind that this man has limitation to have done this much. I can take up forward these things, or you can give a better idea that this can be done in this way. I think that will be the great contribution. And that is the reason people say that if you want to become a learner, become a lifelong student. Never become a teacher. Because the moment you think that now you are a master, then you have gone. So ups and downs is the nature. Always it happens. And if there is no ups and downs, then life is also danger. Because the cardiogram, if it is straight, then it is very difficult to think about the person. So in life also you have this ups and downs, hard day and soft day, good day or bad day. But never compromise with your continuity of working towards with this positive mind. Giving a greater goal, the larger vision, that will be very, very important. For larger vision, be careful with your all sense of sensing mechanism given by the God. Always keep your eye open, proper things hearing, proper thinking, that is required and makes you a rememberable. A very short, a very famous example I can quote and then I can complete. People think about the careful, how one can be careful that makes a remarkable day. April fall, since inception of this earth, down. But one person has seen it very carefully, discussed in his mind, deliberated his mind, and then decided what is the reason of that. And that fellow is remembered till today, no alternative. This is Newton gravity law. Like all the innovations, having the careful observation is very, very much required. Do not try to see what is going to be fail. Even failure gives a possibility of success in the life. So I request my young researchers that always be ready to face hard time and tough questions, and keep balance your hard head and hands together and work for the progress of this nation. I am extremely grateful to the principal of this institute for his kind words, and organizers who has given me this opportunity to express my personal view on this topic. Thank you very much. I wish you all the best.
I have to adjust it according to my height. Thank you very much, sir. Definitely we will flow like river. And the things which you told us about the technological advancement towards sustainable development, what engineers can do and what our researchers will do in future, they will definitely orient their research towards this. And in the series, now next I would invite Professor S.K. Verma sir, VCBU Patna, to say a few words in this inaugural session. Sir, please, you are welcome here.
Honorable Director IIT Patna, Professor T.N. Singh Sahab, respected Professor Anant Babu, Joint Director DSTT Bihar, respected Professor Manvendra Pathak Sahab from IIT Patna, and organizer of this international conference and principal of this institute, New Government Polytechnic, Patna 13, Dr. Chandrasekhar Singh Sahab, other dignitaries present in this hall, researchers, delegates, students, representatives from electronic and print media, ladies and gentlemen, आप सभी को मेरा सप्रेम नमस्कार। सर्वप्रथम मैं इस इंटरनेशनल कॉन्फ्रेंस के आयोजक की पूरी टीम एवं विशेषकर प्रोफेसर चंद्रशेखर सिंह साहब को धन्यवाद देना चाहता हूं कि जिन्होंने मुझे इस कार्यक्रम में शामिल होने का मौका दिया एवं आप ऐसे यंग डायनामिक रिसर्चर्स के साथ रूबरू होने का मौका मिला। जैसा कि अभी आपको बताया गया कि यह इंटरनेशनल कॉन्फ्रेंस का जो थीम है एडवांस ट्रेंड्स इन इंजीनियरिंग एंड इमर्जिंग टेक्नोलॉजी, बहुत ही सामयिक है, प्रासंगिक है और बहुत ही इसकी आवश्यकता है। तो सही समय पर इसका आयोजन किया गया और जैसा कि आपको ये बताया गया कि ये पॉलिटेक्निक संस्थान पहला संस्थान होगा खासकर इस बिहार में जहां यह अंतर्राष्ट्रीय सेमिनार का आयोजन किया गया। मैं आपको बताना चाहता हूं कि जब भी मुझे खासकर पॉलिटेक्निक में जाने का मौका मिलता है तो मुझे एक अंदर से बहुत ही सुकून कहिए, एक सुखद अनुभव कहिए फील होता है। और इसका एक बहुत बड़ा कारण है कि मैं भी पॉलिटेक्निक से ही पढ़ाई किया हूँ। आज से सर करीब 50 वर्ष पूर्व मैं पॉलिटेक्निक का छात्र रहा। मैं ये बात इसलिए बोलना चाहता हूँ कि अगर आपके पॉलिटेक्निक के कोई छात्र यहाँ उपस्थित हों तो शायद हमारी बात से वो प्रभावित होंगे, वो देखेंगे, क्योंकि सुनी हुई बात तो सुनी हुई होती है, देखी हुई बात का कुछ अनुभव अलग ही होता है। तो आज से 50 साल पूर्व मैं आप ही की तरह एक विद्यार्थी हुआ करता था गवर्नमेंट पॉलिटेक्निक धनबाद। उस समय बिहार और झारखंड एक ही था, बाद में वो धनबाद अब झारखंड में चला गया। तो जब देखता हूँ कि पॉलिटेक्निक संस्थान, जैसा कि बात से पता चलता है कि पॉलिटेक्निक मतलब एक स्टेप नीचे इंजीनियरिंग कॉलेज से, लेकिन इस तरह के आयोजन को देखने से आपको क्या लगता है कि पॉलिटेक्निक एक स्टेप इंजीनियरिंग से नीचे है या ऊपर है? आप देख लीजिए। इंजीनियरिंग कॉलेज ने तो नहीं किया इंटरनेशनल कॉन्फ्रेंस का आयोजन, लेकिन पॉलिटेक्निक ने किया। तो बात यह है कि आप क्या करते हैं। जैसा आपको कहा गया कि अगर आप ठान लेते हैं, अगर आप में कमिटमेंट है, डेडिकेशन है, तो शायद इम्पॉसिबल कुछ भी नहीं है, असंभव नाम की कोई चीज नहीं है। तो चाहे वो पॉलिटेक्निक हो या इंजीनियरिंग कॉलेज है, अगर आपने इस दिशा में कार्य करने को सोचा है, हो सकता है कि इसको देखकर और भी लोग प्रेरित हों और आगे आने वाले दिनों में कई पॉलिटेक्निक संस्थान इस तरह के कार्यक्रम का आयोजन करेंगे। और मैं उम्मीद करता हूं कि इंजीनियरिंग कॉलेज भी, चूँकि प्रोफेसर अनंत कुमार साहब सिर्फ ज्वाइंट डायरेक्टर ही रही हैं, वो ज्वाइंट डायरेक्टर विभाग में हैं। उन्होंने खुद बताया कि वो प्राचार्य भी हैं गवर्नमेंट इंजीनियरिंग कॉलेज वैशाली का, तो हम चाहेंगे कि सर इस तरह के कार्यक्रम वहाँ भी आयोजन किए जाएं। और जैसा आपको परिचय में बताया गया प्राचार्य महोदय के बारे में, चंद्रशेखर सिंह साहब के बारे में, तो मैं ये बता दूं कि जिन्होंने इनकी प्रशंसा की है उनमें भी बहुत प्रशंसनीय गुण हैं। मुझे पूर्ण विश्वास है कि वो इसी तरह मुझे मौका देंगे और अपने अभियंत्रण महाविद्यालय में भी इस तरह के कार्यक्रम को कराएंगे। मैं उनके कॉलेज में गया हूं और देखा हूं, डिफरेंस साफ दिखता है। सभी इंजीनियरिंग कॉलेज एक तरफ, वैशाली इंजीनियरिंग कॉलेज एक तरफ। तो कहने का तात्पर्य ये है कि ये पॉजिटिव जो थिंकिंग है इस तरह के काम करने का, अगर इसको स्पर्धा में भी लेते हैं तो कोई गलत बात नहीं है। पॉजिटिव कंपटीशन होगा और इस तरह के कार्यक्रम होंगे। तो ये भी बताया गया कि इतनी ही संख्या नहीं है, ये हाइब्रिड मोड में कॉन्फ्रेंस हो रहा है। सो रिसर्चर्स फ्रॉम अब्रॉड इज आल्सो कनेक्टेड इन वर्चुअल मोड। तो बहुत अच्छा लगा कि ये दोनों का कॉम्बिनेशन है, ऑनलाइन एंड ऑफलाइन। और अभी आप सब विद्वत जन हैं, जो जिस क्षेत्र में कार्य कर रहा है वो वही उसका एक्सपर्ट है, वो ज़्यादा जानता है। जैसे पीएचडी में गाइड से ज़्यादा कैंडिडेट, पीएचडी का काम गाइड का काम गाइड कर रहा, मतलब रास्ता दिखाना है। एक्चुअल काम तो रिसर्च स्कॉलर करते हैं और फिर वही आकर अपने गाइड को बताते हैं कि सर यहाँ ये प्रॉब्लम है, यहाँ ये प्रॉब्लम है। तो यहाँ बिल्कुल सही सटीक बात जो अभी निदेशक महोदय ने कहा कि लर्निंग जो है वो लाइफ लॉन्ग है। तो जब रिसर्चर भी आकर बताता है अपने गाइड को, सुपरवाइजर को कि यहाँ ये काम करने से ये प्रॉब्लम आ रहा है, क्यों ना हम इसे इस तरह से काम करें तो शायद सफलता मिले, उसका पॉजिटिव रिजल्ट मिले, वांछित रिजल्ट मिले। तो गाइड भी सीखता है कि नहीं, ऐसे करने से नहीं, इस तरह से भी काम करने से सॉल्यूशन प्राप्त हो सकता है। तो इस तरह के जो कार्यक्रम के आयोजन हैं, शुरुआत जैसा बताया गया कि छोटी होती है, बिगिनिंग जो आप देखते होंगे चाहे वो कोई नदी ही क्यों ना हो, छोटी होती है, लेकिन वही आगे चलकर कितना बड़ा रूप ले लेती है। तो साहब देखिए, तो आपका शुरुआत है, इट इज द बिगिनिंग। आगे देखते देखते जाइए होता है क्या। घबराने की कोई बात नहीं। पॉलीटेक्निक है तो क्या हुआ, पॉलीटेक्निक। और सर आप सब जानते हैं कि विदेशों में पॉलीटेक्निक का मतलब क्या होता है। पॉली मतलब पॉली एंड टेक्निक, आप समझ रहे हैं। तो हम तो एक टेक्निक की बात कर रहे हैं, ये तो पॉलीटेक्निक है। डिफरेंट टेक्निक्स विल बी डिस्कस्ड हियर एंड दोज स्पेशली विच आर इमर्जिंग टेक्नोलॉजी। और वो तो आज के समय में आप देखते हैं कि कोई भी इलेक्ट्रॉनिक गैजेट आप खरीदने जाते हैं तो आप जानते हैं कि ये कल आउटडेटेड हो जाएगा। टेक्नोलॉजी इतनी फास्ट है, वो डेवलप हो रही है कि अब वो ज़माना चला गया कि आप एक खरीद के लाए सामान और उसको सहेज कर रख रहे हैं वर्षों। अब उस पर बात नहीं, आज ये है कल नहीं रहे, इसी पूछ नहीं रहेगी। तो आज क्यों 50,000 इसमें लगाना, 1 लाख क्यों लगाना, 1.5 लाख क्यों लगाना, पता लगा कल इसकी वैल्यू 0। तो ऐसा है चेंज इन ट्रेंड्स इन इमर्जिंग टेक्नोलॉजी। मैं आपका ज़्यादा समय नहीं लूँगा। ये प्लेटफॉर्म इसीलिए है, और बिल्कुल सही कहा सर ने कि ये हॉल भरा होना चाहिए था, बच्चों को यहाँ होना चाहिए था। भले पार्टिसिपेट ना करते, पेपर प्रेजेंट न करते, देखते सुनते तो उनको पता चलता कि किस तरह से लोग
सब ऑनलाइन जुड़े हुए हैं।
हाँ, इस तरह से। लेकिन ऑनलाइन और ऑफलाइन में भी मेरा थोड़ा विचार अलग है। अगर वो यहाँ बैठे होते तो उनका इफेक्ट थोड़ा अलग होता। एनीवे, बहुत अच्छी बात है, सब लोग जुड़े हुए हैं। तो आप जब आपस में डिस्कस करेंगे, ये प्लेटफॉर्म इसीलिए होता है कि लोगों को काम करने में क्या दिक्कतें आ रही है वो शेयर करते हैं एमंग पीयर ग्रुप्स और तब उस पर सॉल्यूशन मिलता है। तो मैं आपके उज्जवल भविष्य की कामना करता हूँ। जितने भी पेपर प्रेजेंटर्स होंगे, यहाँ पर डेलीगेट्स होंगे, उनके डिस्कशन के बाद कोई फ्रूटफुल आउटकम आएगा जो निश्चित ही ट्रांसलेट होगा, ऐसा मैं मानता हूँ। वो टेक्नोलॉजी ट्रांसफ़र होगा कम्युनिटीज में और तब उसकी अहमियत होगी। अदरवाइज राइट ए पेपर, पब्लिश इट एंड गेट द प्रमोशन, दैट इज ओवर मीन्स टेक्नोलॉजी, और उससे कुछ होने को नहीं है। वो जब तक सामान्य जनजीवन के लोगों के लिए उपयोगी नहीं हो जाता, पेटेंट हासिल कर लेना एक बात है, बड़ी बात है, नो डाउट, लेकिन वहाँ पर रुक जाना बड़ी बात नहीं। अगर वो टेक्नोलॉजी ट्रांसफ़र नहीं होता जब तक सोशल आम लोग जिसको कहते हैं उनके बीच, तब तक उसका महत्व शायद उतना नहीं है जितना कि हम समझते हैं। पुनः एक बार तहे दिल से आपको धन्यवाद। आप सबों के उज्जवल भविष्य की कामना करते हुए मैं अपनी बात समाप्त करता हूँ। धन्यवाद। जय हिंद।
थैंक यू वेरी मच सर। डेफिनेटली बात निकलेगी तो बहुत दूर तलक जाएगी, और ये बात तो ज़रूर जाएगी। दिस इज़ जस्ट अ बिगिनिंग एंड वी विल डू दिस काइंड ऑफ थिंग्स इन फ्यूचर. So now this program has come to an end, but before going to the final conclusion, we have with us a very renowned professor from NIT Durgapur, Professor R.P. Nanda sir. I would invite sir for your felicitation. Dr. Ashutosh Kumar will felicitate sir. Thank you, Ashutosh ji. Now with this, I Dr. Ranjita Tiwari, take your leave and hand this mic over to Dr. Shambhu Kumar to give vote of thanks and conclude this inaugural session. Shambhu ji.
Thank you, ma'am. Respected dignitaries on the dais, Honorable Director sir, Vice Chancellor sir, Principal sir, distinguished speakers, dear faculty members, researchers, delegates, collaborators, media partners, ladies and gentlemen, good morning to all of you. I am Dr. Shambhu Kumar, organizing chair of this conference. So here is the moment of great pride and emotions of the day. This is not merely a conclusion of this inaugural session, but it is a landmark moment in the history technical education of Bihar. सर ने सही कहा कि हमने ये जो पहली बार जो है हमने हिम्मत किया एक पॉलिटेक्निक होकर के एक इंटरनेशनल कॉन्फ्रेंस को आयोजित किया जाए। भले ही हमें कुछ ऊपर नीचे हो गया या हो गया, उसके लिए क्षमा चाहते हैं हम लोग, लेकिन एक स्ट्रॉन्ग मैसेज जाएगा सोसाइटी को कि एक पॉलिटेक्निक होकर के जहाँ पे जो है एक रिसर्च और इनोवेशन का तरीका खोज सकता है, और हम लोग पॉलिटेक्निक में भी रिसर्च का और ग्लोबल लेवल पे हम लोग इसको रख सकते हैं। ये हम लोगों ने करने का ठाना है और भविष्य में इसको हम लोग जरूर करेंगे इस बात को। और मैं इस सब के पीछे बहुत बड़ा योगदान जो इंस्टीट्यूशनल सपोर्ट हमारा रहा और जो म्यूचुअल ट्रस्ट है IIT पटना और NIT रायपुर का, तो मैं उनको विशेष रूप से धन्यवाद देता हूं कि उन्होंने सहमति दिया। और मैं प्रोफेसर TN सिंह सर और NV रमन्ना राव सर को हृदय से आभार व्यक्त करता हूं कि पॉलिटेक्निक इंस्टीट्यूट को पर आपने हम लोगों पर विश्वास जताया। मैं प्रोफेसर कराली पात्रा और RK साहू सर को विशेष रूप से धन्यवाद देना चाहता हूं कि उन्होंने ऑर्गेनाइजिंग चेयर के रूप में अपना इन्विटेशन एक्सेप्ट किया। और मैं पब्लिकेशन पार्टनर को भी धन्यवाद देना चाहता हूं कि इस कॉन्फ्रेंस के लिए वो पब्लिकेशन करने के लिए तैयार हो गए। हम डिफरेंट सेक्रेटरी मेंबर प्रोफेसर डॉक्टर अनुष्का प्रधान, डॉक्टर आशुतोष कुमार, प्रोफेसर रोहित कुमार को भी धन्यवाद देता हूं कि बढ़ चढ़ के धन्यवाद ये काम किया। मैं डिस्टिंग्विश प्रोफेसर जो डिफरेंट डिफरेंट एकेडमिया से है, आईआईटी धनबाद से पवन सर हैं, एनआईटी रायपुर से आर के साहू सर हैं, दुर्गापुर से सर हैं, बुल्लर सर हैं और पाठक सर हैं हमारे। तो ये सब जो है हमारा इनविटेशन को एक्सेप्ट किया कि चलो एक इनिशिएटिव है हमारा पॉलिटेक्निक का, है ना, क्योंकि ये इंटरनेशनल कॉन्फ्रेंस से बिहार में पहली बार है जो एक कोई पॉलिटेक्निक करने जा रहा है। तो हम लोग से ये जो है इसको इनिशिएट किए हैं सर, और मैं भरोसा दिलाता हूं कि आने वाले समय में हम लोग इससे अच्छा प्रदर्शन करेंगे। मैं पब्लिशर्स जो हमारे यहाँ टेलर एंड फ्रांसिस है, सीआरसी प्रेस है, स्प्रिंजर नेचर है, और सर हमें कई मेल भी आ चुके हैं इस कॉन्फ्रेंस में, क्योंकि हमने 200 से ज़्यादा पेपर्स जो है हम लोगों ने कलेक्ट किया था, उसमें से लगभग 100 पेपर को हम लोगों ने एक्सेप्ट किया है। और पहले हम लोग सर ये लिखते थे उनको कि पब्लिश करें, लेकिन आज सर ऐसा हो गया है कि पब्लिशर हमको लिख रहे हैं कि हमारे ये जो है इसको कॉन्फ्रेंस में पब्लिश करवाना चाहते हैं। तो दिस इज द ग्रेट अचीवमेंट फॉर अस। मैं यहाँ मीडिया के सभी साथियों को धन्यवाद देना चाहता हूँ, प्रिंट मीडिया, इलेक्ट्रॉनिक मीडिया, जो यहाँ पे आए हैं। मैं ऑनरेबल सेक्रेटरी मैम जो डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी के हैं उनको भी सादर धन्यवाद देता हूँ। फिजिकली वो प्रेजेंट नहीं हो पाई हैं, बट उनका सराहना हमेशा रहा है। मैं ऑनरेबल वाइस चांसलर सर को भी धन्यवाद देना चाहूँगा, क्योंकि वो हमेशा गाइडेंस करते रहते हैं हम लोगों को। हमेशा जब जब हम लोग बुलाते हैं तो सर जो है मोटिवेशन देने के लिए हम लोग को तैयार तत्पर रहते हैं हमेशा। सर ने एक बात कही थी हम लोगों को कि आप हमारा 24 आवर्स जब भी आप फ़ोन करिए, हम है व्हाट्सएप पे दीजिएगा, तो हम लोग तैयार हैं। तो धन्यवाद सर। मैं पर्सनल नोट पे कहना चाहूँगा कि सर मैं आईआईटी पटना का पीएचडी का छात्र रहा हूँ, और आईआईटी से को मैं विशेष धन्यवाद देना चाहूँगा, क्योंकि वो मुझे स्टूडेंट के समय में भी मुझे हौसला दिया, और मैं जब वहाँ से निकला तो हमारा ऑर्गेनाइजेशन को भी सहायता दे रहा है। इसके लिए विशेष रूप से धन्यवाद आईआईटी को। मैं फाइनली कीनोट स्पीकर और इनवाइटेड स्पीकर और ऑर्गेनाइजेशन टेक्निकल कमेटी मेंबर्स, स्पॉन्सर, स्टूडेंट, वॉलंटियर और सभी पार्टिसिपेशन को जो ऑनलाइन और ऑफलाइन है उनको तहे दिल से धन्यवाद करता हूं। इनकी वजह से आईसीटी जो हमारा कॉन्फ्रेंस है वो एक ग्लोबल एकेडमिक प्लेटफॉर्म बन पाया है। विद वर्ड्स आई वांट थैंक यू फॉर ऑल टेक्निकल सेशन। अब मैं जो है इसके बाद हमारा पाठक सर का एक टेक्निकल सेशन होगा, तो अभी इनॉग्रेशन सेशन समाप्त करके और की नोट स्पीकर के रूप में हमारा डॉक्टर मनवेंद्र पाठक सर हैं, उनका हम लोग की नोट स्पीकर सुनेंगे। थैंक यू सर।
सर फर्स्ट 2 मिनट आए सर। के लिए भी 5 मिनट
5 मिनट बाद फिर से शुरू होगा ये कीनोट एड्रेस जो है सर का, तो आप सभी यहाँ पे बने रहें। 5 मिनट्स का ब्रेक है।
We have our very first speaker, Professor Manmendra Pathak sir from IIT Patna. Before joining IIT Patna, sir has completed his BE from Assam Engineering College and MTech and PhD from IIT Guwahati. After that, sir has worked as a postdoctoral fellow in the Department of Chemical Engineering at Israel Institute of Technology from 2007 to 2009. Sir has more than 100 international SCI publications, more than 10 book chapters, and more than 100 conference papers. Sir has also granted 2 patents on his name. The research area of Professor Manmendra Pathak sir is computational fluid dynamics, two-phase flow and heat transfer, nuclear materials, and renewable energy. He has successfully guided 14 PhD students and 4 students are currently working under his supervision. He has also supervised more than 20 MTech projects and more than 60 BTech projects. So we have a very well-renowned professor who was in the top 2 scientist list in 2021 to 2025 consecutive years. Today's talk is on the topic development of hybrid solar tracking system for a parabolic collector. I hope this lecture will enlighten us all in the field of solar tracking system. Sir, the stage is yours. Rahul, Ramendra.
You can move this slide, okay?
Yeah, good morning everyone. First of all, I am thankful to organizer for giving me this chance for sharing my research work. Basically, this problem was done by one of our MTech student, and already mentioned by Asutosh also that I got one patent from this work. Okay, so basically what is solar tracking mechanism that I am going to tell about, and what we have developed is, it is a new concept that is called hybrid solar tracking. And what is hybrid solar tracking, that I will explain. Okay, please, next slide. Okay, so all of you know we are exploring the renewable energy sources because the conventional energy, they are depleting as well as they are producing a lot of the pollution. So from different renewable energy sources, the solar thermal technology has the advantage that solar energy is readily available and its conversion is also very simple. Now, out of 2 different solar technology, here we are going to talk about the solar thermal technology. Okay, next one. And what is the technology that we come across is mainly the photovoltaic cell. But in photovoltaic cell, definitely efficiency is less. And from mechanical engineering background, definitely we have to explore how the solar thermal that can be utilized for producing the power. But basically here we are using a small trough or small collector, that is a parabolic. Its length is hardly 1 meter, and this parabolic trough collector is a parabolic shape where we are using actually a reflector, and that can produce the temperature around 400 degrees centigrade also. And this temperature definitely if you use maybe without mic also I can tell. Basically this 400 definitely that we use some synthetic pop. Okay, but in our applications we have not done up to that much of temperature. We have done it for household application. Okay, so next slide. So how the parabolic trough collector works? So simply this shape is parabolic. So from this side you can see this is a parabolic shape. So when the solar radiation, that radiation is coming from too far, so they can take the form of parallel rays. So these parallel rays, when they strike this reflector parabolic, they all concentrate on a line or on a point, and that is called the focal point. So once the ray they are concentrated, so definitely we get very high intensity. So that is the all concentrated collector. We have flat plate collector also. You have seen, like in photovoltaic cell, most of the photovoltaic cells are flat, and even flat plate solar thermal collector also we can see. So the advantage of this is, one is we can achieve very high temperature, and where we use the one absorber tube. That absorber tube, their fluid flows, and that fluid is actually heated up, and that way we can gain the thermal energy, and that thermal energy is too high, we can produce steam. That steam is expanded in the turbine, and that is called actually solar thermal power. But here it is a portable the collector, so we will not generate steam. And this is the diameter, that is the tube diameter. After that there is one enclosure. That enclosure is used for reducing the convection loss, so that efficiency is high. Next slide. So this is the mathematical part. I will not go in detail because time limit is not that much. So basically how the solar thermal is ultimately converted into the useful energy. That means this is the area of the collector, and if you know what is the actually global radiation intensity, so this is the what is the gross amount of energy we get. After that there are certain loss, and those losses are actually taken care by some optical efficiency. That again depends on the solar collector, as well as this theta is the tracking angle. So what is the tracking angle, that I am going to discuss maybe after 1-2 slide. Then after that, what is the useful energy? That useful energy is for heating the working fluid. So working fluid gains actually temperature, that is the temperature difference at the inlet and outlet. So that utilize energy by what is the energy supplied by the solar, that is the efficiency. So for increasing the efficiency, definitely first things we have to collect the high amount of these solar rays, and that is the purpose of tracking mechanism. Why? Due to shape of the parabolic trough collector, there will be the shadow effect, and for that actually we need the collector has to rotate. Okay, next slide. And definitely these are the parameters we use for calculating these like in terms of heat transfer coefficient, that is called Nusselt number. Then Nusselt number again, it depends on the flow rate and Prandtl number. Then ultimately what is the energy that is absorbed is nothing but the energy utilized plus loss. Okay, next you go. Okay, these also I will skip, but quickly maybe this is loss due to the atmospheric radiation from the cover surface, and these are actually emissivity of the cover surface as well as the absorber tube, and those depends on the wind, the sky temperature as well as wind the velocity also. Okay. This slide I will tell. So this is, we are showing what the typical photovoltaic cell, even though we can use the tracking mechanism for this type of photovoltaic the panel also. So you see the sun, when it actually from the morning to the afternoon, the sun takes from east to west due to the rotation of the earth. So what will happen at the morning hour, definitely the panel that has to be face the east side, otherwise the rays that will not directly strike here, so will not get the high intensity radiation. So naturally you can come across once the sun tracking mechanism is sunflower. You have seen also the sunflower automatically it changes its direction from the east side to west side in the afternoon. So same type of mechanism we actually use in the tracking mechanism. So from the east, then in the noon definitely it is directly perpendicular into its top direction, then again into west direction. So when we do it technically or using some the advanced technology, that is the actually solar tracking mechanism. Okay, so depending on how that panel is moved, okay, there are two types. One is called passive another is called active or closed. So what is passive? Because you know, if you want to track the solar rays, that means that rays coming to the earth, and if you can define that solar rays in terms of some angle, and those angles, suppose if you give, definitely with some electric motor, this panel can be rotated automatically, but definitely we have to write some actually code so that it takes from that program. Okay. Then what is active close? Depending on the intensity level, and we get the feedback of the solar intensity, and that information we have to again feed into the driving mechanism, and that is called actually closed loop. So what is closed loop? That means it is kind of a feedback mechanism. Okay. So how we define the solar ray? So this is little bit theoretical, but you try to understand it. Suppose this is a person and that is the flat surface of a earth. Okay, so this is the observer. So in that observer point, that is the sun rays striking here. So what are the different angle we use? One is called actually zenith angle. So what is zenith angle? That means that solar rays make with the vertical direction. That is called zenith angle. Then another is called actually altitude angle. That is the solar rays makes with the horizontal direction. Then another angle we measure in the horizontal plane, that is called azimuth angle. So what is azimuth angle? Suppose solar ray is coming from this direction, okay, and this is my south direction. So if we just make one projection on the horizontal line, and that line make with the south direction, that is called azimuth angle. So obviously you will see when the sun actually rises in the east and gradually it goes towards the west side, definitely it is not that the sun actually always remains in one plane, because depending on the season, okay, like winter, always sun goes towards this south side. So just to take care of daily variation as well as the seasonal variation, these angles are used. Another important angle is called actually declination angle. So what is declination angle? That is the delta. This is, suppose if you imagine the center of the earth and center of the sun, and if we make one line and that line makes with the horizontal direction, that is called actually the declination angle. So as the earth is always inclined in its axis, so this declination angle actually varies from positive 23.5 to negative 23.5, and this is very, very important, or this is interesting also. You can see we have like solar solstice, okay, that means June means it is summer solstice, where we get the longest day, and December we get the shortest day, and that is called actually winter solstice. So in the this June it is the maximum actually 23.3 positive, and in the December it is minimum 23.5 in negative direction. Whereas when the sun rays is parallel to the center of the earth, we get the zero angle when it is called actually equinox. And equinox, there are two equinox, one in March, I think it is in 21 March, and another is September, where both the day and night duration they are same. So all these informations we can track how? If you know the geometric location of a place, like for Patna, what is our altitude and latitude. So depending on the altitude and latitude, we will get the declination angle and the all this angle, and all this angle we have to make in a formulation. Next slide. So those angle, like for solar tracking ultimately, so this is the ray diagram already I had told. So this is our parabolic trough collector. This shape is like this, okay. So the ray, sun ray, it will strike like this, and gradually the sun ray will move gradually from here to here. So ultimately the angle that we have to sense is actually the solar tracking angle is the rho. Okay, so these are the formulation. First, that is the declination time, that is the declination angle depending on the number of days each day. You can make delta, then we use one equation of time UT, then AB, and that is solar time, then hour angle, and from this ultimately this is the actually expression of the tracking angle rho. What is this rho? that row we have to rotate the collector. So you can see here, this is the row, that is the solar ray, and this is the perpendicular direction. So when this row will be, that means that this collector will be rotated. That means we are aligning the collector along the ray direction. That means both this perpendicular direction and this, they will coincide. So that way, at different time of the day, we have to rotate the collector, and that is also automatically, not manually. Okay, and here we have shown the tracking axis. So this is exactly the parabolic collector. Okay, so this is theoretical, the formulations of the problem. And our student, what they have done, all this they have made one small program in a microcontroller, and that microcontroller is used for rotating this shaft with some gear arrangement. Okay, next slide. So this is the working that already I have told. If you know the geographical notation, this place, then from the longitude and latitude you will get time and date time. Then we use a sun position algorithm. That means, and this is written by our own student. Nowadays you can even get somewhere, you can download it also, but they have written. So based on the azimuth and elevation angle, the controller will actually rotate. Okay, one will be altitude and another is the azimuth. But definitely we have gone for one axis. So we have only tracked the altitude tracking motor, not azimuth. Azimuth is only used for seasonal variation. That means from winter to summer, if sun actually changes its direction, then we use. Okay, next slide. So depending on, like I have told about active and passive. So in the passive already we have shown the formula. So what is actually the closed loop? Here, suppose you have one surface. On that surface, if you put one opaque body, and if the sun rays that strike, okay, that sun rays strike equally in both direction, so there will be one circuit. That circuit will see what is the actually ray intensity, and both are equal intensity. Definitely it will not move anything. But suppose sun has moved to that direction, and due to the obstruction, if we get some shadow here, so definitely the intensity will be less here than this position. So due to that differential intensity, some the analog signals are actually generated, and that rotates the collector, so that ultimately we get actually equal ray in both sides, and that is called actually passive. So in our approach, that is called actually hybrid tracking. That is a novelty of our work. So what we have done, we have implemented both the open, this solar tracking, as well as close also. That is called actually hybrid. And why it is needed actually? Why it is needed? Because the open loop, definitely all this angle we have to write our own code, and if your motor is not working, so we will not get accurate the tracking. Whereas in closed loop, if the sun intensity is not good, mainly during rainy season or clouding, definitely we cannot get the accurate effect. But if you combine the both, that actually the disadvantage of both loop can be actually this targeted. Okay. So this is the actually working of a solar tracking mechanism. So here, suppose this is your cross-sectional view. So one way you can move it like this, that is one axis, and another for seasonal variations for azimuth angle we use this. And these are the actually the circuit diagram for using this sun position. And this is the actually closed loop. Okay. This is, you see, exactly we have written, and that is why this parabolic shape the student they have developed, because you have to give the shape of this, and exactly for getting this parabolic shape, first they have made some wooden frame. On that wooden frame they have made some the bar, and there we pasted one the aluminum sheet, then we have pasted the reflector sheet. And for moving the tracking mechanism or the shaft, we have some worm gear, and that worm gear actually reduces the speed, because you see, even though the angles they changes hourly, very small angle, maybe in 1 hour it will go only for hardly 0.5 degree kind of thing. So we have to reduce the speed also. So locally we have made, this is the frame for supporting the collector, and these are all scales. Okay, so ultimately how it works, we have another novelty of our work is we have studied in the literature that most of the time we have to put the geographical informations manually, but here we have put one global GPS system. So once we have incorporated GPS system, you need not put any geographical locations. Even this collector, it is portable, it can be equally applicable Patna, or if you go for Ranchi also, that's it, because this GPS will take care of all the geographical notation. So it will give the sun position, and that is fed into the microcontroller. Then that microcontroller actually give the motion to the potentiometer, and that rotates the parabolic concentrator. But what happened? This is again for day and night, because from the morning we get low intensity, noon we get high intensity, afternoon again we get low intensity, then again we have to revert it back to its original position. That we use some this luminosity in this sensor. That means it measures the intensity of the sun rays, and depending on the minimum and this maximum value, it orients to its previous position. Okay, next. So these are electronic circuit the student has actually developed. So you see, from this, starting from the GPS, then this is the solar the tracking algorithm, then position and power source modulation, this DC motor is run, then with the help of again potentiometer, again it goes. So how it makes the hybrid? Because I have already mentioned there is one luminosity intensity sensor. So suppose it is a normal day, so we are getting the clear sun, so we can go for the closed loop the tracking mechanism. Okay, but suddenly there is suppose rain or cloud, we will not get any the solar rays. So either it will go actually open loop, or it will shut down the entire unit. So that is the actually beauty of this hybrid tracking mechanism. Okay, next. So these are all, you see, we have developed, indigenously developed. This is for the this light dependent resistor. Okay, so this is one opaque plate. So these are two LDR used for, and these are the actually the circuit diagram, and this voltage V1 and V2, if they are equal, definitely that means we are getting the same intensity. But if V1 and V2s are different, definitely it will orient the collector itself so that they become equal. That is called actually feedback mechanism, and that is called closed loop. Okay, next. So this is the algorithm how we start in a particular day. So it start, then we get the illumination and time from GPS as well as the sensor. So if time is, that means if it is for definitely Patna in the summer, maybe it is greater than 5 am, definitely it will go fast in the open loop. If illumination is greater than the 34,000 lux, that is the intensity, so it will go for open. If it is no, definitely it will go for actually the open loop. Okay, so that way it works in the hybrid mode, and that is the actually novelty of our work. Okay, next. So this is the real circuit diagram. It is the microcontroller. Okay, and here we have included this motor drive, and we have used a very small motor for rotating the this panel. Okay, go. So exactly. So this is the this is the actually collector. Okay, and this is the observer. So the collector we have to rotate. So the problem will be because it is heavy one. Okay, so when it is maybe in the noon time, this whatever the moment that will be applied, that can balance. But when in the morning or evening, okay, so it will be unbalanced condition. Like just imagine this whole setup you have to put like this or this side, so there will be high moment. So for that we have used actually the warm rear drive, so it is actually stuck in particular position. Okay, so these are the different actually torque level we have the calculated based on its weight of the collector. Okay, Just if you play this video, I think just if you click here, even though this is made on this, just if you click here, we have just amplified, but it actually moves very, very slow. Just if you click here, it rotates actually, and this is simulated. Okay, here. So this is amplified movement. Okay, not actually real, because we have to slowly move it. Okay, and that way we have shown it. Okay, quickly you go to next. These are the during the manufacturing time how student has developed. Already I have told. They have first cut this parabolic this shape. Then these are the supporting bar. Then on that bar one aluminum sheet is actually the fixed. Then on the aluminum sheet there are the locally made reflector glass. This okay. So this is the complete setup you can see here. So this is the shaft where this entire the collector is actually supported, and these are the strips, and here this is the DC motor with the worm gear mechanism, and there we are putting the sensor for getting the intensity of the light. Okay, and at the other side there is the potentiometer, so that it is actually always oriented in the morning every day. Okay, so that way we have developed. Here actually the observer tube we are just using for the AR. Why? Because we could not support other the enclosure for cover tube, because it becomes very too heavy one. Okay, so that is why we are showing here just we are measuring the temperature with the hybrid and with open or closed, and we have compared. So what is the actually results we are getting? Okay, next. This is the side view. You can see here also we had that. Now maybe I have removed this. You can see these are all still photograph we have taken at different time. It is not like a real animation, because it rotates so slowly. You cannot record that much of real data. Otherwise, the data will be very, very huge. So student has just recorded at different time, and these are automatically done with that this mechanism. Okay, and due to the small setup and due to small actually what is that called setup, its power consumption is also very, very low. And even you can ask me if that power is needed for tracking, where we will get. Obviously we can use another PV cell for actually getting the power in real application. Okay, so that is the level. So these are some results. These are first we have taken from open loop, means that means whatever the formulations we have given, based on that we can get all this actually, and certain algorithms are also there, we have followed that also. Okay, so these are the results for open loop, that means calculating the angles. Okay, next. And these are the results. Okay, we have it is quite actually old data, because first we prepared that, we actually submitted for patent. It took a lot of time. Okay, next. Just go back. You can see here tracking angle, as I have told. So in the morning, definitely the sun that comes from the east, so the collector has to move 86.3 degree from its position, that means vertical position. So one side it is positive, and gradually you see as the actually time progresses it decreases. So around 12 o'clock it becomes exactly 0 degree, not 0 degree, very small value, we have written 0. Then again from 1 p.m. it goes other direction, it goes to the negative. So at the 86 and minus 79, highest actually torque is needed. Okay, so that is the point. So we have just shown some results. Simulated means from our the formulations and experimental real data we have taken. Then these are the error between what should be actually simulated and the error, and errors are actually you can see very, very small in terms of only degree, that those angles. Okay, next. Then we have shown here the open loop and closed loop. Okay, so open loop means it is cloudy, that means we are not getting directly required intensity, it goes. Closed loop, definitely it is clear sun, and again it becomes open close depending on the actually what is the intensity. So exactly these are the real time you can see, starting from 11 o'clock to the 1640, that means 4 o'clock. So these are the results we have shown. And these are the actually observer time. This temperature, that means the pipe temperature, if we use hybrid and if we use closed loop. So obviously the hybrid is showing a little bit higher temperature because the tracking is accurate, and mainly, as I have told, you can see in the evening hour its accuracy increases. That is why we are getting better results in the evening hour. Okay, next. Besides that, we have used some the small temperature also transient, that different, but that setup was different, so it is not part of the hybrid. Okay, you go to next. So ultimately, what is the improvement of the efficiency? You can see here, when we go for the hybrid loop, okay, we get around 10 to 12% of actually more efficiency. So that is the our achievement, because using this hybrid, the tracking mechanism, we can save the energy or we can improve the efficiency of the solar thermal technology. So these are the conclusions that we have developed on the hybrid tracking mechanism, and using our locally made available the materials, we have developed it and we get the better. And definitely when you use microcontroller instead of PLC, definitely it reduces cost, and for PLC you need very complex programming also, but microcontroller nowadays in school level also people use. So that is the actually the main innovation. Okay, so with very short I have made it, and very fast also maybe I have delivered it. So I hope you have understood. Okay, thank you.
Thank you so much, sir, for your valuable talk. I hope it will help the young researchers to lead it, further in this area. If any questions from the audience.
Thank you. It's a nice presentation, and really it's innovative, and we are really enriched. Thank you, sir. I have certain questions. Okay. First of all, that what is the maximum variation or azimuth angle you have considered?
Azimuth angle, as I have told, it is one axis tracking mechanism.
Okay.
Okay. Azimuth angle we have not taken. For azimuth angle,
oh, that is for the seasonal. Seasonal, it will change.
Seasonal. For 2 axes.
Okay. So
axis, that means for yearly or seasonal variation, you need another motor.
Okay. Okay.
So this is one axis.
Okay. So near future, obviously, you may consider this one, and there may be the one future research work. Okay. Good. Now I want to know that how much efficiency you can increase using this method.
Yeah, already in the last slide I told, if you go for only like one, that means either open or closed. Okay.
You are considering the hybrid mode.
Hybrid mode. So
that is the innovation part.
Yeah, innovation. You see, first, if you go for a fixed collector, efficiency will be low, around maybe 30. Okay.
It's true. 30.
30 only. But tracking again, you will go around 40, 10% in.
Okay.
In again with the hybrid tracking, we have shown also one plot around 45.
You are telling that 30% efficiency for the solar. So what kind of material you have used?
30%, it is solar thermal technology, I am telling.
Okay.
Solar thermal technology.
So not for the solar efficiency.
Now, if you go for tracking, you are actually accommodating your collector with the sun movement, so you can increase
up to 40%.
40%.
Okay.
Now, using hybrid, you can get 50% also. But only thing, you are right, these are small scales of efficiency.
Okay.
That will also do.
Actually, my concern is in another direction. That is that for that your tracking system, you are using the motor and you are giving the supply. So how much supply generally per day you are giving, power or energy? Respect.
Yeah, that is why I have told also, these are all small scale lab we have developed.
For the smaller scale also you can say, suppose you have generated this much of power. How much power per day you can generate for the, suppose it is not a cloudy day. So during that time, how much power you can generate?
Yeah. Power means, you see, we have
power or energy.
We have performed solar thermal technology. So we are not directly getting the electrical energy. Here we are using the heated fluid. Okay. Because in solar thermal technology, our always target is to heat up any working fluid either into steam or in the process industry. So here we are getting the temperature rise of the working fluid, and that is
so in that respect also you can calculate the energy, no?
Yeah, energy that means based on your mass flow rate, that we have not calculated, just we have shown how much temperature gain is actually what is that called, we have gained through this technology, because it is a solar thermal technology.
Thank you for the highlighting. Actually, I want to, why I am asking this question, that I want to say, suppose you are moving it, okay, so you need the power to move it because you are using the motor. So you have to calculate the per day how much power or energy you are giving, you are supplying, okay, and when your efficiency increased, for that how much energy you have enhanced because of your innovative research work, that you have to also consider, and you subtract it, and in that respect you can think that that much of percentage gain you have attained. So that may be the future research work.
I fully agree with your suggestion. The research has multifaceted objective.
I know.
Exactly. So our objective is to improve the efficiency.
Sorry, sorry for intervening. You can continue during the lunch session. Your interaction will continue.
Okay.
Thank you, Professor Manbendra Pathak sir, for this valuable talk, and it was a lovely interaction between two researchers, which will lead the path to the young research fellows. Now in the line, we have next speaker, Professor R.P. Nanda sir. Sir is Professor in IIT Durgapur in the Department of Civil Engineering. Sir has done his BTech from CET, ME from NIT Rourkela, and PhD from IIT Roorkee. Sir, doctoral research area was low-cost friction isolation for masonry building. Sir has guided more than 30 MTech projects and 7 PhD scholars. Sir has more than 50 SCI publications in different journals, more than 30 conference papers, and 3 book chapters. Sir, I would like to invite you to proceed with your talk. Sir.
Thanks the organizers to give me this opportunity for this type of for the keynote speaker. My scheduled time was at 4 o'clock because of some other assignments. I preponed, I requested the organizer to keep this slot here right now. The topic is the earthquake resistant masonry buildings and as a sustainable materials, sustainable constructions. So as you know that whenever you are looking that there is a development or the construction is going, and we are happy, but at the same time we should see the future generation needs. We should not compromise for our needs. We should not compromise the future generation needs. We have to keep the materials or the environmental protection. Now, the philosophy, the earthquake resistant construction, because when you are going for a resistant buildings, so it should be durable and there should not be frequent damage and your materials will be conserved, or else you have to go for a demolition of your building and the repairing, or that leads when there is a repairing or there is a damage, that also leads to pollution. Okay, next please. So these are some key points, that is we are protecting the society, and it is a resilience to any disasters. Then the sustainable materials in this particular slide, so I will show you that how the materials can be used for the earthquake resistance purpose, and it is also minimizing the impact on environment. Next please. Then my focus area is the masonry buildings. Why I am considering the masonry buildings? As you know, the 85% buildings in Indian conditions are masonry buildings. Why the masonry buildings are widely used? Because of the low cost, and it does not require any engineering interventions. No engineering idea is required for the masonry construction. And local materials are also used for these masonry constructions, and they are thermal insulated. But these masonry buildings are having heavy masses, and they attract, you know, the earthquake force is the mass into acceleration. So when mass is more, the earthquake force will be more, and these masonry buildings are brittle. So it is, when there is a lateral forces, so immediately there is a collapse of the masonry buildings. Next, please. So this is the damage in Balakot earthquakes. So the large scale damage. So if there is a any sort of magnitude 6 or 7, more than 6 magnitude earthquakes, so many buildings of Delhi and Bihar areas will be damaged or collapsed like this. So next, now the mechanism in the masonry buildings, you see that when there is a earthquake force is coming, so one wall is subjected to in-plane forces, and the cross wall is subjected to out-of-plane buildings. So due to this, so there is a failure at the corners. Now the code has suggested that it should be, all the walls should be binded in integral box sections. So it is saying that you have to give the different types of bands at the plinth level, then the lintel level, and the roof levels. But beside all these bands, again the masonry is subjected to some sort of damages, because when there is in-plane wall, the A wall is subjected to in-plane. So this A wall is, because of the in-plane, so the mortar joints is very weak. So brick and mortar. So the wall, there is a sliding failure because of the in-plane. Next. Now, other type of failure due to in-plane is that diagonal failure. You know that masonry is brittle metals. So the one diagonal is elongated. So because of that, there is a tension cracks. So this is the welding cracks, diagonal cracks already shown in the bottom figures. Next. Now the IIT Roorkee, some researchers tried with providing the bands. You see the left side, the motor buildings with different bands, and after the checking shock table testing facilities, the collapse or the damages of the buildings. Please, hello. Now you see that now how to protect this shear failure of the wall panels. So researchers tried with providing the bamboo shotcrete reinforcement. Then some researchers tried with the reinforcements and the wire mesh. Some researchers tried with the GFRP sheets, and some researchers tried with the polypropylene banks like this. Now next please. In our laboratories here, there in IIT Durgapur, the PhD students, they tried with providing some GFRP, that is geotextile members like this. So they provided the horizontal pattern, different patterns. Now you see that left side, the UR is the on-reinforcement panels. So it is carrying so there is a compression load. So due to the compression loads, there is a shear failure along the joints. So it is when it is retrofitted with a different type of your geotextile sheets. So the cross patterns gives a better resistance. So the load carrying capacity is more. Next. Now the same thing for the bending actions, we have tried 3-point loadings with the different patterns, and it is giving a better resistance when there is a the grid patterns reinforcement is there. Next. Now this is we have tried with surface reinforcement. Now we have tried with a bed joint. So the brick mortar and the brick layer is like this. Then we provided at the bed joint, because surface generally there is a chance that it may be affected by the fire hazard or any environmental. So we tried with because in the research we are just adding some sort of whatever the existing literature, we are adding something little bit. Now we have tried with the bed joint reinforcements with the geograde metals. Now you see we have carried one building models. Next. Where you will find one wall, L-shape wall, where there is a bed joint reinforcements with the geogrid. Other L-shape wall is without any sort of strengthening arrangement. Now after different, we have applied some a low-cost selectable model instrument is there, platform is there, where we are providing a sinusoidal loadings. And you see the after several frequency, we have increased the frequency, and the L-shape walls, which does not have any strengthening arrangement, is suffered, while the L-shape walls, which is having strengthening arrangement without any damages. Next. Now this is, I tried with the IIT Roorkee platform. So this is sort of some isolators. We have isolated the earthquake effect at the base isolation level. That is at the base level, the earthquake force is cut off at the base levels. So we have provided friction layers, a smooth layer at the plinth levels. So one marble plate is provided, then one more marble plate is provided in an inverted manner. Then the superstructure construction is going. Then we have we use some polythene sheets so that the interference will not be clogged by the motor, the slurry. Next, the superstructure construction is completed. Now we have used the zone 5 simulated earthquakes, and this is the instrumentations. We have used some LVDT, then the sensors to monitor whatever the accelerations at different level, the floor levels, then the roof levels, because the earthquake force is the mass into acceleration at the roof level that damages the buildings. Now we have used a fixed model as well as the sliding models. So some arrangements has been made at that plinth level, interface level, so that it can be fixed. So we applied the marble to marble. Then next. Now you see that the pictorial views where we have given the base excitations and the base excitation at the bottom accelerators. It is showing that 0.4 is the maximum PGA, peak ground acceleration, while the top roof level, the peak ground, the acceleration, maximum acceleration, it is attracting 0.8 G, almost 100% more. While applying using the isolators, now the isolations, the roof accelerations is almost 0.2 G. So from 8 G, 0.8 G to 0.2 G, so almost 1/4. So 75% reduction. Okay. So this is all about the latest development in the earthquake resistance building. So we have used a material that is durable materials and low cost materials for earthquake protection. For the base isolations, almost the cost of the isolator, one isolator is more than building cost. So we have used a low cost techniques to protect the masonry buildings. Thank you. Any question? Yes, sir. Thank you.
Thank you so much, sir. If anybody want to interact with the they can interact during the lunch session for their knowledge transfer. So at this time, we will take a break for the lunch. After 45 minutes, we will join again in the same place for further invited talks. Thank you. Thank you so much.
क्या काम पड़ा है? अच्छा इनको दे दीजिए है तो 10 मिनट का ब्रेक सर तो है नहीं कहाँ जाना है दोस्त के साथ मिलने जाना है तो लंच के बाद नीचे दे दीजिए प्लीज But that is not good, sir. Good was सीखने तो मेरा भाई था, ये लंच के पहले था मेरा। लंच से पहले तो बिल्कुल से पहले तो मेरा भी था। तो शेड्यूल से चलेगा ना। That is not good. That is actually quite difficult. That is international conference. We avoid by the time and time to avoid by the time नहीं होगा। Time to avoid by नहीं होगा।
Somebody will come and tell me, I also a lot of work to do. मंडल दादा आपकी गाड़ी
ठीक है, इंस्टेंट, ठीक है, लाइव चला जाएगा, लाइव यहाँ पे तो जान रहे हैं लाइव चल रहा है, ठीक है, न्यू मीटिंग, इंस्टेंट मीटिंग, क्रिएट इंस्टेंट मीटिंग, ठीक है।
चलो सर लिंक कॉपी कर लो,
लिंक कॉपी कर ली
सर ज्वाइन
और कोई ज्वाइन होगा कोई ज्वाइन ना, बस इसमें दिखाना है तुमको कैमरा, कैमरा में
यहाँ ऑफलाइन होगा ना तो डायरेक्ट
कैमरा ऑन करो
सर, कैमरे का परमिशन लगेगा।
हाँ हाँ, तो कैमरा यूज कैमरा, ठीक है, और उसको ठीक है वो वाला होना चाहिए कैमरा में, लॉजिक वाला, हाँ लॉजिक टेक, ठीक है, चलो ओके। हाँ हाँ वो भेज दी है, ठीक ठीक ठीक, ठीक है, हम देते हैं समझ गए बात, कॉन्सेप्ट यहाँ पर वो तो ये था लाइक बनाइए, लाइक चालू लगाए
सर मिरर बंद कैसे करें, मिरर हो रहा है
कौन गिरा उसका सेटिंग हो गया, अरे इसमें ये लाइव देखो ना, लाइव लाइव में बोलता ही नहीं दिख रहा है।
पहले से कॉपी कर लीजिए।
कौन सा?
एनजीपी पटना, मतलब पीपीटी एनजीपी पटना।
ये पीडीएफ वाला?
नहीं, पीडीएफ क्यों?
बस एक ही है ना?
हाँ, एक ही है। इसका वो
ये सर के पास ही होगा।
Regions. So post lunch session, we have the first invited lectures of Dr. Pawan Kumar Singh sir. Sir is Associate Professor in the Department of Mechanical Engineering at IIT ISM Dhanbad. He received his BE from Madan Mohan Malviya Government Engineering College, Gorakhpur, and his Masters and PhD from IIT Madras, with a specialization in nanofluid transport in microchannels, followed by his postdoctoral research at the Mashadar Institute, Abu Dhabi, and the National University of Singapore. Dr. Pawan sir has guided several PhD students, developed the microfluids and nanofluids laboratory at IIT ISM Dhanbad. It's a very rich laboratory, and received prestigious fellowship including the ASEM DO in 2019, NUS postdoctoral in 2012, and Masdar Institute Fellowship in 2010. With over 3,900 citations and an H index of 23, he continues to contribute significantly to the field of thermal science and engineering system. Sir, it's our honor to have you with the panel. Kindly proceed with your talk.
Okay, so Ashutosh, thank you very much for this introduction. And I think the total time for this talk is 20 minutes. I will try to cover the things in 20 minutes. What I am going to do an overview whatever we have done over the last 10-15 years. So the topic of this presentation is nanofluid for thermal management. I think please next. So actually my thesis and all my presentations start with this particular line, which Richard Feynman in his famous Nobel laureate speech he has given. There's plenty of room at the bottom. So when he gave this speech, till that time the experimental techniques were not that much developed, but he believed that there are a lot of hidden physics and techniques which are hidden at the smaller level, and we can see in today technology, all this nanotechnology, which is bringing all the thought which Richard Feynman has given. So anyway, going forward, this talk about, like, we have a lot of modern system which generate lot of high heat. Like you can see that day to day your computer, your mobile, everything is going to be updated year by year. So whatever happens, when you have more and more highly strong processor, you are going to generate more and more heat also. So you need to cool that heat so that you can work, I mean, you can use this device. Just to say that when all this electronic development that is constrained by this thermal management thing. If you can cool the things, we could have made this all this mobile and all those things 10 years back itself. So having said that, people have used a lot of fluid. In that context, we have found that when you use something like a nano-sized particle in addition to some normal fluid, we can have a better convective heat transfer fluid. I think I will better go on that side. Yeah. Hello. Yeah. So, what we are going to do that, I will just describe what is nanofluid, what are the application of those, then I will come to the thermal amendment, and then I will merge both those things. So it has been, I mean, it is believed that the thermophysical properties of nanofluid do not follow the usual suspension behavior like a micro suspension. Next one. So what is nanofluid? It's a very simple fluid where we have something like a nanoparticle. We mix with some base fluid. The base fluid may be water, ethylene glycol, transformer, and all those things. The most common one is the DI water. You mix it, and by some chemical or other methods, you make it suspended. The main criteria is make it suspended. If it is suspended, that is the nanofluid is prepared. The advantage we told that, because of nano size, we believe that they are continuous in the Brownian motion, and there are some other chemical techniques also. So we will believe that they are in stable suspension. You can use them in lot of techniques where, because of the small size, you don't get clogging. But since they don't have that much mass, the erosion is not there. And the most important part, people have found that the high enhancement depending on the particle size. Next one. So these are the few applications which we show that where they can be used, or they are being used, like electronic cooling, engine cooling, lubricant. And one live example which my group at IIT Madras has done it, they have used these nanoparticles for this cancer detection and the destruction of those cancerous cells. So this is the live example which we have used the nanoparticle for the actual application. Okay, next one. So how to prepare it? So you can say this slide in a brief, it gives you the total methodology through which you can prepare the nanofluid. It's a two-step process, means you mix the base fluid nanoparticle depending on what concentration you want to make it, what is the volume or mass function. Accordingly, you will do the weighing. Then you will mix them simply. Before going to this one, you will use the magnetic stirrer so that you get a first mixing. And then the most important part, you need an ultrasonic cleaner, where you give this high power ultrasonic waves which breaks these nanoparticles in their basic size. Why? Because the small particles are having tendency to agglomerate. If you leave them in some powder form, they are going to agglomerate and they are going to make a bigger particle. So you have to give this enough energy, which we give as this ultrasonic cleaner, sometime 2 hours, 3 hours, to make it suspended. But even after that also, we get the basic size. You can see that the earlier size was quite big, then we got the basic size. Still, we are not sure they will be suspended. So there is something called the zeta potential of a solution, which ensures that if your zeta potential above certain millivolt or below certain millivolt, your system will automatically create enough repulsion force to make that particular particle in the suspended. So zeta potential, then what we do that, we put a drop of acid in this particular solution to make that zeta potential higher than 30 millivolt or lower than minus 30 millivolt. And then we assume that these particles are suspended for the enough day. One small caution, even this much we are saying, but still we have not found any nanofluid which can be suspended for days and months. Whatever you do that, they are going to get settled after a certain time. You can use in the system, we are using continuous aggregation or something like things are happening. Next please. So this is one small thing which I want to highlight. My colleague at IIT Madras, Dr. Rishikesh Patel, he has developed this setup to measure the thermal conductivity. I have improvised it. It is based on the transient hot wire method, and by this particular instrument we have measured the conductivity, and you can see that as we have higher concentration, we are going to get a higher enhancement in the conductivity compared to temperature. Next one. Just to show the capability of this instrument, in 2000, I think 8 or 9, MIT has conducted one blind exercise. Blind exercise means they have sent blind samples to all over the world. Like in India, it came to IIT Madras, IGCAR and IIT Kharagpur and other university, they didn't tell us what are the samples. We have to just measure the properties and send the result back to them. So you just see that how good my colleague has made that particular setup. The IIT Madras one is having the least variation. It is simply in the lab made instrument which gave less than 2% error in this one, which is still no commercial instrument can give still till now. Next please. So where this talk is going, so this simply you can say that all this heat generation happens because of transistor which we use in the electronic industry, and as we are telling that from 2013 to 20 these transistors are doubling every 3 years, means more transistor means more heat generation and we need to cool it. Next please. This is another, just to give you an idea, when we have an Intel Core i7, we used to have this 60 watt per centimeter square. When i9 came, the 60 became 100 watts. A big jump in that one. And we are expecting it is going to happen for the 450 watt per. You just think that from 1 centimeter by 1 centimeter area, you are going to remove 450 watt. I mean, that seems, I mean, it's like a very difficult task, but obviously the thermal engineers are taking this challenge. This is just to show you a graph how over the year things have changed. Next please. Okay, so what we are at, so for these all things there are various cooling techniques. I have just pointed out few one. Remember, this is not all the cooling techniques. So there is something called passive cooling techniques, and then active cooling techniques, cylinder surface, thermosiphon loop, heat pipe, direct immersion cooling. Then in the active cooling, you have force liquid, spray cooling, jet impingement, thermoelectric, refrigeration one, and in the recent one, this direct liquid immersion is becoming very popular. Next one, please. So what we are going to do now, we are going to use this cooling technique of microchannel with its nano fluid, and we are going to show that how good or bad this whole technique is happening. Please, next one. So what is a heat sink? A very common example, if you use any of your desktop, you will find this heat sink which is kept over this your microprocessor, this chip, and above that sometime you don't have this fan, sometimes this fan is there which cool this one because whatever heat is being generated. So this particular thing is called the heat sink. Okay, next. So this heat sink also, they are made of mini channel, micro channel, conventional channel. What is the definition of mini channel, micro channel? We see that when the channel size is higher than 3 mm hydraulic diameter, we say it's a conventional channel like your pipe for water flow and all those things. When you go to 3 mm to 500 micron, we typically call it mini channel. And where we are going the micro channel, where we are developing a channel in the range of 200 micron to 10 micron channel. So see that. Why with this much a small size? We want to take the advantage of higher heat removal rate. We all know that from the same volume, when we have a higher area, our convection heat transfer will be higher. So what we are having from the same volume, we are having more surface area and our heat is increasing to high. Second advantage, compact inside electronic cooling. I'm going little fast because 20-minute time is there. Can be integrated directly. The best part, when the micro channel has been developed, first time they have been developed on the semiconductor industry. In 1980s, Tuckerman and Peace, they developed on the MEMS technique. So meaning is that one side you can have all electronic components, and other side you can have your so-called this micro channel. So that is the best part, and that's why this line has been added. Can be integrated directly on the heat dissipating device without any contact resistance. Then these are various type of flow arrangement which you can take in these channels to study what is the best for that one, such as I-type. I-type means you can see this one coming from this one, going from here. Then you have this then Z-type, then C-type, and then the U-type. U-type means something coming from top and then leaving from the bottom one. Next one. The application, you can see they are having 100 of applications in the micro channel. This one I have taken from some particular website only, where you can see the number of application. I think we can go ahead. Not needed. Next. So the design and structure, what we are doing here, as I told that I'm giving the general idea. Generally, how do you make this micro channel? Typically, they used to be made by micro milling, laser cutting, and electronic machining. Or recently, with the advent of this 3D manufacturing, we were able to make this channel by 3D printing also. And one more thing has come which I have not discussed, maybe next slide, the soft lithography technique, where we don't need this complicated heavy machinery and this equipment, and we use soft lithography to make those channels. Please, next. So this I will skip. This is just a process by which I used to make channel in a MEMS lab. starting from a silicon wafer, how do we do that one, and finally how do we get the channel, and it shows that what range of this surface roughness we are getting in this channel. Next please. This one I wanted to add because this is a technique which lot of people can use here. Meaning is that if you want to study on some micro channel, you can make in your lab with the cost less than 100 rupees. This is called the soft lithography, where you have something like you make a mold, put this so-called PDMS agent, leave it for 8 hours, you take it out, you got a perfect micro channel. Only problem you cannot study is for the heat transfer application. But any flow visualization, anything, any biological application, you can do it this one. So that's a big step, because when this research started, you need a lot of money. Now you are having various fabrication techniques which has brought the cost very much down. Next please. So this is just a technique how to use this PDMS technique. You make a 3D printer, use mold, then you make this mold print, put the, next please, then put the liquid on that one, this PDMS with curing agent, put in a oven, take it out, you got this, your channel ready. And then you put a glass top, use the oxygen plasma chamber, you got a very nice micro channel for whatever application you want. Next please. So when we made those micro channel, we took two things. I told you we discussed nanofluid for a over the conventional fluid, and then we made these special channels which look like a diamond shape, or you can say kaju katli. The advantage of these shapes were there. We are not only having cooling across this one, we are having this extra channel also, which were helpful for the secondary flow. And one more thing is that if you remember the fluid mechanics, there we have a concept of something called developing and developed flow. So here what you are doing that after every this depth, you are breaking the development. So your flow is almost all the time in the developing condition. Developing condition means your heat transfer coefficient will be higher for the whole channel. So two advantages we were getting, and we started exploring, okay, we want to get more benefit, add the nanofluid also in that one. We gave the name as oblique fin micro channel, and then we started using the nanofluid in that one. Next please. So you can say these are the actual fabricated one, where we use the wire radium machine and all those things to make these channels. They are of the size of 300 to 400 micron one. So you can see one is like a wavy structure with the cut one, and then this is like a diamond structure which we gave as an oblique fin. And then these are the various, fabrication methods. Here we put the heater so that we can heat this one, and this is the whole assembly on which we did the experiment. Next please. This is the whole setup, like which is having the starting the pump is there, temperature measurement is there, data acquisition system is there, heating system is there, liquid to air. So this is a closed loop where the fluid was continuously going through the circuit, and this is the schematic diagram of the whole this one where we did the experiment. Next one. This is a simulation which we did it. We wanted to show that how this extra path is helping us to get a better heat transfer. So this is a CFD one. Okay, so as a result one, this one you can see that we always know that these solid lines are the CFD result, and this solid markers are the experimental result. So you can see that even though they are not matching well, but they are giving you the trend which we want to see that. So the lower line is for the standard channels which we are having, which you open your laptop, desktop, when you open it, you will find this type of straight light of channel. And the upper line shows that the channels which we have developed, and those channels with the nanofluid. So you can see that first thing, they are getting you higher heat transfer coefficient compared to the straight channel. And when you have nanofluid with the higher concentration, even that benefit is going higher and higher. But you know that the thermal management is not only the heat transfer, it is also how much pumping power you are spending it there. So you need to also calculate the friction factor, and once you take the combination of these two, then only you can say that your system is finally better than the earlier or not. Only the heat transfer will not work for all the things. Next one. So this graph shows that, leave all those things, this shows the combination of heat and pump both. And you can see that the value is always more than 1. It is the ratio of heat transfer by the pumping power. And ratio is greater than 1 means this nanofluid based, this novel channels, they are going to give you a much advantage than the other channel, and also with the concentration they are giving you a better heat transfer, better overall performance. This first is for the heat transfer, this is for the friction, and this is the overall which we are more interested as a thermal management engineer. Next one. Then, as I told that nanofluid for thermal management, then we started using these nanofluid for the heat pipe also. You know that heat pipe recently again, it has been invented long earlier, 1960, but in last 10-15 years, it has started again gaining the attention. Why? All the satellite cooling, you can't have any other cooling technique except the heat pipe one. And then recently in Sony laptop, or in recent some of the mobile one, please go ahead, next one. I will show you this one. So, yeah, some more, please. Yeah. What exactly heat pipe is that? It works on a two-phase principle. You are having some fluid which is filled at the very low pressure, vacuum one. You give the heat, the liquid convert into the vapor, go towards other side, give the heat, and under this capillary action it comes back. So you don't have any extra mechanical equipment. That's the best part. Once you bring any mechanical equipment, your life will be lower. But in this case, for the heat pipe, they are self-sustainable if somehow you can manage the condenser part. So that's the beauty of heat pipe, and that's why they are being used in the space application. Next one. Next, leave it. Okay, these are few applications. Go ahead. This is also okay. Where they are being used actually. These are actual application of heat pipe. Go ahead. Go ahead. It's like in this one. Next. Yeah, next. This, you can see that how your heat pipe is there in the actual motherboard. This whole line is example of a heat pipe which is taking heat from the heat source and finally using this condenser one, it is dissipating one. Next one. Next. 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 I think lot of figure I have put it. Next. Next, leave it. This one was, the earlier one was the satellite control where we are using the heat pipe. This one you can see that this is again, it is from your one of the laptop where they are using this heat pipe for the cooling one. And Sony was the first laptop company which has started using this heat pipe technology. Next one. This is, you can see the same thing in the mobile, how it is being used. Nowadays you can see that mobile, you just compare 5 years back and now. How much difference has come. Now you are having mobile, which our time used to dream our desktop should have that capability, and now your mobile is having that capability. So this one you can see that a loop heat pipe is there which is being used in a mobile system to dissipate the heat. Next one. Okay, these are again the next one. But unfortunately when we used it, nanofluid for this one, it was not really a good thing. Why? What happened actually? When you use nanoparticle in the heat pipe, you can say these graphs show that we saw that every 3 months we took this photo, and we saw that over the year these particles are getting deposited on the heat pipe internal structure, and that is not really a good thing. Next one, show that. It will show you, see how the things are increasing. 6 months, next. 9 months, next. See, you can see that the whole mesh which was there, now it is totally filled with this solid, this nanoparticles. So unfortunately this was not a success. I mean, this was not giving you a good benefit using the nanofluid in the heat pipe. Next one. Okay, next. Go ahead, I think a lot of things are there. This already we have discussed that. Next. Then we use this nanofluid for the heat pipe with the anti-gravity. Anti-gravity means in the opposite direction to this one. Next one. I directly come to the result. Next. Yeah, so here also what we saw that we found that even in this case also, meaning is that heat pipe, you can work at a certain angle, 0 degree or 180 degree. We found that at any angle, we are not finding any benefit compared to your normal heat pipe. So conclusion was that in the heat pipe system, nanofluid is not really a beneficial one. Next one, please. And then this is the last thing. We wanted to do a fundamental study. This I wanted to add that because this facility we have developed with the help of this DST FIST facility. Please go ahead next. Here what we have done that, irrespective of heat pipe, all the cooling, or you can say your cooler drying, it happens through a meniscus. Meaning is that in a capillary, when you put a fluid, you will find a meniscus. And in this meniscus, there is a region from which you have a two-phase evaporation. What does it want to say that? Meaning is that whenever you have a small corner and your fluid is being evaporated, it is totally because of phenomena of thin film evaporation. So meaning is that if you want to study how a cloth drying is happening, how a heat pipe is working, or how any phenomena at a small level two-phase is happening, you need to study the thin film evaporation. So we have developed this facility to measure this thickness, because this thickness will give me the idea how good or bad the heat transfer will be there. Next please. So we have developed this setup where we are having this F40 UV, which can work on the principle of refractometry, and it can measure the thickness of this meniscus, which we get in the microchannel capillary or cloth drawing. Next one. We made this particular setup in which we put the liquid, which is making a next one, which is making that particular capillary, and you can see that with the nanofluid also we have seen that how the thickness is changing across that one. So this gives us an idea that how good or bad nanofluid will be there for the thin film evaporation. Next. This was that again, which I gave you idea that when we use the nanofluid for the heat pipe over a long time, we found that that is not really a good thing related. Here you can see that we took the image of this one, and you can see that once you use the nanofluid, how the color has changed. Means what is happening over the time, they are making a porous coating layer on your surface. So that not really is a beneficial one. Next. Yeah, so I think I took less than 20 minutes, something like that. So what I wanted to give overall picture. I didn't go in much in detail each different topic. So how nanofluid can be used for the heat sink, can be used for the heat pipe, and can be used for any like a thin film evaporation. So that's all. Thank you. And yes, any question? Could we? Yes, please. Pardon?
How much lifespan it have?
No, lifespan, it is something like that. Suppose in a lab you have made it, and when you have put enough acid in that one, then it can sustain for 3 days. But if anyone claim that he has a nanofluid for months and months, that is not possible. The nature will not allow. The physics of the fluid is that within the time it will get sedimented. When you want to use these fluids for any actual application, you have to use a system which have a continuous running and some system where you can keep these things in a suspended one. Otherwise, we will not going to get a suspended fluid for a long time. Yes. No, commercialize means like what we got sample, I told you we got some sample from the MIT. They have used a very high amount of surfactant, and this one, those samples were suspended for very long time. And suppose if they are not suspended, want to use it, before using in the application, you have to just put a sonicatin for 20 minutes. That's all. Then you can use it. Or you use a system where you have a continuous like a circulation, then they will be in the suspended condition. Otherwise, they will not be. तभी आप यूज कर सकते हो उसको. Yes, please.
What is your comment? Because day by day, always this losses is going to increase. That's why our mobile and other thing is not going to be treated up, right? So what you are thinking that in near future, where this technology is going to?
See, it is like that. Even though this, you are saying that this losses, but still you can see that now everyone is having 4 GB RAM mobile, 6 GB RAM mobile. And just think that we used to have something like 512 or even few MB of RAM in the year 2000. So this all means that what is happening at the same time, thermal engineers are also working on that one. Rather than going at the single cooling system, go at the component level, make it modular.
Like my phone, it is going to be more heated.
Yes.
And Apple is not going to be.
So Apple thing is that Apple doesn't allow you integration separately. You cannot simply open the things and you can change it. Everything is integrated. When you go to take it for the repair also, the whole things will be disintegrated and again will be combined. While all other mobile, that is personal, totally personal opinion. All other mobiles, they allow you to integration of the third party in that one. And in that way only they lose the, not only safety, they lose the basic thing. That's why we always say the Apple laptop or Apple mobile, we say that, again, I'm not commercializing. At the same time, there are a lot of problems with the Apple. But on the functioning level, what they do that they always design and fabricate everything in a single unit. While other things, what they borrow each component separately and then they do it. So sometimes the integrity issue comes.
No, my concern is where you are going to see this technology in the future.
This cooling one.
Yes.
So as I told that this heat pipe, it was ideal for the 40 years. But now I'm in the contact with the actually SAC ISRO, and they are going to, and not only SAC ISRO, I'm in the contact with the IGCAR Kalpakkam. Indian government has come with the concept modular reactor. So they are going to use the heat pipe for those modular reactor cooling. Same thing for this space cooling. You don't have any air in the space. You can only use the radiation one. So in that case, only the heat pipe is the sustainable one. And now heat pipe also they are modifying with the micro heat pipe. Like go with the micro heat pipe, go with the capillary loop pump heat pipe, go with the loop heat pipe. General heat pipe also not work. So latest one, the latest cooling one is the heat pipe one. Even though the technology was available from the 1960 when the Grover invented it. But recently now it is the most prominent one. And the another one, the day-to-day your laptop and this one cooling, the liquid immersion cooling, all the server one, whole motherboard, everything is immersed in this dielectric liquid where they are being cooled. So things are there, and the thermal engineers are also coming parallelly, and they are solving it, and that's why every day, every year we are getting an update more and more. Yeah, thank you. Thank you. Thank you very much.
Thank you, Pawan sir, for your insightful talk on how the heat pipe and heat transfer is functioning in the industry. So coming to the next invited talk, we have Dr. Murshid Imam, Assistant Professor, Department of Mechanical Engineering, IIT Patna. Dr. Imam has expertise in advanced manufacturing and material engineering, particularly friction steering welding, processing, additive manufacturing, and microstructural engineering. He earned his PhD focusing on friction steering welding of naturally aged aluminum magnesium silicon alloys from IIT Kharagpur in April 2014. Following his PhD, he served as a specially appointed researcher at the Joining and Welding Research Institute, Okasha University, from between 2014 to 2017, where he expanded his work in solid state joining, advanced characterization, and microstructure property relationship. Since joining IIT Patna in 2017, Dr. Imam has led impactful research in metal additive manufacturing, friction stir additive deposition, metal matrix, composites, high entropy alloys, and numerical modeling, with publication in premier journals including Additive Manufacturing, VR, Material Characterization, Engineering Failure Analysis, and Ceramic Internationals. He actively collaborates internationally, notably with Shandong University, China, and the University of Manchester, UK. He has successfully supervised 3 PhD graduates with additional doctoral and postgraduate researchers nearing completing his work. And is deeply committed to mentoring future researchers. Dr. Imam serves as editor of High Temperature Materials and Processes and editorial board member of Advanced Material Joining, Springer. He is frequently invited and keynote speaker at major international conferences and has led multiple national and international funded research projects supported by DRDO, SCRB, MHRD, and UK India Education and Research Initiative, UKD. Dr. Murshid Imam sir, now you may proceed with your talk. Thank you, sir.
Thank you so much. I'd like to express my sincere thanks to the organizers. Thank you for inviting me and giving me this opportunity to interact you all. So it was really a very wonderful to see you all, as we have seen that Polytechnic College is organizing international conference. So I really congratulate Sambhu and his team to really done a great job. Okay, just only one comment that since it's an international conference, so we have to be very much principle wise, we have to very much be on time, because many people come from different part of the state or outside, or even it's international conference from other country. So time management is a very crucial. So this is my suggestion to Sambhu and his team. So please take care, because many those who have the flight or have the trains, So they have to be on, those have to go on time. So that is the time management for conference is very, very important. So please take care of this. Okay, thank you. Okay, so okay, fine. Okay, so I hope I convey my message to Sambu, so please take care of this one, okay? So thank you. I'm going to talk about this metal 3D printing. And in fact, I was deeply involved with the 3D printing techniques to give lectures to training to Polytechnic colleges across Bihar. I visited different Polytechnic colleges in Bihar and I trained them. And in fact, many of you came to IT campus when there is this workshop organized by COE. So thank you for inviting me. Okay, so please. Yeah, just yeah, next slide. So these are the major content. So we would like to see what is the major trend we are seeing in the metal 3D printing, and then I will show you some interesting work. Okay, the next slide. And relevant to today's talk, you please refer to these research papers. Okay. So whatever the talk we are going to see today related to this 3D printing, you can follow these research papers. You will find all the details, because in 20 minutes I cannot go that each and every detail. So probably you can go look at the details in these papers. Next slide. Yeah, and activities is going on my research group that 3 PhD students already graduated. One, Mr. Rajneesh Mishra, is going to submit his thesis. One student, first one is in University of Science Malaysia. He's a faculty over there. 2 are doing the institute postdoctoral at ISM Dhanbad, IIT Dhanbad, and one IIT Kharagpur. Okay, and a couple of PhD students are going. We are deeply working in the selective melting of high strength materials or advanced materials, and arc-based additive manufacturing and fixed additive deposition. Okay, and we also starts doing some working on advanced material characterization that's related to high entropy alloys. Okay, next. These are the one work I would like to show you that recently Kishore Kumar has done his research in this work. So we have fabricated the advanced fluxugated composite material, where you can see that we deposited in the additive manufacturing in different layers. That is by using the fixed lab welding this approach. And you can see that we have actually have a new kind of composite material, gradient material, we have fabricated using FSM technique. Okay, next. These are the tools. Actually, we are in the process of patent. Okay, so we are trying to see that how we can inline we can deposit during the processing itself. Yeah. So in these are publications we have in the last year 2025, and I have been invited by the Institute of Materials joining Shandong University. So in fact they have paid my travel and the accommodation cost. So they have invited me to give the lectures on the 3D printings, and I have been given this responsibility of advanced material joining this genre. You are most welcome. You can submit paper if you want. Yeah. So because this arc-based additive manufacturing is actually a direct energy deposition method. Okay, 3D printing technique. So VAM is one kind of a DAD. Okay, so that's why I try to look at what is the importance of this kind of DAD 3D printing techniques. So VAM is one of the 3D printing techniques, and additionally we have this powder field mechanism also. So one of the great advantage we have that even the refractive metals we can now do the 3D printing, and that's why if you look at the recent trend that you can see that many jet engines we are particularly the refractive metal niobium hafnium alloy now can be 3D printed, which is having a high melting point material, but now it is possible, and certainly NASA and many satellites they have used this kind of 3D printing of this refractive metals now. The next slide. Next, please. The next. So what is additive manufacturing? Just I will give you some little basic, because many students are there, so probably it will be very beneficial for them. Okay, 3D printing technique is just like we have additive layers position. Okay, one of the advantage that I run this one. This is not touch screen, right? So it's just like a positive subtractive manufacturing process. Like in subtractive manufacturing process, we do the machining, we do remove the material, but in 3D printing the technique, we actually do the addition of the material. So this is just opposite to the subtractive manufacturing processes. Okay, and the main advantage that we have a weight reduction, we have many complex geometry where we can actually do the 3D printing. Okay, which is actually almost difficult by the other manufacturing techniques. Next. Yeah, you can see here that refractive material like silicon carbide, 203, tungsten, it's almost very difficult by any kind of conventional manufacturing process. But since in additive manufacturing we can use these powders, okay, so with the help of this development of this additive manufacturing, now we are in a position that we can do the 3D printing of these refractive metals. Okay, so this is actually the recent development, you can say, that now we start making use of this refractive kind of metals in the application of from the application point of view. Next. So in the DED kind of thing, let's say WAM or powder feed mechanism, one of the advantages is that you can use the coaxial nozzle, and one of the advantages that we can actually have the of new kind of material, like you can use different kind of the powder particle and you can mix in the weld pool and you can have a composite kind of that material. So this is one of the other than the process, the fabrication of materials is also possible by using this kind of the 3D printing technique. Okay, so you can see, as I told you, that this is actually project by the DRDO. Okay, in India actually we are the first one actually we have done in this particular material C103. Okay, and because of the confidentiality, because of the work, we are not allowed to show the result what we achieve from the C103. But the application point of view, if you look at, we have a lot of defense application for this particular material. So now we actually now you will see in the near future that we can start making this C103 niobium alloy in this application, in the DRD application made from this particular material. One of the advantage that even a high temperature, it has a sufficient yield strength. So that is the unique feature we have this kind of the C103 alloy. Next. Okay, so another idea about the fabrication of material, that you like WAM process, that we use the filler wire. You can see we can actually have a different composition of the filler wire, different material, and these all we can go to the melt pool and we can have a new kind of the functionally graded material. So this process we can use for the actually development of the new kind of the advanced materials, like whether it's a powder bed mechanism is there, powder feed mechanism, or whether it's a arc based additive manufacturing. Yeah, next. Okay, what is the main challenges that since all these two processes, whether it's a WAM or the powder feed DD process, they all have the liquid to solid phase transformation. So the main challenge is that we have solidification defects like cracks, porosities, internal cracks. Okay, next. Okay, can you click this video? Yeah, this is the video. So you can see this weld pool is very dynamic in nature. Okay, because you have the droplet falling on the weld pool, and this is the liquid weld pool. So this liquid weld pool, when the torch is moving, it will go in the solidification process. So you can see these are the weld pool boundary. Okay, you can see the weld pool boundary. So solidification process starts from here, because this is at the interface, liquid solid interface. Okay, so all kind of very complex microstructure formed at the interface, and so that's why this particular the cooling rate, that parameter which is dictated by the scanning speed or the torch speed of the in the WAM process actually dictates the microstructural evolution. So that's why tailoring of this kind of microstructure is very, very important in this kind of additive manufacturing technique. Next slide. Yeah, these are the issues. We can see that defects are there. Okay, these are the defects are there. Next slide. Internal defects, micro cracks. So tailoring is one of the major need that we can think to improve the mechanical properties of the material, whether it's a fatigue property, whether it's a tensile property, or any kind of corrosion properties can be improved, or tribological properties can be improved if we are work on the microstructural homogeneity or from the microstructural point of view. So that tailoring of microstructure is one of the major demand in the present situation. Next slide. Okay, so what is importance here? If you look at the science point of view, so interface is very important. Okay, now if you look at these video, so you can see the leaf and water droplet. So if you think of the leaf as a substrate material and the water droplet, okay, so that's like lotus leaf. The leaf is very smooth, so water droplet can easily move on the surface. But when you have a rough surface, then you have a contact issues. So you can see this difficult to move on the surface. So what is important here from these natural, you can see that interface is very, very important. So when you use the different powder morphology and the size, okay, and when you put inside the whirlpool, so in the interface, because this interface nucleation will take place. All kind of nucleation kinetics will take place from the interface itself, because that is the side where you can have the nucleation to start, and then it's followed by the grain growth. So that microstructural evolution or actually fundamentally depends upon the nucleation kinetics. So that interface plays a very crucial role. Okay, next. Like here, if you look at from the basic science point of view, like inside the fridge you have ice, you take a water droplet and you put the droplet on the chilled surface. What will happen? There will be a solidification process. Okay, you can see there are a lot of crystals will start growing on the surface. So this is the same situation we have in the whirlpool, that when you at the interface you have a microstructural crystal growth, nucleation followed by the crystal growth, and when you put some reinforcement particle, it will act as a nucleation sites for the kind of microstructure which see inside the whirlpool. So what is important here? This activation energy barrier. This is the driving force. This if you reduce this, the nucleation will be the faster. Okay, so this is the actually key point that we need to think of, that how we can control the activation energy, okay, by using the different size of this particular kind of the reinforcement which we use in the whirlpool, or we add in the whirlpool. Yeah. Next, just can you run this video? So you can see here, these are the interface, and here your crystals are growing, and what you see that these are the aqueous dendrites are there. Run this one. This one. Yeah. So these are the dendrites. So this we call the primary dendrite, and these are the secondary dendrites are there. So at the interface, the nucleation starts. So first you have the nucleation, then the cellular structure, then you have a primary and the secondary dendrites. So these are called the cellular dendritic kind of structure. If you have the high cooling rate, if you increase the high velocity, then these will change into the aqueous dendrites. Yeah. So these are the parameter actually which control the microstructure within the whirlpool. That G is the thermal gradient, R is the growth rate. So this product of the thermal gradient and the growth rate will give you the cooling rate, and this ratio actually give us the morphology. Okay, so the morphology changes like this, that you have a cellular, then you have the cellular dendritic, and then you have a higher cooling rate, then you will end up with the cellular kind of dendritic kind of structure, aqueous dendritic kind of structure. Okay, next. Okay, so what we have done, that first we have optimized the bead geometry, because you know in additive manufacturing we need to do it layer by layer deposition. So optimization of bead geometry is one of the important parameters. So first is that we have done the optimization of the bead geometry. Okay, next. So we have performed a number of experiments at different scanning speed by varying the torch travel speed and the wire feed speed, and we try to look at the deposition. Okay, next. we find that at this parameter we have the optimum condition where we have where the bead geometry is optimum. So we try to look, if you can look at these are the bead geometry at different parameter. We have a lot of porosity, unfilled, underfilled, but this condition is the optimum condition. Okay, so we have choose this particular parameter for the additive deposition and layer by layer deposition. Next. Yeah, we further confirm the whole this length by the surface reference measurement. Okay, so you can see this is the optimum bead we have considered in our case. Next. Yeah, so we have deposited two approach. One is the cladding, like on the surface we have clad the surface by deposit one thin layer. Another we have 40 layers. Okay, we have deposited, okay, by this process. So this we adopt the bidirectional strategy. One way you can do it in the same direction, another way you can use the bidirectional strategy. Next slide. Click this video. Okay. So these are the unidirectional. You can see the same direction we are depositing it. Next. Here you can see it's a run this one. Here you can see this is a bidirectional. You can see for this side and this side. So we adopted this bidirectional strategy because we find through simulation that bidirectional strategy is the best way to deposit because it will have less distortion. Okay. Next. Okay, so we use the bidirectional strategy to deposit these 40 layers of the additive beads, and after that we have performed two types of tunneling microstructure, one by using the fixed raster processing, another by the heat treatment techniques. Okay, so yeah, next. Okay, next. Please, yeah. So after the web deposition arc, you can see lot of dendrites are there because it's in Cornell 625. In Cornell 625, it's a solid solution hardened alloy. Okay, so these on the primary dendrites. Okay, you can see this niobium are basically segregate. Okay, you can see the primary dendrite on the secondary dendrites, and on the secondary arms we have a niobium segregates. Okay, so these actually dendrites are actually not much beneficial because it's detrimental to the mechanical properties. So what we have done first, that we have done the FSP, fixed raster processing, so that we can break these interdendrites, these phases like carbides and lab phases. Okay, so that we can improve the strength and ductility of the material. Okay. Next, you can see these are the actually TM images. Okay, you can see these are the gamma 1 prime. So main strengthening precipitates, strengthening are the gamma factor, that is nickel niobium. Okay, precipitates. So gamma 1, gamma prime are the main contributing strengthening mechanism. So if you look at these phase diagram and the triple T curve, okay, so this is the solid solubility of the niobium, around 3.5%. Okay, and this is the eutectic point. So when you have the large weight percentage of niobium, or the ratio by carbon by the niobium, you can see we have the layer phases and the carbide phases. Okay, so in this about this solid solubility, after that the solute is rejected in the liquid phase. Okay, which will lead to the layers and the carbide phases. And if you look at from this triple T curve, okay, slower cooling rate actually give you the this particular gamma double prime. There is a strengthening precipitate. Otherwise, these you will end up with the lab and the delta phases. These are the very hard phases which are detrimental to the material from the mechanical property point of view. So if we somehow we can break these phases, hard phases, or by heat treatment we can change these kind of the lab phases, okay, back to the matrix, that what we call the constant solid solution again then we can improve the property. So first one, we have done the solid state process by using the FSP after depositing the VAM. Okay, what we see, okay, next go. Yeah. Okay, next slide. Yeah, so what we see that these are phases. Now you can see this is the process region, so completely defined region. There's a great reduction of grain size. So you can imagine the grain size of around 170 micron now reduced to a 2 or 3 micron. So there is a very huge, high degree of grain refinement, and all these the lab phase and the carbide phases are now break into small pieces. Next. As a result, what happened? You can see there's a huge increase in the yield strength, almost double of the from the VAM deposited sample. So this is one of the great advantage we have, that we are able to increase the strength of the material by doing the tailoring the microstructure. Next. Yeah, next strategy we use the heat treatment. Okay, so you can see we have done the heat treatment different temperature aging actually. So at this temperature 950, with the optimum condition we have observed that both the strength and have the sufficient ductility. What happened at around 900 degrees Celsius? Okay, so these precipitates are actually get dissolved. Okay, but since we have done the heat treatment aging, okay. So there is a actually reprecipitation. Okay, there is a possibility of that one. So that is one of the reason. Another reason that thermal stability was quite good still at this temperature. But if we go to this particular temperature, 1250 or 1150, what happened? That there is a grain coarsening takes place, and all this lab phase. Okay. Will go into the solid solution. So what happened that these ductility instant decreases, but ductility has increased. Okay, so that is the case when at high temperature. So we
are running short.
Okay, fine. Yeah, please next. Okay, so next slide. Yeah, so this is the microstructure we have at around 950 degrees Celsius. Okay. You can see that in the lab space or in other nickel matrix, okay, the carbides all carbides are there, but remaining are actually the solid solution. Next. Yeah, this is at high temperature. You can clearly see the grain size has enormously increased. Okay, that is actually leading to the high ductility. Okay, and you can clearly see from these images that. All the stepping precipitates are in absence, that is dissolved. Only what we left the carbide phase. So these carbide phase are actually high thermal stability. Okay, so that is in the matrix only. Okay, next. Yeah, so these are the two major conclusions, that you can use the FSP to tailor the microstructure. Another, you can use the heat treatment strategy. So these are the two different approach completely. One is helpful for the entire sample, like bulk of the sample you can actually control, tailor the microstructure. Another by FSP you can do the surface modification. So okay, so these are the two different strategies you can actually use to tailor the microstructure, and both are beneficial depending upon the application point of view. You can make use of it. Thank you so much.
I have one quick question. You have shown that some functionally graded materials you are making, right?
Yeah.
So how you are maintaining the gradient of that particular thing while doing the painting?
Gradient? You mean, what do you mean by gradient?
I think
gradient मतलब grade ना?
stepwise or continuous, which type of gradient you are maintaining there?
See, gradient means gradient properties, right? Gradient means properties.
Yes,
okay.
Yes.
So first problem issue is that we have when we use the particle, okay, reinforcement particle. Okay, so particle size plays a very important role. Okay, and FSP is like a process where you already have inhomogeneity you already have the gradient. Like if you do a simple FSP process, you can see along the depth direction, you can see that there is a difference in the hardness value. The top hardness will be changed in the lower hardness value. Okay, so there is already a gradient. Okay, in terms of, but here what we have done. Okay, now I'm coming to your point. Okay, so what do you mean by gradient? Let me first clarify that one. First point is that, like, if we have a sharp interface, like for the case of composite material, we have a sharp interface. Okay, but here we don't have any sharp interface. Okay, so that's why we are not using the word composite. No, because in the composite generally we have a sharp interface, that one material is different from the other material. But here why we use the gradient? Because we have used a different aluminum alloys grade. Like we have used the solid solution ammonium alloy, the 5,000 series. We have used the precipitation hardened ammonium alloy. So you have the different
thickness of that particular thing which you are creating.
3 millimeter. All plate thickness was the 3 millimeter.
3 millimeter.
3 millimeter.
So every millimeter, if someone will go in radial direction, their properties is going to change.
No, like 3 millimeter, one sheet is there, another 3 millimeter, we have another sheet. Okay, and the tool pin was the around 4 millimeter. Okay, slightly larger than the sheet thickness, so that you can do the lap joint. Okay, so lap joint, when you at the interface, when you're doing it, so at the interface you have a gradient because you have the different material.
Okay, so thank you.
You got this point or not?
So I will discuss.
So because you have the different material, you are doing the lap joint, so that's why you use the gradient. Composite means you have the different interface when one material has the interface to another material. Okay, that is a composite. So there is no composite, but like a gradient kind of structure. So but that's why we call the functionally graded material, functionally graded FGM. Okay.
I will discuss.
Okay. Okay, any other question? So, coming to the next session, I'm requesting Dr. Senthil Nathan. I want to introduce him. He is online from Dubai. So, Dr. Senthil Nathan is an internationally recognized educational strategist and advisor with a career spanning over 3 decades in higher education leadership. He is renowned for his expertise in strategic planning, industry collaboration, and educational innovation, having helped shape leading institutions across the UAE, India, the USA, and beyond. Early career and education, Dr. Nathan began his professional life as a structural engineer in the United States. Following the completion of his PhD, his transition into the education sector occurred in 1990 when he was invited to the United Arab Emirates by a Canadian consulting group to assist in establishing the Higher College of Technology, HCT, which was only the second university in the UAE at the time. Leadership at Higher College of Technology, Dr. Nathan served HCT for nearly 24 years, rising through the rank from faculty member to dean, campus president, and eventually serving as a deputy vice chancellor for the final 8 years until 2014. During his tenure, he worked closely with visionary leaders like Sheikh Nahyan bin Mubarak to integrate technology into every aspect of higher education. His contribution to technological advancement in education were pioneering. He helped facilitate the importation of the personal computers from Canada before they were widely available locally, and established HCT Internet Pipeline in 1996. So it is a big biodata. So I'm welcoming Professor Nathan on to Professor Senthil Nathan on the dais, please.
Thank you. I hope you can hear me. All right. I hope you can hear me. Yeah, the audio should be clear.
Yeah.
Okay. There is another mic from Sunny Kumar, or says that's on. So if you can mute it, I think we can quickly finish this. All right. So I just want to share a little bit with you on the value and advantages of interdisciplinary degrees. Especially my focus is on postgraduate qualifications, PhD and masters. I had the fortune for the last few years to closely work with New York University, Abu Dhabi. Can somebody please mute Sunny Kumar? Yeah, thank you. All right. So I had the fortune, and I continue to help New York University, Abu Dhabi, which is world ranked in 25 or something like that, in all their postgraduate programs. So all of them are interdisciplinary programs. So can we go to the next slide, please? Yeah. So I will quickly explain for those who may not be familiar what interdisciplinary is typically used to describe degree programs that provide postgraduate training across the traditional disciplinary boundaries. It could be two or more fields combining, and essentially you're trying to solve a problem which needs more than one area, and sometimes it even crosses the boundary from engineering, social science, mathematics, physics, pure sciences, all this. And one second, let me just. Okay. Okay. So this is the definition. I think in my screen I have a problem. I can't. Okay. So this is a definition: interdisciplinary studies as an approach to education, research, and problem solving. They actually break down typical boundaries in universities between academic fields. For example, civil engineers don't talk to mechanical engineers don't talk to computer science. Those are the boundaries. But in these programs, it encourages collaboration and integration of knowledge from different areas, and actually competencies and skill sets as well. So this is the reason is it's to understand complex issues and to help the graduate students, postgraduate students, with the knowledge and skills needed for complex jobs in STEM and the humanities. Okay, next slide, please. I'm going to give you a few examples so you'll understand. These are some of the interdisciplinary postgraduate programs that are offered in the world famous MIT, Massachusetts Institute of Technology, which is probably number 1 or 2 in engineering and technology in the world. And you can see from the definition, there are a lot of traditional programs where computation becomes very critical in the PhD or scientific doctorate program, and they name it like that. And environmental engineering, for example, by itself, an interdisciplinary program, and then you add computation to that. So it's like that. And the health sciences, when I say health sciences, even if you forget medical studies for a minute, today in health sciences, the technology is playing a huge role, especially in research, but even in application. Increasingly, doctors, nurses, bioengineers, they're all gathering together to solve the human health condition. So you can see many programs around the world where health science come up with integrated PhDs and master's program. Okay. Next slide, please. So the philosophy is actually behind. There are many ideas behind interdisciplinary programs in the world. Some of them are undergraduate level. It's giving a lot of freedom to students just students make up a lot of courses here and there and they want a degree. I am not talking about those. I don't know if the students at the undergraduate level really understand what they want in when they finish. So the the interdisciplinary programs, graduate programs I'm talking about, they are well designed, well thought by faculty and with the help of the industry. And the philosophy behind this is many problems in real life, in industry, in research and development, wherever you go, they rarely fit within a single discipline, within a narrow area of research. It typically in real life, it requires a multifaceted approach. So, so the real world application is very important, and it's a project-based learning, whether it's a master's or PhD. If you look at these problems, sustainability, global health, or social inequality, you cannot solve it just by one little area. And also, here students are trained to use frameworks and concepts from different disciplines. For example, if you are if you come from an engineering background, you know how to solve problems. But if you go into social sciences or health science, there are gray areas, there are ethical considerations. These are not something typical engineering students understand. But in real life, you have to bring these concepts and frameworks to solve a problem. It's actually looking at the same problem through different lenses. Then our solution will be broader, as well as there will be a deeper understanding. And the complexity of issues, that's important, because the way you design interdisciplinary master's or PhD programs, it's to prepare these graduates for complex jobs that demand the integration of knowledge from many different areas to solve a social need or a business need. Okay, so the idea of this interdisciplinary program is not just to give freedom to the students just to explore, but actually give students freedom to give them power to build the skill sets they need to actually effectively solve a particular problem without thinking about whether it is fitting within my department view or my thesis advisor, whether what he thinks. We are focused on the solving the problem. Let's go to the next slide. And it's all wonderful to talk about this, but actually, practically, designing a program like that, there are practical challenges. Now, the challenge is really not from the industry or the business. They really welcome interdisciplinary. We talk to hundreds of leaders, business leaders around the world. Most of them welcome this kind of interdisciplinary graduates. They want multi-skilled employees. But the challenge is in the academia, in the research universities. Because typically in the research universities, you have departments they really built on, we call them ivory towers. They build walls around them. Actually, they are in different buildings. And for two or more departments and specialized research teams, first of all, they have to collaborate really to design the curriculum and then deliver it to their PhD or master students with a clear focus on student success, not their own success. So the territorial fight is a common problem in universities. And the second challenge is if the students complete the interdisciplinary PhD, okay, when they want to join a university to become a postdoctoral or a faculty member or an assistant professor, typically departments, they are structured in departments. So if I say I have computing and mechanical engineering PhD, the universities sometimes get confused. Should I take this person in mechanical or computing? So they may not be very clear. So the one of the things we have seen, until universities actually become very clear and they change themselves.
Sorry, sir. Sorry to interrupt you.
Actually, we are running short of time. I'm requesting you to wind up in 2 minutes. Okay, thank you.
All right, no. So we will, until the universities reframe or reform, then it's a problem. Yeah, let's go to the next slide and I'll stop there. So I was going to give you a couple of examples, what we helped with the New York University, astrophysics, which is a abstract program, and space systems, which is an engineering skill. We have helped them launch. Now it is running for the betterment of the space industry. Okay, I will stop here. Yeah, it's okay. Let's stop. Yeah.
Thank you.
Okay, thank you very much. And if you need any more, I think this presentation may be available. Okay.
Okay, we'll stop.
Yeah. Okay.
Thank you, sir.
Coming to the last session. Now this is the last session, I hope so. Sambuji, last session, na? Second last session of today's invited speaker. Now I'm requesting Professor Parimal Acharji. He is a professor there in Electrical Engineering Department at NIT Durgapur. He has done his PhD in Electrical Engineering from Jadavpur University. And he is working as a professor in NIT Durgapur from 2007 to up to till date. Previously, he served at NIT Silchar, BP Poddar Institute of Management and Technology, and different other institutions. He has published more than 150 papers in different reputed international journals like Elsevier, Springer's, and all. He has also undertaken several sponsors projects that is funded by DST, CSIR, and different other agencies. He has also undertaken different industrial consultancy from different organizations like SCADA and electrical and different more. He is recognized as a fellow of IET UK, fellow of IE India, ISTE, senior member of IEEE USA. Now I'm requesting he is also having several administrative responsibilities, like he is acting as a Dean Alumni Affairs, Head Center of Advanced Research and Energy, and also laboratory in charge of different laboratories. Now I'm requesting Professor Parimal Acharji on the dais, please. Thank you.
Hello, very good afternoon to all of you, and I want to convey my profound gratitude and thankfulness to the organizing team. Okay, I will tell about the smart grid. Do you have slides? Okay, so actually I don't want to tell in depth regarding the smart grid research part. Generally, I want to give here for the awareness of smart grid, because our government of India, they are trying a lot to implement smart grid in our country, but they are facing different kind of constraints and complexity to implement smart grid in our country. Okay, because we common people don't have the मैं तो वहाँ पे जो बैठा था ना उसको भी दिया था वो वाला एक और जो
व्हाट्सएप पे जो आपने दिखा अच्छा ये तो सोच कर ये है सर क्या जो वहाँ पे बैठा था जिसका कंप्यूटर में मैं कनेक्ट किया है तो वो आपको भेजा नहीं तो उसका गलती है आशीष आशीष
Forget about the PPT slides. Whatever I will tell, that is the general knowledge regarding the smart grid, not related to the research. So there is no need regarding that type of slides or like this. So we can continue without slides. When slides will be prepared there, they will show it, then I will proceed. But actually what I want to say to all of you, when I take interview, then most of the students, they tell about the smart grid wrongly. Their concept was wrong. Generally they tell that it is a smart electrical grid, but smart grid is not the smart electrical grid or smart intelligent electrical grid. Actually it is nothing but the modern automated advanced power system. So power system subset is electrical grid. Now we are talking about the vast area of the power system. Now when we tell about the power system, then generally there we have generation, then transmission, then distribution. So you have to generate the power, further generation is there. You need to transmit the power because we are the consumer, we are the customer. You have to supply the electricity here, so obviously you have to transmit it. So transmission system is also there, and you have to distribute to us consumer, so distribution system is also there. So there are three parts, and in theory class your teacher generally tell about these three parts: generation, transmission and distribution. Practically when we are talking about the smart grid, we have to include consumer also. What is our demand? What is our requirement? How will be satisfied? Generally the service provider should know, and accordingly they need to provide, isn't it? So actually the consumer was not included in case of that power system, and we did not study about that also. But in case of the smart grid, that consumer satisfaction, consumer requirement, it is included. So what we can tell, that smart grid is not related to the electrical grid. Generally I need to tell in brief regarding the electrical grid. Generally you are generating the power. So from the generating station we are getting the power. There will be one node. Think about the one node, it is taking that power, and obviously it will transmit that power to all of us, maintaining the frequency and voltage generally. Okay, so it is one subset of the power system. Okay, but when we talk about the smart grid, generally we have to think that it is related to the our modern power system, automated advanced power system, which also includes consumer in addition to generation, transmission and the distribution system. Now here in case sound aa raha hai here, hello हेलो, वहां से हो रहा है क्या? क्या we can I can use microphone also, ये cordless microphone also I can use. सर हो गया? हाँ, हमिंग आ रहे थे. ठीक है. I think it is audible to all of you. Now when I am talking about the smart grid implementation, and first we have to know what is smart grid. If we want to if we know about the smart grid features, then we come to know about the constraints and complexity regarding the implementation of the smart grid in our country. Now here for the smart again, you can give that microphone. The next slide please. Okay, now the first one already I have explained. The next one it is telling that we have to use the intelligent measuring system. Now we have the system already. We have SCADA, supervisory control and data acquisition system, isn't it? And through this we can supervise and monitor. But nowadays we are using the advanced measuring instrument, which is known as the PMU, phasor measurement unit. And using this phasor measurement unit, we can get the synchronized, accurate, fast data. Actually, this data is synchronized through the GPS, and because our substation station transmission that is 400 kilometer long, so at different place we have to get the data at the same time, same instant. Otherwise whatever our analysis that will be wrong. So here actually we are talking about the digitalized advanced measuring instrument. By that we can monitor. If monitor is correct, then our analysis prediction that will be correct. From that we come to know about there will be a prediction of the fault. There will be fault or not. If we predict that fault, we can disconnect the line earlier and we can save our costly equipment, isn't it? And if there is a fault also, we can go for the self-healing, means that it will automatically disconnect, and whatever the new system we have, that we can get, and we can analysis, and that will be stable system. So we can enhance the stability when we are talking about the smart grid. So here whatever the points it is mentioned, here also mentioned that we have to go for the customer satisfaction. As a consumer, I want to make it interactive session. As a customer, suppose you are consuming that electricity, that power. As a consumer, as a customer, what is your requirement? Tell me. What is your requirement? You are consuming the power at home, at institute, everywhere you are consuming the power. So as a consumer, what should be your requirement? What is your requirement? Cheap rate. Cheap rate. That is one part. Any other? The equipment work with the full potential. What does it mean? Means that your voltage and frequency should be maintained. If voltage is fluctuating in nature or frequency is fluctuating in nature, then equipment will not work properly. Number one, measuring instrument will give the wrong measurement. Sophisticated instrument may get damage, isn't it? So that is your requirement. Not only that, another one is there that is related to the certain technical part, that is harmonics. Okay, multiple integer of the fundamental frequency. We have the fundamental frequency. I think that all of you know the fundamental frequency. क्या है fundamental frequency? यहाँ का जो electricity है उसका तो एक frequency है, sinusoidal wave है. If it is sinusoidal wave, then obviously it should have frequency. What is its frequency, fundamental frequency? 50 Hz, very good. Obviously in this country, if we go to USA, then it is 60 Hz. Good. That is the different one. And there generally we supply that approximately 25 kV. Okay. So that is different. Okay. Now, in general, whatever we are consuming at home or institute, that is obviously 50 Hz. If it is multiple frequency, it is included, then harmonics is there, noise will be there. So our sophisticated instrument may get damaged, and durability of the instrument equipment, obviously that will be less. Durability means longevity. Okay. Another part is that continuity of service. Generally we talk about. Suppose we are getting the supply. Okay. Now it is cut. Load curtailment is there. It is off. So what will happen? Now we are running a very good international conference. Okay, so it will be stopped. So continuity of service also our requirement, our demand. We don't know. Nowadays actually we are getting the continuity of supply because we have the energy, power. So, but earlier in rural remote area, generally we don't get power supply. In the evening, what happened that we have low voltage or no power. Generally we observed it, but nowadays it is improved, most of the cases. Okay, Now the point is that this type of power quality generally we expect and we want. So this kind of power quality generally consumer wants. Continuity of service, voltage should not be fluctuate in nature, so it will be stable one. So that generally we can give through the smart kit. So here for the consumer and the service provider, there will be bidirectional information flow. How it will be done? Through the smart meter. I think that all of you heard about the smart meter. Now you are using the electronic energy meter at home. Okay, now we are now introducing the smart meter. If you go to the IIT Kanpur, you will observe it. You can see in most of the certain areas. Generally, we have already introduced and installed the smart meter as a AMI, automatic metering instrument. In this feature, we have added it. What will happen that whatever the information, that information will come. Suppose there will be load shedding, that information will come through the smart meter to your mobile, and whatever your demand, your requirement also you can give. And generally there are two types of tariff will be introduced. Now in case of mobile, what type of SIM you may use? Two types of SIM. Now your mobile is prepaid or postpaid? Most of the cases it is prepaid. Okay, so but we have the two options, that is prepaid and postpaid. Now in generally what generally we pay, that is in pre-post manner or prepaid or postpaid manner? Prepaid, is it?
Yes, sir.
No, that is I am not talking about the mobile. Now I am talking about the when you want to give the bill submission. Okay, you will go for the payment for your bill. So it is in prepaid manner or postpaid manner. Electricity bill I am talking about, not the mobile bill payment. Postpaid, that is it, postpaid. Now it is in prepaid manner also in case of the electricity. Good. Okay, that's a very nice opportunity for me that already prepaid, postpaid, both options are there. Okay, but in West Bengal, what is that? So how much unit we have spent, depending on that, straightforward per unit cost will be multiplied, and maybe there is a one fixed cost that is related to the meter rent. Okay, so means that it is a static tariff, means that suppose per unit cost is 10, you have consumed 100 unit, means 100 into 10, 1000 you have to pay approximately. If you add the other fixed cost, that you can add. Okay, but dynamic tariff is different. Dynamic tariff, what is that? Per day the tariff will be different, because we know about the peak load and lightly loaded system. Peak load means that our load demand is high. Most of the cases, generally in the evening, we observe the high load demand. That is known as technically it is called the peak load demand. Okay. Now at midnight, most of the cases we are not using the appliances. We are sleeping. So in that case, at midnight, it is lightly loaded. But we can't stop our generator or alternator here. We have to run it. So during the midnight, when it is lightly loaded, we can encourage our consumer that you can use your appliances. Okay, because the tariff will be low. So during the time, if tariff is low, you will use this one. On the contrary, during the peak load, tariff will be high, means that per unit cost is high. Suppose instead of 10 it will be 20. That means we are indirectly discouraging you that you don't use your non-essential items. What is non-essential items? Washing machine, geyser, mixer, those are the non-essential items. Means that you during that peak load demand, when tariff is high, please don't use it. On other time you will use it, isn't it? So in this way we can manage. So that load management is also coming in picture when we talk about the smart kit. Okay, now another will come in picture. Whatever the equipment, instrument will use, that will be standardized. Suppose now sir is telling that in USA when you will go, the frequency will be 60 Hz. Okay, now here is 50 Hz. There is also another change. Now whatever laptop you have, now if you want to charge your battery, that you will use the 3-pin plug here, but you can't use that plug point there in USA, isn't it? So here, there are only 2 pins there. Okay, so you have to use advanced adapter. Okay, so that adapter, if you use that, you can do. In Europe also it is different. So the plug point settings, just if we are talking about that, it is different, means that it is not standardized one throughout the world, but we want to make it, the equipment whatever it is, that should be standardized. So I can purchase those equipment from anywhere. Okay, so that means that competition will come in picture, marketization will be better, isn't it? So that is actually included in the smart grid. Okay, so next slide please. Here actually the first part is already given, mentioned what it is, that is given that 3 main parts of the smart grid. One is transforming the grid, means that we are technically advanced regarding the grid, isn't it? So here first it is written knowing exactly where a power outage occurs and instantly dispatching a crew to fix the problem. Earlier what happened, now I am not talking about the present scenario, but earlier what happened that if there is a fault, what we will do, that we will first send our electrician just check that where fault occurs. What we have. Hello. Okay, now first we send the electrician, you go where is the fault occurs, then you check that what type of fault it is, then you come and take the equipment and fix it. So it takes longer time. Nowadays using the ANN, what we will get that where fault occurs. Okay, what exact location of the fault we can get, not only that, what type of fault, that is classification of the fault we can get. Okay, so advancement it is done using the AI, artificial intelligence we can get it, using the software algorithm we can get it. Okay, now it is telling about the advancement. Okay, so whatever we have the old equipment, we have to replace it and we have to use the digitalized equipment. Suppose we have the electromechanical relay, now we will use the analog relay, digitalized relay. Okay. So that is the point. So here what is that, the marketization, economic growth will come in picture, because when we will introduce the smart grid, what will happen that there will be a lot of impact on our society as well as economic. Let me explain. Suppose OEM, original equipment manufacturer, they will be grow and they will manufacture the new equipment, advanced equipment, digitalized equipment. So they need engineers. Okay, so job employability, that will increase. Startup project will increase. Okay, entrepreneurship will increase. So trading will be there. So a lot of business will come in picture. Okay, so socio-economic development will observe if more and more smart grid, if it is implemented everywhere in our country. Okay, so that is related to the socio-economic, but technical development will be there. Here another point is that empowering the consumer, it is also true. Complete. Okay, so that is the part. Now another point, actually main important point, I forget that I will tell, and after that I will conclude. That is renewable energy integration we have to use when we are talking about the smart grid implementation. Okay. Now when we are going for the smart grid implementation, renewable energy, more and more renewable energy we have to introduce, because if we go for the renewable energy, then what will happen that pollution, we know about the thermal power plant, that fossil fuel we use, and pollution day by day it is increasing. So if we go for the renewable energy, that it is pollution free, obviously environment friendly, eco friendly. Okay, so pollution will be less. Another point I want to add, that generally our country they are facing a lot of challenges and complexity to implement is because the common people, they don't know about the smart grid and new tariff system and other advanced system. Okay, so being an engineer, please inform that about the smart grid and smart grid implementation so that they come to know about the smart grid, and if common people knows, so it will be helpful for our government bureaucrats that they can implement the smart grid in our country. Thank you. Thanks a lot.
Thank you, sir.
Very nice talk.
Okay, good afternoon to all of you. My name is Sumit Gupta. I am from BHU. Under the supervision of Dr. Avdesh Kumar, he is from MMB BHU. My title is Attention Guided Bidirectional Convo LSTM Unit for Missing Video Frame Reconstruction. In this work, we are presenting the work that in a video there is a consecutive frames or number of frames. If there is a chance, if there is a missing some frame, then it leads to reconstruct the problem that there is a certain things that has to be reconstructed in the missing frames. Okay, so this in this work we will use the bidirectional convolutional LSTM unit for
video missing frame. Next. These are the outline that we will discuss throughout this presentation. Next. As for I have told you that the video data is widely used in the many real world applications. In practical scenario, video sequences suffers some sequence missing, like storage error or compression errors or artifacts. There is a certain reason there is a loss of some frames. Missing frame break the temporal continuity of videos and significantly degrade the performance of the downstream tasks such as motion analysis, object tracking, and activity recognition. There is a need of some robust technique that has to reconstruct this missing frame in an efficient manner. Next. These are the literature review that we work throughout this work. Some of them uses some traditional methods. Some of them uses the deep learning. Like in the traditional method, someone using the optical flow, Gaussian mixture models, and they try to reconstruct the missing, but they suffer the temporal and some spatial issues. In order to resolve the spatial issues, many researchers use the deep learning technique to extract the useful information. But they focus on only to the spatial features, not the temporal reasons that they are consisting with some motion patterns. So, in order to this review of this literature, we combine some traditional methods and the deep learning technique to reconstruct the frames in a video. Next. So these are the points that we are doing we are doing the research on this. Some motivations like the traditional method, like what the basically traditional reconstruction struggles basically on the large motion, occlusion, complex background. Then after that, many deep learning models are proposed. And some unit architecture also used to reconstruct, but unit is also only for the spatial features, not for the reconstruction. It is only for the sometimes has been used in the long ago for the medical segmentation. But the researcher uses some hybrid technique to incorporate the unit. But the use of the unit with some traditional method like optical flow or some methods give these some computationally suffer. Okay, that's why we use these certain like techniques that Congo LSTM that uses the temporal and the unit extract the spatial information. In that with the combination of this we reconstruct the missing frame. Right. Next. The methodology. In order to this, we are doing the sequence of steps that to reconstruct the frames. First, we process the videos into the certain frames, then extract. Normally, missing of a frame in a video that can occur due to certain failures or some transmission errors. But intentionally, in this research, we extract the number of frames and intentionally we delete some frame at the random position. That's just like example that in a video there's a 50 frames and we intentionally delete certain frames and then kept them as a blank and put at full black. Means there is a temporal discontinuity in a frames. Back. Next. We use the unit decoder and decoder network in order to extract the information from the images. Next. This is the pipeline that we have used in order to reconstruct the frame. First, we take the input sequence of images, then pass to the biconvolutional LSTM. Then, after extracting the overall temporal features, information,
from the image that in which part there is a motion because in a video there is a motions which contribute the temporal continuity. So in order to maintain, we use the biconvolutional system to extract the temporal information. Then after extracting the temporal information, we pass the unit, and in that unit we use as a convolution and max pooling in order to extract the information. But if you directly use the unit in this work, then it contains some background noise. So in order to reduce the background noise, we use a attention mechanism. In attention mechanism, we suppress the background and focus on that region where only the motion pattern is highlighted. Next, these are the algorithms that we have done throughout the this work. Next, in this work we have explained the how the model is working. Next. These are the experimental results. These are the basically ablution method. First we test the LSTM plus unit, then we test the bidirectional convolutional unit without attention mechanism, and in this work we use a biconvolutional LSTM plus attention unit. In all the three, we get the best performance. 38.79 PSNR, SSI value 0.9923, and the MSE which is very lowest in the case of the convolution LSTM with the attention unit. And this result we test on a UCF 101 dataset. UCF 101 dataset is a very action recognition dataset which is used in the computer vision task. Next. These are the results that we compare the our result through some recent works, and we have cited the number of their citation of papers in the footer. From this result, it is clear that our result is surpasses the other methods, and it is very efficient for the reconstruction method for a frame in a video. These are the qualitative analysis that we have taken one single frame and we have deleted, and after that you can see that the visual representation of my proposed work is how much looked it like. Next, these are the continuation results. This is the learning curve throughout the learning stage of the model. Both the training and validation loses, decreases smoothly and stabilize, showing the effective convergence of the model. The closely aligned curve indicate robustness generalizes without overfitting. Next. After that, the conclusion part is that the attention mechanism significantly reduces pixel level errors. Bidirectional temporal modeling improves the motion consistency. The PSNR, the SSIM value, and the lowest 0.000013 indicate that this result is somehow some better through some other state of art method. These are the references, and thank you.
So, anyone have questions? So, one basic question like how much it is feasible in realistic manner, where we can implement this algorithm?
In every scenario, if we are working on a video, there's a certain frames in every frame, and there's a chance of the loss of it. So in order to reconstruct, there's a need of some method that we can use to extract the information and reconstruct the overall video and to make the consistency in the videos. Okay, thank you.
Thank you so much. Next.
Vishwa Vijay Pratap.
Yes.
Good evening, respected dignitaries, researchers, and my fellow participants. My name is Vishwa Vijay Pratap from Government Polytechnic Bar. Today I'm very honored to present my work. It's on digital transformation of Indian civil structure, implementation of construction 4.0, and digital twin framework. As India is moving towards more digital India, we have always approached for the traditional approach of construction. We have never moved towards more modern or data-driven construction industry. Next slide. Yeah, yes, sir. Hajpur English Bar. So at the ground level, there's always at the ground level, there's always based on a traditional approach. We are facing the cost overruns, traditional delays, and the issue of sustainability. So the solution lies in a digital twin. Digital twin means whatever is in a physical asset or whatever in a physical form can be represented in a digital way, which can continuously monitor its health and continuously share the data. It's based on a bi-directional flow. Before we deal this topic of why we are going for a digital twin and why should we move towards a digital twin, there's some problem lies in construction industries regarding the manual approach, which is not very automated. There's a high incidence of delays, critical work. Next slide. So traditional approach has always been a reactive, not predictive. We are not able to predict what will happen in our structures. We are always used to, it happens and then we react. So this is always a reactive approach, not a predictive approach. There's always a manual process in it. We haven't now with the digital twin, with the construction 4.0, which is the engineering counterpart of industry 4.0, we will be able to convert all the manual process into our automated systems. With a static system like BIM, which is following in the industry right now, building information modeling, which is a static data of a static picture, it will be changed into dynamic. Whatever will be the condition in the physical, it will be represented in a digital form. And the fragmented data silos. What happens? Different departments hold different data. They don't share the data. With the implementation of construction 4.0, we'll have an integrated ecosystem. So as we can see, this is a building information modeling, which is a traditional practice in the construction right now, which tells about all the things in a static manner. It can be seen as like we have a picture, which is very detailed picture. It tells you everything, but it doesn't tell for it's a short-term approach, but it's not a long-term approach. One will have a digital twin, which is continuously sharing data with each other, which connected in the form of a digital thread. We can share data and we can update any changes or any failures, or we can predict any anomalies, any failures which is going to happen in the building. So as you can see, digital twin is just not a 3D model. It is a continuous synchronized data with a physical asset connected with a digital thread. Digital thread has a 4 part. One is data collection. We collect data through sensors. Temperature sensors are there, vibration sensors are there. There are sensors who can predict the cracks, who can see the cracks,
and there is a strain sensors are there. Then we collect data from there. Then we put it in your data fusion. Data fusion is like whatever unstructured data are coming or data coming from the different sensors. We can fuse it. We can correct the noises over there. Then we'll put through simulations. Then we'll predict with the machine learning. We can predict. We can simulate using BIM and AI. Through we can predict what next could happen. What next building can happen. What cracks can develop in 6 months, or any changes going to happen in the building. We are going to analyze it. So next thing. Next. So we have proposed a framework which works on a 3 framework. Press the button, please. More. There's a physical layer. Physical layer represents the physical, whatever the physical structure is there, which is connected through the sensors. All the sensors are connected to the physical building. We'll share the data, and we'll try to analyze the data through geometric BIM or finite element analysis models. Or very different models are there, which can analyze the data which are receiving through the IoT sensors, Internet of Things sensors connected. Then we'll go to analytics layer, where we can predict data. We can predict any changes going to happen in the building in the future, or any changes is happening, or the load condition has changed. We can predict that data through the deep learning method. And from there, we'll have an interaction layers. As a human, or the person who doesn't have a knowledge of backend, or who doesn't have a knowledge of how the LLM models are working, we have to have an interactive user face, which is user friendly. We can interact. The engineers can interact. Whatever the changes is happening, they can see in their dashboard. That's the interaction layers. Next thing. It adds a value creation to different infrastructure lifecycle, like for shape optimization, like even the progress monitoring of your site construction happening. Then there's a smart cities. You can have a optimized urban infrastructure planning, and you can also fulfill your sustainable development goals. But before we move to our the work of digital twin, we faced like there's a social technical barrier exists in the construction industry, because people have an attitude that they don't tend to change. They don't easily adapt any changes. So there's a very resistance of change. There's a fear among people. If we'll bring any changes, our work will get slow. Cost will get overrun. So they don't try to adapt new technologies like digital twin. Then they have an unrealistic expectation. Whenever we think of any digital changes, people think there's going to have some magic going to happen. But it should be implemented in very smaller projects. Then it should be moved towards the more larger projects. Then there's a data silos. Every department holds different data. They do not share data with each other. That leads to the project. That leads to the wrong decision making in the projects. That's why when we have an integrated system like digital twin, over there the data can be shared with each other. It can be solved. Interoperability standards should be made in the industry or even the construction projects. Next. Then there's a 5-pillar strategy we have developed, through which we can move towards our traditional approach to construction 4.0, to move towards more a digital twin framework. So the first one is Gemini principle. Then there's a orchestration. Then there's a people enablement. Then process re-engineering, and then there's a data centricity. Next slide. The first Gemini principle talks about, it's been written for the Center for Digital Build Britain. This principle has been taken from there, and it has become a very standard practice for all worldwide. The Gemini principle talks about when we are going to implement digital twin, whether it serves a purpose for public good or not, whether it's creating any value for public. Then there's a trust, whether the platform is secure or not, because we are sharing a data. Even for very sensitive data like bridges,
We cannot share data. It should be secure data. We cannot share in a public domain. So it should have a very strong security system. Then there should be open source based. It should not be in a closed source system. It should be based on open sources, and there's a function. Whether it will have to lead to development or evolution of that industry or not, we have to focus on that. Then there's the orchestration. The change comes from the top management. So the top role, the people who are in the top role, needs to bring the changes. So we are talking about orchestration, like they need to align their projects or their whatever the projects or whatever the functioning of the industry in that fashion that they are going to bring the changes of digital twin. Next. Then there's a people enablement. Without giving a proper skills or without a proper providing an interactive layer or proper interactive user interface layers, we cannot able to guide people. The interface should be in such a way that every people who do not have very strong knowledge can easily go through all the data, whatever the data has been received and whatever the prediction is predicting. Then there is a process engineering. For this, we'll need to revamp whole workflow. Whatever the workflow is working in for your industry or any sector, it needs to have a revamp workflow which will be data driven. Which all things will be data driven. All the decisions will be go through data. Then there's a data centricity. The construction 4 is all about data. What kind of data we are receiving, whether the data is continuous. We do not have any noise data. We do not have a lot of noises in the data. So we need to blend the static and dynamic part data to eliminate the silos. Next slide. Then we hope that in the future this more people will start talking about digital twin, because it will just does not serve purpose for security. It also serves as a guidance for industry 4.0. Next. Then some key players to implement this digital twins are the policy makers. Then there's an industry leader, and then it should go to the researchers, who is going to continuously bring the new changes in the digital twin for India. These are the key references. Thank you. Any questions?
Thank you for the insightful lecture.
Thank you.
So, anyone have a question?
Sir, that this the entire paper is not it is in the help of AI. The entire civil projects will be under the AI, will be following the AI.
No, sir. The AI tools will be only for your whatever the data we are getting.
I will say that the entire projects will be controlled by AI. Just that data within 6 months about the failure of the structures will be identified.
Yes, sir.
If suppose the substructure is identified after 6 months, what are the remedies for that? The substructure is identified after 6 months.
So still we are, as we haven't in India, we haven't moved towards this model. So we haven't tested it in a big projects. Still it's working in our smaller projects. We are still focusing in how smaller projects is going to react, what data we are receiving right now. We do not have any very clear idea what will happen in 6 months. We will be able to see for smaller projects whether it's giving us a good data about any failures or any cracks developing in the building. Then only we will be able to say what kind of things will happen in the future.
That's a very good idea. But the substructure is okay.
Yes, sir.
As far as the substructure is concerned, that has to be identified. How will we identify and what are the remedies for that?
So for substructure, we haven't focused yet. As we do not have any, because below the ground, we do not have access to it. So only we can understand right now it's of superstructure. So, but it's a very nice question from your side. We will definitely look into this substructure. Thank you, sir.
10 मिनट खत्म हो जाएगा। आप तैयार
Cube satellite tour. Good evening, all of you, respected sir and ma'am, and all the guests present here. My name is Sahil Kumar. I am presented here the design and implementation of ESP32 based cube satellite.
Excuse me, I request
Educational and agriculture application.
I request everyone kindly pay attention to the speaker. Thank you. Go ahead.
नेक्स्ट स्लाइड। पहले हम कंटेंट में बात करेंगे कि इंट्रोडक्शन, क्यूब सैटेलाइट होते क्या हैं और इसके हिस्ट्री के बारे में जानेंगे, और बहुत सारे लेखक लिटरेचर रिव्यू में जो बहुत सारे लेखक पहले दे चुके हैं, उसके बाद उसके जो प्रॉब्लम आया था उसको सोल्यूशन कैसे करेंगे, फिर उसके बाद ये जो क्यूब सैटेलाइट बनाया गया उसका प्रॉब्लम क्या क्या आ रहा है, फिर क्या करेंगे कि उस प्रोजेक्ट का ऑब्जेक्टिव क्या है, की कंपोनेंट के बारे में जानेंगे कि इस क्यूब सैटेलाइट का जो हम इन्वेंशन किए हैं उसमें कौन से कंपोनेंट का यूज किया गया है, फिर क्यूब सैटेलाइट के वर्किंग के बारे में जानेंगे, फिर रिजल्ट एंड डिस्कशन, इसका रिजल्ट कैसा आता है, इन कंक्लूजन का बात करेंगे, फिर फ्यूचर वर्क, इसके आगे क्या कर सकते हैं क्यूब सैटेलाइट में। नेक्स्ट स्लाइड। जैसे जैसे हम जानते हैं कि इलेक्ट्रॉनिक्स का एडवांस होते जा रहा है, वैसे वैसे सैटेलाइट क्या हो रहा है, सिंप्लीफाइड हो रहे हैं और छोटे हो रहे हैं। क्यूब सैटेलाइट बहुत ही स्मॉल होते हैं और इसका सबसे ज़्यादा यूज रिसर्च एजुकेशन में करते हैं। बात करें एक स्टैंडर्ड क्यूब साइट की, तो 1 यू क्यूब साइट 10 × 10 सेंटीमीटर का होता है, और अगर 2 यू क्यूब साइट की बात करते हैं तो 10 × 10 20 सेंटीमीटर होता है, जिसमें 10 क्या होता है कि 10 लेंथ होता है और 10 विड्थ होता है, हाइट क्या होता है 20 हो जाता है। लार्जर क्यूब साइट की बात करते हैं तो लार्जर क्यूब साइट 12 यू का होते हैं, और इस 1 यू क्यूब साइट का वेट 1.2 kg के अप्रोक्स होता है। ये जो प्रोजेक्ट डेवलप किया गया ESP32 बेस्ड क्यूब साइट प्रोटोटाइप है, जो ग्राउंड लेवल टेस्टिंग के लिए अवेलेबल है। इसमें बहुत सारे सेंसर का इंटीग्रेट किया गया, जीपीएस लगाया गया, अर्थ इमेजिनरी के लिए इमेजिंग के लिए लगाया गया एक ESP32 कैम। फिर इसमें जानेंगे कि पावर मैनेजमेंट कैसे किया जाता है, क्योंकि सबसे ज़्यादा चैलेंज जो आता है क्यूब सैटेलाइट में वो पावर मैनेजमेंट का आता है। अगर पावर मैनेजमेंट थोड़ा सा भी ज़्यादा हो जाता है तो क्या होगा, माइक्रो कंट्रोलर पूरी तरह से डैमेज हो जाएगा। और कम्युनिकेशन के लिए एक LoRa SX1278 मॉड्यूल लगाया गया, जो क्या करेगा 10 से 15 किलोमीटर तक ये कम्युनिकेट करेगा। एनवायरमेंटल सपोर्ट के लिए और एग्रीकल्चर एप्लीकेशन, डाइजेस्टर मैनेजमेंट में हम इसका यूज कर सकते हैं। नेक्स्ट स्लाइड। 1999 में कैलिफोर्निया पॉलिटेक्निक और स्टैनफोर्ड यूनिवर्सिटी ने क्यूबसाइट के बारे में बताएं, जो इंट्रोड्यूस किए थे कि क्यूबसाइट आखिर में बनाया कैसे जाता है। फिर 1999 में क्या हुआ था कि इसका कोई फिक्स साइज नहीं था। फिर 2000 में क्या किया गया, इसका फिक्स साइज किया गया, क्योंकि हम जानते हैं कि अगर मान लीजिए हम किसी सेफ कंटेनर से हम शिप से कंटेनर को भेज रहे हैं, तो ये तो पता होगा कि मेरे को कितना शिप से जो कितना कंटेनर भेजा जा सकता है। तो इसी प्रकार से इससे क्या हो गया कि निर्धारित होने से ये पता चल जाता है कि कितना हम क्यूब सैटेलाइट एक बार में भेज सकते हैं। फिर 2003 में फर्स्ट क्यूबसाइट लॉन्च किया गया, जो सक्सेसफुली हुआ था। फिर 2010 में क्या हुआ कि एक ग्लोबल प्रोपरेटी के लिए एफोर्डेबिलिटी हुआ, सिंप्लीफाई किए, फिर सुटेबिलिटी हुआ। IIT बम्बई ने 2016 में इसरो के साथ मिलकर इनसाइट जिसका नाम था, और ये पार्था क्यूब सैटेलाइट को लॉन्च किए थे। अभी प्रेजेंट डे में क्यूबसाइट का सबसे ज़्यादा यूज होता है वर्ल्ड वाइड में एजुकेशनल के लिए, अर्थ ऑब्जर्वेशन, जो पहले बता चुके हैं। नेक्स्ट स्लाइड। कैलिफोर्निया पॉलिटेक्निक के एंड
के जो प्रोफेसर थे 1999 में क्यूबसेट के कॉन्सेप्ट दिए, जिसमें क्यूबसेट को इंट्रोड्यूस किया गया। फिर नैनो सैटेलाइट के बारे में भी बताया गया था। हार्नेट एल ने 2011 में एजुकेशनल पर्पज से क्यूबसेट को एक्सप्लेन किए थे रिसर्च में। वोल्ट E8L ने ओपन सोर्स सिस्टम के बारे में बताया कि जो इलेक्ट्रॉनिक्स कंपोनेंट बहुत सारे ओपन सोर्स होते हैं, उसका यूज करके हम कैसे क्यूबसेट को डेवलपमेंट कर सकते हैं। सेमटेक एक कंपनी है जो क्या करता है, लोरा मॉड्यूल बनाता है। जो 2021 में लोरा मॉड्यूल बनाया गया था, लोरा वैन, वो 10 से 15 किलोमीटर तक लॉन्ग रेंज के लिए था और लो पावर कम्युनिकेशन के लिए लो पावर चाहिए था। टाइजन ETL ने 2018 में पावर मैनेजमेंट को दिया, जो एक थ्योरेटिकल पार्ट था। गोमेज ETL ने सेंसर और ESP32 का जो बेस्ट क्यूबसेट बनाया था, इन्वायरमेंटल एंड डाटा कलेक्शन के लिए बनाया गया था। लिटरेचर गैप में जानेंगे कि पहले जो वर्क किया गया वो एग्जिटिंग वर्क में आएगा और इसके बीच में क्या गैप आइडेंटिफाई किया गया, उसका सोल्यूशन कैसे हुआ, कैसे सोल्यूशन हम किए। तो एग्जिटिंग वर्क में ये जो था रियल और वाइटल क्यूबसेट मिशन के लिए था। और ये क्या है कि लिमिटेड जो हम गैप आइडेंटिफाई किए, ये लिमिटेड लो कॉस्ट ग्राउंड सिमुलेशन मॉडल है और एक ग्राउंड वर्स्ट क्यूबसेट प्रोटोटाइप है। पहले जो ऑथर लिखे थे आर्डिनो रास्पबेरी पाई का पार्टली यूज किए थे, बट ये जो ESP32 रियली यूज होता वो भी ऑनबोर्ड कंप्यूटर में। ESP32 ऑनबोर्ड कंप्यूटर का हम यूज किए, ठीक है। लोरा मोस्टली यूज IoT लिमिटेड क्यूबसेट टेलीमेट्री यूज के लिए किया गया था। लोरा जो है लोरा वो बेस्ट लॉन्ग रेंज टेलीमेट्री है। थ्योरेटिकल पावर सिस्टम को बताएं, थ्योरेटिकल पावर सिस्टम को बताएं। जो पहले के लेकर थे वो थ्योरेटिकल पावर सिस्टम को बताएं, बट ये क्या था, प्रैक्टिकल पावर सिस्टम था जिसमें यूज किया गया TP4056 चार्जिंग मॉड्यूल और एक ESP32 मॉड्यूल का, जो पावर मैनेजमेंट को दिखाता है। नेक्स्ट स्लाइड। इसमें जो प्रॉब्लम था कि ये बहुत ही सिस्टम क्या होता था, वेरी एक्सपेंसिव होता था और ये बहुत सस्ता नहीं होता था, इसमें खर्चा आता था। क्यों? क्योंकि ये जानते हैं कि क्यूब सैटेलाइट बहुत महंगे होते हैं और हम किसी को महंगे सैटेलाइट को हम दे नहीं सकते किसी को चेक करने के लिए या किसी को बनाने के लिए, इसीलिए इसका यूज किए क्योंकि ये बहुत सस्ते होते हैं और ये जस्ट क्यूब सैटेलाइट की तरह ही वर्क करते हैं और इसको अगर चाहेंगे तो स्पेस में भी भेज सकते हैं। फर्स्ट इसका जो ये बहुत ही कॉस्टली कंपोनेंट का यूज करते थे। ये क्या था कि रिलायबल लॉन्ग डिस्टेंस के लिए कम्युनिकेशन के लिए था। डाटा ट्रांसमिशन इमेंस चैलेंज, बहुत सारे चैलेंज आते थे डाटा को ट्रांसमिशन करने में, कहीं कहीं इंटरफेरेंस आ जाते थे डाटा में। और क्यूबसेट जो थे चिप नहीं होते थे ये जो, बट ये क्या कि ये चिप सैटेलाइट हैं, बहुत ही सस्ते हैं। जो पहले एक्सप्लेन कर चुके हैं कि ये लो कॉस्ट होते हैं। ESP32 का माइक्रो कंट्रोलर का यूज किया गया था। ये इंटीग्रेट सब सिस्टम था जो पावर मैनेजमेंट, सेंसिंग, GPS इमेजिंग के लिए यूज किया गया था। ये जो लॉन्ग रेंज लो पावर कम्युनिकेशन लोरा टेक्नोलॉजी के यूज करते हैं और ये प्रैक्टिकल सारे होते हैं। नेक्स्ट, इसमें पावर सिस्टम EPS में जो यूज किया गया, एक 3.7 वोल्ट का लिथियम आयन बैटरी यूज किया गया। सोलर पैनल इसलिए यूज किए हैं क्योंकि अगर मान के चलिए हम स्पेस में भेजते हैं तो वहाँ पे चार्जिंग के लिए कोई सिस्टम नहीं होगा, तो क्या होगा कि सोलर से वो सन, जितने भी सन पावर से हैं सोलर सिस्टम से वो चार्ज होंगे और पावर डिस्ट्रीब्यूट होगा सर्किट में। ऑन बोर्ड कंप्यूटर में ESP32 माइक्रो कंट्रोलर का जो क्या करेगा, वो सारे डाटा को कलेक्ट करेगा और जैसे ही कलेक्ट करके वो ESP32 मॉड्यूल से लोरा SX1278 को डिस्ट्रीब्यूट कर देगा और डिस्ट्रीब्यूट करता है अर्थ ग्राउंड स्टेशन को। एटीट्यूड डिटर्मिनेशन एंड कंट्रोल, ये सेंसर, बहुत सारे सेंसर लगे रहेंगे जिसमें टेम्परेचर सेंसर बताएगा, ह्यूमिडिटी बताएंगे, प्रेशर बताएगा और GPS बताएगा कि क्यूब सैटेलाइट कहाँ पे है। फिर पिक्चर के लिए हम ESP32 कैम का यूज किया। जो लोरा मॉड्यूल लगा रहेगा ये ऑनबोर्ड कंप्यूटर के ये ऊपर में लगा रहेगा और ये लोरा मॉड्यूल कनेक्ट होगा एक एंटीना के थ्रू। ओबीसी रहेगा जिसका ESP32 का ये पूरे ओबीसी मैन्युफैक्चरिंग होगा। ADCS में बहुत सारे सेंसर लगे रहेंगे। ESP32 का क्या करेगा, इमेज को कैप्चर करेगा और सोलर पैनल बैटरी को चार्ज करेगा, एंटीना के थ्रू सेंड कर देगा। क्यूबसाइट के आर्किटेक्चर की बात करते हैं तो क्यूबसाइट के आर्किटेक्चर दो भागों में बांटे हैं क्योंकि इसको समझने के लिए आसान कर देते हैं। पहला होता है मैकेनिकल फैब्रिकेशन। तो मैकेनिकल फैब्रिकेशन में क्यू सैटेलाइट को हम कैसे डिजाइन करेंगे, फिर असेंबल कैसे करेंगे, सिमुलेशन कैसे करेंगे, फिर एवोनिक्स में हम सर्किट के बारे में जानते हैं कि सर्किट डिजाइन कैसे करेंगे, ट्रांसमिशन रिसेप्शन कैसे होगा, पीसीबी डिजाइन कैसे करेंगे, एंटीना को कैसे डिजाइन करेंगे, ये उसमें दिया हुआ। पावर मैनेजमेंट के एक रेगुलेटर सप्लाई देते हैं एमसी को, क्योंकि जानते हैं कि एमसीयू किसी फिक्स वोल्टेज पे वर्क करता है, अगर उससे ज़्यादा हम वोल्टेज देंगे तो वो डैमेज हो सकता है। कंट्रोल यूनिट के लिए SP32 का यूज किया गया। सेंसर नेटवर्क एनवायरमेंटल एंड मोशन सेंसर जैसे रहेंगे। वायरलेस RF लेग के थ्रू ग्राउंड स्टेशन से कम्युनिकेट होगा। और स्टोरेज के लिए अगर मान के चलिए किसी समय से मेरा वो सिग्नल ट्रांसफ़र नहीं होता है तो क्या करेगा कि वो सिग्नल ट्रांसफ़र तो नहीं होगा, तो उस समय सिग्नल क्या करेगा, स्टोर करके रख देगा, और जैसे उसके नेटवर्क से कम्युनिकेट होगा तो क्या करेगा, सेंड कर देगा। बात करते हैं पावर सप्लाई की। तो पावर सप्लाई जैसे ही देंगे क्या होगा कि SP32 मॉड्यूल ऑन हो जाएगा। ये क्या है, GPS मॉड्यूल है जो क्या बताएगा कि क्यूब साइट का ट्रैक करके बताएगा कि क्यूब साइट है कहाँ पे, मतलब एल्टीट्यूड में बताएगा, लॉन्गिट्यूड में। BMP280 सेंसर है जो क्या BMP280 प्रेशर को मेजर करेगा। MP6050 फिर LM35 टेम्परेचर सेंसर टेम्परेचर को मेजर करेगा कि इन्वायरमेंट में टेम्परेचर कैसा है। 13 सेंसर ये बताएगा कि गैस कैसा है, जैसे कार्बन डाइऑक्साइड कितना है वायु में, या सल्फ्यूरिक गैस कैसा है। DHT सेंसर क्या करेगा कि DHT सेंसर ये ह्यूमिडिटी को मेजर करेगा। IR और सेंसर अगर उसके सामने कोई ऑब्जेक्ट तो नहीं आ रहा है तो अगर ऑब्जेक्ट आएगा तो एक मैग्नेट टॉर्क लगा रहता है क्यूब साइड में, जो क्या करेगा कि मैग्नेट टॉर्क लगने से उसमें अगर मान के चलिए मेरा जो अर्थ है बहुत ही ज़्यादा मैग्नेटिक फील्ड है, अगर उसमें थोड़ा सा भी चेंज होगा तो क्यूब साइड का अपना ट्रैक चेंज कर लेगा मैग्नेट टॉर्क के कारण। और कैमरा से क्या लेंगे कि एक इमेज लेंगे जो अर्थ इमेजिनरी के लिए यूज करेंगे। ये ट्रांसमीटर है, क्या करेगा कि ये जैसे ये डाटा का प्रोसेसिंग करेगा, डाटा का प्रोसेस होने के बाद डाटा को ट्रांसमिट करेगा। ट्रांसमीटर के थ्रू डाटा को ट्रांसमिट कर दिया तो यहाँ पे एक रिसीवर के लिए लोरा SX1278 पे लगा रहेगा, और एक माइक्रो कंट्रोलर जो क्या करेगा डाटा को वो रिसीव करेगा, और रिसीव करके हम क्या करेंगे डिस्प्ले पे या लैपटॉप पे हम देखेंगे। लास्ट ईयर रिजल्ट के डिस्कशन के बाद ये क्या करेगा, सक्सेसफुली कंट्रोल करेगा डाटा एक्विजिशन थ्रू SP32 मॉड्यूल के साथ। और ये बहुत ही कॉम्पैक्ट होता है, बहुत ही छोटा होता है, पावर इफिशिएंट होता है, ये सुटेबल है एजुकेशनल मिशन के लिए। GPS के लिए हम क्या करेंगे कि GPS एक्यूरेट डाटा पोजीशन देगा क्यूब साइट का। SP32 को क्या करेगा, डिलीवर करेगा इमेज को पॉकेट के फॉर्म में। लोरा कम्युनिकेशन जो है 10 से 50 किलोमीटर तक ओपन इन्वायरमेंटल में सक्सेसफुली कम्युनिकेट करता है। ये क्या है कि ये इन्वायरमेंटल और मॉनिटरिंग के लिए, एग्रीकल्चर एप्लीकेशन के लिए एप्लीकेबल है और ये प्रूव कर चुके हैं। ये वेदर एनालिसिस से परफेक्टली डन हो चुका है, और ये अर्थ इमेजिनिंग करता है। अर्थ इमेजिनिंग इसलिए जरूरी है क्योंकि बहुत सारी इंडस्ट्री में खोजते हैं। गुड रिलायबल कम्युनिकेशन इन्वायरमेंटल कंडीशन सक्सेसफुली कर चुके हैं, और एग्रीकल्चर मॉनिटरिंग पूरी तरह से डन हो चुका है। इसके आगे के लिए जो क्या कर सकते हैं कि EI से हम उसको एनालाइज कर सकते हैं, उसमें फॉल्ट क्यूब साइट के फॉल्ट जो डाटा भेज रहे हैं उसमें क्या फॉल्ट डिटेक्शन आ रहा है। मान के चलिए कोई एक्यूरेट डाटा नहीं देता तो उसको फॉल्ट डिटेक्शन मेजर कर सकते हैं। इसमें बहुत सारे सोलर पैनल को लगाएंगे जो लॉन्गर ऑपरेशन के लिए, जैसे ये जो क्यूब सेट हैं वो 2 इयर्स इसका मैक्सिमम ऑपरेशनल लाइफ होता है, उसके बाद ये पूरी तरह से डैमेज हो जाते हैं। और ये बहुत सस्ता है, तकरीबन 6 से 7 हज़ार में बन चुका है। रिफ्रेश। Thank you for.
So,
thank you, sir.
Do we have any questions?
सर है ज्वाइन है क्या?
Sir, we are audible.
सर वी आर ऑडिबल. अजय सर. Received his PhD in the field of advanced manufacturing and automation, and he has received his BTech in mechanical engineering and MTech in manufacturing and automation. He is listed among the world top 2% of research scientists in the list published by Stanford University and Elsevier in 2024-25. He has H index of 31 and more than 3100 citation on Scopus profile. He is a book series editor in CRC Press and Elsevier. His area of research include smart materials, advanced manufacturing, incremental seed forming, sustainable materials, additive manufacturing, Industry 4.0 and optimization techniques. He has over 250 publications in international journals of repute, including Scopus, Web of Science, and SCI Index database, and referred international conferences. He has organized various national and international events. So with this short introduction, because your introduction is very large, so with this short introduction, I welcome you, sir, and now the dice is for you.
Thank you very much. And first of all, I congratulate the committee of First International Conference on Advanced Trends in Engineering and Emerging Technologies, ICATET-2026, for organizing such a wonderful conference and for arranging such a intellectual gathering. And in line, I think, as Professor Sahu has mentioned, it is the last session, and everyone has listened so much since morning. So I will not take much of your time. I will present. I will try to present very shortly, and let me share the screen. Is my screen visible to you?
Yes.
I hope screen is visible to everyone.
Yes, yes.
Yes.
So let's discuss the topic which nowadays everyone is talking about: additive manufacturing and 3D printing. So recently, our group has evaluated the performance and optimized some process parameters in FDM-based 3D printing. So everyone knows what additive manufacturing or 3D printing is. It is a rapid prototyping process which makes the components layer by layer by deposition of the material, and the process is arranged by the digital data in the form of STL file made by CAD geometry, and we can make any complex geometry and shape with minimum efforts, and it is highly customized process to make the customized items And one of the major advantage of additive manufacturing is it can make any complex geometry with precision. And in this process, it is very important to identify the ideal values of the input parameters, and so on. We have to optimize the response factors, and by for doing this, we have to use some optimization methods like single objective optimizations and multi-objective optimizations, and some of the times we use some machine learning and artificial intelligence techniques or soft computing techniques. Although several statistical techniques and algorithm types, including design of experiments and meta-heuristics algorithms, are employed for the optimizations, and some output like tensile tests, compression test, wear test, hardness test, and some chemical tests are also explored for optimizing the output for some certain applications, like for biomedical applications, for aerospace applications, for in the field of sensors and actuators. So we have to optimize and find the optimal value of the input factors, and we have to identify and we have to calculate or employ some governing equations for the output. So some of the literature review has already been explored on this technique, and in which several materials like mild steel, carbon fiber reinforced thermoplastic, biodegradable PLA for stenting applications in medical, polylactic acid for some particular applications, PMMA and PETG, and carbon composites, carbon fiber, glass fiber, a lot of polymer or and even elastomers like TPU or TPE, thermoplastic elastomers, have also been explored in this field. And recently, people have tried some applications of bilayering or multi-layering, in which uh, researchers are trying to uh, uh, make bonding of two different materials like PLA and TPU, who has similar kind of polymer matrix for their bonding purpose, and they can serve the some very critical and state of the art applications, uh, in which single any particular thermoplastic polymers are not suitable, like glass fiber and carbon fiber are also mixed to serve some particular applications, where strength to weight ratio is very critical, like in aircraft cabin designing and cabin manufacturing, dashboard of the car, and as I mentioned, some particular polymer sensors, where elasticity is the key. So by that way, some stiff material and some very soft material like TPU or TPE can be blended to make the applications served. And in the same way, several modern techniques are also being implemented by the researchers, like RSM, Taguchi, and SVM sport vector machine, regression methods, some particular hybrid techniques like NFIS, where in an artificial neural network and fuzzy are interfaced with, with each other, and they are made hybrid further by fusion of machine learning technique in NFIS. And some researchers are also using nature inspired techniques like WSO, white shark WO, gray wolf optimization, so and so techniques are blended with machine learning techniques, so that they give the accurate models rather than techniques like RSM and Taguchi. And people note some particular response like surface roughness, tensile strength, flexural strength, and thickness, and other mechanical and chemical properties of the material. And uh, so recently, our students and our group has optimized the process parameters of TPE material that I mentioned, that is thermoplastic elastomer. It is very elastic graded material, and we evaluated hardness according to ASTM standards and tensile strength as well for ASTM standard. and ASTM D2020-40 were the sample type, and for tensile strength it was D3638 type 4 standard. So we identified significant process parameters and their best corresponding levels based on comprehensive literature review pertaining to FDM based 3D printing, and we studied mechanical properties and chemical properties as well. But here in this presentation, I have only included mechanical properties, hardness, and tensile strength. And then we designed and implemented approximate experimental plan for selected process parameter and their levels. Then we determined optimal value of input parameters using RSM technologies, and later we also optimized the process and predicted the value using machine learning technique, and then we compared the result of machine learning technique and other nature inspired technique, making biomaterial or multi-material. Also we are trying to make some particular auxetic structures for biomedical applications and for some sensor applications. So specifically in this study, mechanical characterizations of thermoplastic elastomer has been explored, and for since it is very soft material, so Shore hardness has to be calculated, and then it was optimized using RSM study. Later, same tensile strength was also evaluated and it was optimized using this method. So process parameters: nozzle temperature, print speed, retraction distance, bed temperature, and flow rate, which are very critical and significant. As we determined from literature review, they have been investigated in this study. Later, we optimized the process parameters. So, a methodology of 3D printing or FDM-based additive manufacturing involves we have to determine the object. We have already the shape of the object as per ASTM standard. Then we designed the CAD model in the CAD software. Then we have to convert the CAD model into STL file for generating G code for 3D printing. Then the other part is to the 3D printer, and where 3D printed process has fabricated the specimen, and later the sometimes we need to post process the specimen for testing applications. And as I mentioned, UTM was used for tensile strength, and Shore hardness tester was used for determining tensile test. Later we applied statistical model, and then we optimized the method. So this was the printer which was used for fabricating the specimen, which is shown here is specimen of hardness or measuring hardness. And this was the fixed process parameters. The maximum nozzle temperature, filament diameter was 1.75 mm, and this was the lever height, infill density, and infill pattern was the grid type. So this is the experimental setup for measuring hardness, and this was the UTM of 10 kN capacity, which was used for measuring the tensile strength. And this was the specimen, 3D printed material specimen for hardness. And if we talk about the RSM technique, so there are two particular method to design the experiments. One is CCD and one is BBD. So here we have chosen BBD design, boxed Banken design for response surface methodology to set the number of runs for the experiments. And as I mentioned, RSM is very traditional and famous technique for designing the experiments. And box Banken design is one of the great feature of this technique. And in the study, each factor had three level, and we had chosen the extreme points of each three levels. So these were the input parameters which were optimized and explored for TPE, thermoplastic elastomer. Nozzle temperature was chosen 230, 240, and 250 mm. because printer itself has some certain limitation of setting the nozzle temperature as per its capacity, and another limitation is relates to the material, because every material has some, or polymer has some certain boiling or melting temperature, not boiling, melting temperature. So according to melting temperature, we have to set these parameter. Print speed, we can optimize it and we can take it minimum to maximum as per the capacity of machine. So here we have chosen 20 as minimum and 60 as maximum. Retraction rate makes a lot of difference and it has not been explored in literature, so it has been taken as a parameter. Let's see what will be the impact of retraction distance. Similarly, bed temperature has also impact. It has more great impact in when it comes to elastomers, and similarly flow rate of the material through the nozzle. So these were the designing strategy. So according to these number of parameters and their levels, so 45 experiments has to be conducted according to RSM methods, and this is the strategy, entire strategy setting of the parameters, and the results are produced for hardness. Here we can see for hardness as well as for tensile strength, the values were given, and what we interpreted from the analysis. So we implemented RSM and later we conducted ANOVA. So according to hardness, the Pareto graph was generated for, let's discuss for hardness, which is Shore type. The Pareto, which is showing that hardness, the results are, linear here, and it also shows that significant factor for hardness is the print speed as mentioned, and which is followed by nozzle temperature, then retraction distance, then flow rate, and minimum impact is from bed temperature. Square and non-linear terms were also given in the graph, and which shows that significant effect are there, such as print speed. Similarly, residual plots were also calculated, and which shows that hardness consists of four types of plots. In the normal probability plots, the scattering is near the reference line, which shows the adequacy of the study, that our results are very much robust and adequate. In residual versus observation order plot, it is seen here, there is no pattern, no significant pattern observed between the points which state the relevancy of the study. The histogram, if we take the histogram shows the symmetry, and the residual versus fit shows the scattering is near zero, which indicate constant variance. So it is completely normal, nothing abnormal has been observed. That means our results and the values given by the machines and test is according to ASTM standard, and tests are conducted under ideal conditions. So this is the contour plot for hardness. The contour plot, which consists all the input factors versus the result, which is in this case is hardness Shore. The contour of hardness versus flow rate, retraction distance, and hardness versus flow rate. Temperature shows the variation of hardness as the gradually increase and decrease on the basis of flow rate, as well as retraction distance and bed temperature. And in this plot, hardness versus flow rate and print speed is one of the significant contour among the plot. That means print speed and flow rate is giving more impact to the hardness rather than other three parameters. And the surface plot shows the average of the hardness versus all the input factors. The surface plot of hardness versus flow rate, print speed shows the peak, which indicates the high value of the Shore hardness. The hardness versus bed temperature, nozzle temperature and hardness versus retraction distance. Nozzle temperature graph shows the lowest peak, which indicates the minimum value of hardness, which is considered as a significant result of this study. And in the same way, the results are given. And later we conducted ANOVA for hardness. So ANOVA table states that p value and f value of the parameters which are used to find the significant factor for hardness. That means according to from p value and from f value we can determine which factor is significant and how much significant it is. So here print speed was determined as the most significant factor as p value of print speed is less than 0.05. In this and in ANOVA, in this analysis, the parameters having print speed having p value less than 0.05 are considered significant, and the values having more than 0.05 are considered less significant or non-significant. Similarly, if there are two factors which has the same value, same p value, then the significance of the parameter is considered or is determined by the corresponding f value. So maximum the f value is, more the significance of that parameter is. For example, if print speed and retraction rate has same p value, then we have to see that which factor is having more f value. So greater the f value is, more the significant the parameter is. So r square value is also significant, and later regression equation of was generated for hardness. This equation means that we can calculate the hardness for TPE material using this equation for any nozzle temperature, for any print speed, for any retraction rate, for any bed temperature, and for any flow rate using the particular equation. And similarly, this is the Pareto of the tensile strength, and same the residual plot of the tensile strength. And this is contour plot of tensile strength for all input factors. And here it is determined that stress versus print speed and nozzle temperature shows the minimum variation of the tensile strength, and it is less significant. In this contour plot, we can determine that stress versus flow rate nozzle temperature is one of the significant contour among the plot. So one of the beauty of contour plots are they give us interactions of the parameters. So for example, which combination of two parameter is more prominent with the output, rather than calculating the significance in from the perspective of single parameter with the output. And similarly, this is the tensile strength, which shows us that retraction rate, retraction distance, print speed, and stress versus flow rate, nozzle temperature shows the peak, which indicates the high value of tensile strength. That means nozzle temperature shows the peaks. The stress versus bed temperature, nozzle temperature, and so on gives the lowest peak, which indicates the minimum value of tensile strength. Now, what is the use of these analysis? For the particular material and for these particular parameter, we don't need to do hit and trial method for experimentation. We can generate the regression equation as previous it was generated for hardness, and here it is for tensile strength or stress. So by using this regression equation, we can theoretically calculate the value of tensile strength, and we can see that which temperature sorry which parameter is more significant and what their ranking is. For example, the most significant parameter, let's say, is nozzle temperature, followed by print speed, retraction distance, bed temperature, and then flow rate. So this is the beauty of this statistically analysis, which are robust and powerful tool for determining the value of output based on based on the limited experimental test we can theoretically calculate. And without taking much time, let's discuss the conclusion. So in this study, we investigated Shore hardness and tensile strength for thermoplastic elastomer, that is TPE, for Eason company, and using FDM 3D printing. And the study utilized 45 runs using BBD design from RSM. And print speed was the most dominant factor increasing speed gradually decreased hardness, and increasing speed gradually increases strength. Both the models summarises state that acceptance and adequacy of the study based on R square value and R square adjusted values, and they are under their statistically significance. Square value was 78.24%, and the model's poor adjusted value was 60%. So significant lack of fit is also under promising under considerable limit, which render it for precise optimizations. The Pareto graph of the hardness shows the print speed is the most significant factor, followed by nozzle temperature, retraction distance, flow rate, and bed temperature. This is the conclusion of the tensile strength. Print speed was the most dominant factor, increasing speed gradually, increasing the tensile strength. Both the models summarize states the acceptance and adequacy of the study is given by particular R square value, and lack of it is also under precise optimization. So future work can be more focused towards the retraction distance in this study was 4 to 5 mm, and this defines moment of nozzles. So we can get the more value of retraction distance. Similarly, more other parameters can be optimized, and based on the same analysis, so some more particular where the same is giving critical results, so we can conduct more results, more experiment, and can more explore in the same. And we can also explore towards bilayer material, by layering of the materials, and towards making auxetic structures. So in our current study, we are exploring some auxetic structures for medical, biomedical, stenting, and some sensing applications. Thank you very much. If there is any question.
Thank you, Ajay sir. Now if any, now session is open for the questions. कोई क्वेश्चन है तो पूछ लीजिए.
Sir, your R square is 0.78, so it is just clear for which, sir? Your R square is very low for in your calculation I have seen, and adjusted R square is also low. So, is it?
Sorry?
R squared value is very less. Can you give the reason for that?
See, R square value depends on the number of parameters and their levels and number of experiments. So having R square value less doesn't mean that the study has some limitations. Rather, it gives us some chance, and it gives us some scope for performing more experiments, and to calculate the regression equations again using some more technique, like it depends on the tool, and it is statistical analysis. So for getting a higher R square value, so we need to optimize the process using some more accurate and more data oriented technique, like soft computing techniques, nature inspired techniques, which is more suitable for such and such analysis. So having R square value greater or less is not going is not making your research more impactful or less impactful. So I have seen many studies where R square values are claimed near 100%, and in some papers R square value is mentioned 100%. So which practically does not give us that the study is much accurate.
Thank you so much, Ajay sir, for giving your valuable time and insight towards your experimental study as well as their analysis. And I hope that you will also support this particular conference in the form of publications and all. And thank you so much. Thank you so much, sir.
Yeah, thank you again, and thank you for giving me opportunity, especially Professor R.K. Sahu and Dr. Shambhu, and thank you very much for organizing such a wonderful program again. and I give you best wishes for tomorrow program. Best wishes. Thank you
you,
very
sir.
much.
Thank you.
Respected dignitaries, all senior faculties and all present here, good evening to all. Myself Rohit Kumar, lecturer in Civil Engineering branch. This paper which I am going to present is just an integration of two different simultaneous work, which is on soil strength regarding the stabilization of soil, which has been done by two different admixtures. One is beta glucan and another is xanthan gum. Both the admixtures are polysaccharides, which are natural materials, which is again which will be again environmental friendly material for soil stabilization. This paper, which is on development of model to predict strength behavior of soil biopolymer mix, is just integration. One different work is on soil mixed with xanthan gum and one on soil mixed with beta glucan, and both the work has been simultaneously both work has been presented here with a proper integration of both the work to predict a model regarding the different percentage of admixture to be used to get the further strength of the soil, which we can predict by just putting the percentage of the admixture to be used for soil strength. Three types of here is taken. One is compaction effect of the soil, and other strength behavior has been checked by CBR and UCS, unconfined compressive strength test and CBR values. So soil stabilization is can be done by different methods. There are mechanical method also, some chemical methods are also. But one significant change which are we are seeing now, that soil stabilization done by different types of chemical and mechanical stabilization which we do, which create some environmental effect, which disturb our environment, which is not in good interest for sustainable development. So this there is alternative for soil stabilization by biopolymers, which are environment friendly materials, which is seen in this experiment. Next. Both material xanthan gum and beta glucan, which is used in the experiment. For doing this, we have just taken a soil near Muzaffarpur, alluvial soil was there, so which has been mixed by different percentage of admixtures. Firstly, virgin soil is mixed with 0.5% of xanthan gum, then 1%, then 1.5%. Simultaneously, same virgin soil has been mixed with 0.5% of beta glucan, 1% of beta glucan and 1.5% of beta glucan. Both the test was conducted simultaneously, compaction effect test, some OMC and MDD, and CBR test and UCS test. All tests were compared. Here we can see optimum moisture contained and maximum dry density for both the material. The orange one is for beta glucan plus clay, and blue one is for xanthan gum and clay. Next. Here also unconfined compressive strength test for mixed with beta glucan and xanthan gum. This both admixture gives little bit of similar effect on the virgin soil regarding the strength and compaction behavior. But it has been seen that on percentage 1.5, both the material give best effect. After when we increase the percentage further, at 2%. When we check for 2%, the strength behavior slightly, the curve decreases. So optimum content for both the material xanthan gum and beta glucan is found to be 1.5%. Next, then soaked CBR and unsoaked CBR was conducted. Next, the curve, orange curve is for beta glucan plus virgin soil, and blue curve is for CBR and virgin soil. Next, here when the soil is mixed with xanthan gum, the maximum dry density with 1.5% of xanthan gum is slightly higher than virgin soil mixed with beta glucan, and in soaked CBR, the beta glucan plus virgin soil effect is greater than the virgin soil with xanthan gum. And also for UCS same, the beta glucan and virgin soil effect, the strength behave increase more than virgin soil plus xanthan gum. When we compare the both for analysis in Excel, this predicting the model, a straight line curve was taken, and then both the constants were found with a regressive model analysis in Excel. R square value was given to be this. Next. In the implementation of this, one major issue which we have identified, that time-based analysis to be done on both xanthan gum and beta glucan, as these are biodegradable materials. So it may happen that in further due course, after 10 year, 20 year, it may happen that it get degraded, or the strength behavior which it is showing in 28 days or 7 days, it might get reduced. So that time effect for more time, it should be further checked for the proper application in the field. Thank you.
Thank you, sir, for the wonderful talk. So if anyone has questions, kindly ask, or we can discuss over the team. Thank you. Thank you.
थैंक यू एवरीवन। आप लोगों ने बहुत पेशेंटली हम लोग सुना, इसके लिए धन्यवाद। अभी 6 बजे तक 5 बजने वाले हैं, लोग कॉन्स्टेंटली जो है 6 बजने वाले हैं, सॉरी, है ना। तो आप लोग कॉन्स्टेंटली सुना, इसके लिए बहुत बहुत धन्यवाद। और मैं चाहता हूँ, आप लोग से रिक्वेस्ट करता हूँ, कल भी इसी तरह से आप लोग अपना धैर्य बनाए रखें। थैंक यू ऑल। मैं सभी डिग्नेटरी को धन्यवाद कहता हूं कि आप लोग जो है अपने बहुमूल्य समय निकाल करके यहाँ पे आए और हम लोग को ग्रेस किए। थैंक यू साहू सर, थैंक यू एवरीवन, थैंक यू। अब मैं इस सेशन को क्लोज करने का देता हूँ। थैंक यू।